welcome. So we're going to start a new topic which is called Laplace transformation. This comes under ODE, that is comes under ordinary differential equations, right? This is one of the very easiest topic, so we finish this topic very quickly so that we will have more clarity on this topic, right? Yes. So first what we will do is we will define what is meant by Laplace transformation. After that we will find the Laplace transformation for some elementary function, right? So you can see first we will define what is meant by Laplace transform, right? Yes. So let f of t be a function defined for all t greater than 0. The Laplace transform of f of t is denoted by L of f of t, and it is defined by L of f of t is equal to integral 0 to infinity e power minus t f of t dt, where s is the parameter which may real, right? Yes. So you can see what Laplace transform does is it takes the input f of t and gives the output as integral 0 to infinity e power minus st f of t dt, right? So it acts as a Laplace transformation, right? It is transforming a function f of t be a function defined for all t greater than 0. It transforming to whatever you give f of t, it transforms into integral 0 to infinity e power minus st f of t dt, right? So why we need Laplace transform is that suppose if I have a trigonometric function, that is very complicated, means I can insert the trigonometric function into this Laplace transform, right? So that my output will be an algebraic function. The output of Laplace transformation is always an algebraic function, right? So you can see L of f of t. So this f of t be any function defined for all t greater than 0, then the output is integral 0 to infinity e power minus st f of t dt. So this will always be an algebraic function, that means suppose if you have a complicated function, you can transform that to algebraic function with the help of this Laplace transformation, and we know we can find the solutions for algebraic function easily when compared to some trigonometric functions or some complicated, right? So what Laplace transform does is it takes the input can be any function defined for all t greater than 0. It gives the output as algebraic function, and with the help of the output function we can try some solutions, right? So this Laplace transform is used in engineering to solve some initial value problems, etc., right? Yes. So this is the basic introduction to Laplace transformation. So let f of t be a function defined for all t greater than 0. In the Laplace transform of f of t, right? So you are giving an input as f of t, right? It operates, that operator is Laplace operator. It operates, I'm going to operate that input on f of t. My output will be integral 0 to infinity e power minus st f of t dt, right? Yes. So now what we will do is we will derive some Laplace transform for some elementary transformations, right? So what we will do is Laplace transform, we are going to see Laplace transform for 9 elementary functions, and based upon that 9 formulas we will do many problems, right? So that is we are deriving the Laplace transforms or some functions, right? So first I'll write it down, that will be clear for you, right? So Laplace transform for some elementary function. Laplace transform for some elementary functions. Laplace transform for some elementary function, that is these are the 9 basic important formulas that we are going to derive, and based upon these 9 formulas we are going to do some problems, right? Yes. The first formula is L of 1, right? L of 1 is equal to 1 by s, and s is strictly greater than 0. This is the first formula, that is when you give an input function f of t as a constant function is equal to 1, then my output will be 1 by s, where s is strictly greater than 0. That is what we are going to prove now, right? Yes. So what is, we know the formula, right? So what is formula? We know the formula, just I am going to apply the formula, right? So what is L of f of t? So L of f of t is integral 0 to infinity e power minus st f of t dt, right? So you just put f of t to be equal to 1, right? Because my f of t is 1 here, so put f of t is equal to 1. So if you put f of t to be equal to 1, so this will be integral 0 to infinity e power minus st. So f of t is 1, so 1 into dt. So we will have this to be equal to integral 0 to infinity e power minus st dt. Now integrate this. So this will be e power minus st divided by. So you have to differentiate with respect to here. Okay, this will be minus s, right? So I'm just integrating this. So integral e power minus a, e power minus by minus a, right? These are basic integral formulas. So I can take this minus 1 by s outside. So we will have e power minus st integral 0 to infinity, right? So this will be integral minus 1 by s. So apply upper limit and lower limit. That is, in place of t, you need to apply upper limit and lower limit. So this will be e power minus infinity minus e power minus 0, right? Just put t is equal to infinity minus t is equal to 0. So this will be minus 1 by s. E power minus infinity is 0 minus e power 0 is 1, right? E power 0 is same as e power minus 0. So we will be left with minus 1 by s into minus 1 is equal to 1 by s, right? So why we are putting this constraint here? Because this integral is convergent only when s is strictly greater than, right? So if you have studied real analysis, we will study, you just go through my real analysis playlist. There we would have tested the convergence of some improper integrals. You would have note that this integral is convergent only when this s is greater than 0, right? Where it is s. This is convergent only when this s is greater than 0. That is why we are using this section here. So therefore my first formula is, so this is my first formula. The first formula is L of 1 is equal to 1 by s, and this s is strictly greater than 0. So this is the first formula, right? That is, Laplace transformation of 1 is 1 by s. So now what Laplace transformation does is, it takes the input f of t and gives the output as integral 0 to infinity e power minus st f of t dt. So first we are finding the Laplace transform for some elementary functions. That is, like, what is the Laplace transform of 1, what is the Laplace transform of t power n, what is the Laplace transform of sin ax, what is the Laplace transform of cos at. We are going to find the Laplace transform for some basic elementary functions. So first we have found the Laplace transform of 1, which is 1 by s. Now we'll move on to the next formula, which is Laplace transform of s. So Laplace transform of t power n, L of t power n, right? This second formula, gamma of n plus 1 divided by s power n plus 1 if n is any real number, greater than minus 1, right? Greater than minus 1, and s is greater than 0. And second is, this will be equal to n factorial by s power n plus 1 if n is a positive 0 or positive integer. Right? This is the second formula. That is L of t power n. That is, when you apply t power n as an input, what will be the output, right? Yes. So we will find that, because why we are putting t, this is same as x power n, because here my function is f of t, right? So if it is f of x, means we will put x power n, but here we have f of t. So we will, what happens for when you put input as t power n, that is what my second formula is, right? So L of t power n will be gamma of n plus 1 by s power n plus 1 if n is any real number greater than minus 1, and this will be equal to n factorial by s power n plus 1 if n is a g, that is, if n is a whole number, right? We will prove this now. So we will prove this. So proof, right? So we have L of t power n is gamma of n plus 1 by s power n plus 1 if n is a, you know what is gamma, right? Gamma is a gamma function. So we have studied gamma function, that gamma of n is equal to integral 0 to infinity x power n minus 1 e power minus x, right? This is the gamma function formula, right? Gamma function. So gamma of n, right? You write this as gamma of n is equal to integral 0 to infinity, that is the value of this integral, I am naming that as gamma of n, right? Integral 0 to infinity power n minus 1 e power minus x dx, right? Yes. So we will prove this. So we need to find L of t power n. So this will be integral 0 to infinity e power minus st. So in place of f of t, I am putting t power n dt, right? Here my f of here my f of t is equal to t power n, right? Because you can see L of f of t is integral e power minus t f of t dt. So in place of f of t we have t power n. So I'm going to integrate this. So for integrating this, I'm going to put x is equal to st, right? So what will be my dx by dt? Okay, put x is equal to xt. So we will differentiate with respect to x, right? Differentiate with respect to x. So this will be 1 is equal to s into dt by dx. S is a constant, right? S is a parameter. So I'm going to integrate this with respect to x. So the differentiation of, I'm going to differentiate with respect to x. So derivative of x is 1, and here we have t, which is dt by dx. S is a parameter, right? So that means my dt will be, so therefore my dt will be what? Dx divided by s, right? So just substitute here. So this will be equal to integral 0 to infinity e power minus x, right? Because I substituted st to be equal to x. Let us write this t power n as it is, t power n. Now what is dt? Now dt is dx by s, dx divided by s, right? Dx divided by s. So we need to integrate this with respect to x, right? We need to differentiate with respect to x. So I can also replace t is equal to x by s, right? I can also replace t is equal to x by s. So this will be equal to integral 0 to infinity e power minus x, So I can replace t by x by s whole power n into ds divided by s. So here you can see I can take here we have s power n, here we have s power 1. So I can take s power n plus 1 outside, right? Here we have s power n, here we have s. If I multiply this, we will have s power n plus 1, and inside we will have e power minus x power n ds, right? This I'm writing this as x power n, s power n. So s power n into s is power n plus 1. I'm taking that outside, and here inside integral we have e power minus x, x power n ds, right? Now you just compare this value with the gamma formula. So gamma of n is integral 0 to infinity x power n minus 1 e power minus x dx. Now what will be gamma of n plus 1? That is, you replace n by n plus 1. So this n will be replaced by n plus 1. So that means these two will get cancelled. So we have integral 0 to infinity x power n e power minus x dx, right? So we are getting the same integral here, right? We are getting the same integral e power minus x power n dx. So you can see e power minus x power n ds. So that is, this is same as what? This is same as e power minus x, right? So you can see actually dt is dx by x, dt is dx by x. So you can see dt is dx by s, right? I've written ds by s. So we will have this to be equal to dx, right? dx by s. This will be equal to dx. What this is? This is nothing but 1 by s power n plus 1. So you can see x power n e power minus x dx, right? Where it is power n e power minus x dx is nothing but gamma of n plus 1. So I can write this as gamma of n plus 1. So you can see this value is equal to gamma of n plus 1 divided by s power n plus 1. That is what we need to prove, right? So gamma of L of t power n is gamma of n plus 1 by s power n plus 1 if n is any real number that is greater than minus 1, and this equal to n factorial if n is whole number, right? This is very easy. So we know that so these are gamma function properties. Gamma of n plus 1 is same as n factorial if n is a positive integer. You can see gamma of n plus 1 is same as n factorial if n is a positive integer or 0, right? So if n, or I can write this as n is a whole number, right? N is a whole number. So therefore if n is a whole number, I can write this formula as L of t power n equal to n factorial by s power n plus 1 if n is equal to 0 or 1 or 2 or 3 or 4. That is, if n belongs to and whole number, right? This is the second formula. So we have proved two formulas as of now. The first formula is L of 1 is 1 by s, and L of t power n will be gamma of n plus 1 by s power n plus 1 if this n is a real number greater than -1. This is the formula. If n is a whole number, it is n factorial by s power n plus 1. This is very important formula that you're going to use in problem, right? Remember, you just fix the value of n. If that n is a whole number, you apply this formula. If that n is a real number greater than -1, you apply this formula. For example, if you have n to be equal to 1 by 2, you have to use this formula, right? Because 1 by 2 is not a whole number, right? Yes. So remember these two formulas. So L of 1 is 1 by s, and L of t power n is gamma of n plus 1 by s power n plus 1 if n is any real number greater than -1, and this will be equal to gamma of n plus 1 is n factorial if n is equal to whole number, right? So now we'll move on to the third formula. The third formula is L of e power at, right? So third formula is L of e power at is equal to 1 by s minus a, right? L of e power at is 1 by s minus a, and that s is strictly greater than a. This is the third formula that you're going to derive now, right? So we will prove this formula now. So we know that L of f of t is equal to integral 0 to infinity e power minus t f of t dt, right? So this will be equal to integral 0 to infinity e power minus t. Now what is f of t? F of t is e power at dt, right? Because we need to find the Laplace transform of L of e power at, right? So this will be equal to integral 0 to infinity. So you know e into e, right? So therefore I can add the exponents. So we will have at minus st dt, right? So this will be equal to integral 0 to infinity e power a minus s t to dt, right? So we will integrate this. So we will integrate, this will be e power a minus s into t divided by, we are integrating with respect to t, right? So if I differentiate with respect to t, it will be equal to 1. So we will have a minus s, right? This a and s are parameters, that is these are some numbers. So limit will be integral 0 to infinity. So this will be equal to so I can take 1 by a minus s outside. So we will be left with e power a minus s into t integral 0 to infinity. So this will be equal to 1 by a minus s. So if you substitute, if I okay, what I can do is just write this as integral minus t into s minus a, right? Because I'm just taking minus outside, this will be s minus a into t. Now you apply upper limit and lower limit. This will be equal to 1 by a minus s into, so when you apply upper limit, this will be e power minus infinity, and when you apply lower limit, this will be equal to 0, right? So always remember that e power minus infinity is equal to 0 and e power infinity is infinity, right? E power infinity is infinity and e power 0 is always equal to 1, right? This will be equal to 1 by a minus s. E power minus infinity is 0, e power 0 is 1. So we will have minus 1 by a minus s, same as 1 by s minus a, right? This is one second formula. Third formula, L of e power at is 1 by s minus a, right? For example, if you want to find the Laplace transform of L of e power 2t, will be equal to 1 by s minus 2, right? Because my Laplace transform of L of e power at is equal to 1 by s minus a. Here my a is equal to 2, so we have 1 by s minus 2, right? Now we'll move on to deriving the fourth formula, which is L of e power minus at, right? Fourth formula is L of e power minus at is equal to 1 by s plus a, right? This is the fourth formula. L of e power, in the previous formula we have L of e power at is 1 by s minus a. If L of e power minus at is 1 by s plus a, right? Now we'll prove this. So we know L of f of t is equal to integral 0 to infinity e power minus st f of t dt. So you just put f of t is equal to e power minus at, right? So you put f of t to be equal to e power minus at into dt. So this will be equal to integral 0 to infinity e power minus. So you just take minus outside. So we will have s plus a into t dt, right? Now just integrate this. So this will be integral 0 to infinity. Okay, we will integrate this, right? So if I integrate this, what you will have? This to be equal to e power minus plus a into t divided by. So when you differentiate this t, you will have 1. So you will have minus of s plus a, right? I'm just integrating this in between 0 to infinity, right? So I can take this outside. This I can take minus 1 by s plus a outside, right? I'm taking this outside. So here I'm going to apply upper limit and lower limit 0 to infinity. So this will be equal to minus 1 divided by s plus a. So this will be e power minus infinity minus e power 0, right? So when t is equal to infinity, this will be e power minus infinity, and t is equal to 0, this will be t into s plus a, that is 0 into s plus a, which is equal to 0, right? So this will be equal to minus 1 by s plus a into 0 minus 1 be 1 by s, right? So we have proved that L of e power minus at is equal to 1 by s plus a, right? So this is equal to L of e power minus at is 1 by s plus a, right? Yes. So far we have proved 4 formulas, right? So just recall all those. So first formula is L of 1 is equal to 1 by s. Second is L of t power n, right? L of t power n will be equal to gamma of n plus 1 divided by s power n plus 1 if n is a real number and n is greater than minus 1, and this will be equal to n factorial by s power n plus 1 if n is equal to 0, 1, 2, 3, that is n is a whole number. And the third formula just now we have proved is L of e power at is equal to 1 by s minus a, and L of e power minus at is equal to 1 by s plus a. So we will continue fifth formula. Fifth formula is given by L of sin at, right? We're going to find the Laplace transform for L of sin at. So L of sin at is equal to a by s square plus a square, right? This is what second formula, sorry, fifth formula. This s is greater than 0, right? So we are going to prove L of sin at is a by s square plus a square. Solution or proof, right? So we know that L of f of t is equal to integral 0 to infinity e power minus st f of t dt, right? So what we're going to do is we're going to replace f of t by sin at. This will be integral 0 to infinity e power minus st into sin at dt, right? Now I'm going to use the basic integration formulas. So basic integration formula, that is you come across integration formula, that is integral e power ax sin bx plus c, right? So these are very elementary formulas that you come across in school level, right? So just show the formula that integral e power ax sin bx plus c dx is equal to e power ax by a square plus b square a sin bx plus c minus b cos bx plus c, right? These are very elementary formula that you come across in school level. Now I'm going to use that formula now, right? What is the formula is we know that integral of e power ax into sin of bx plus c is equal to e power ax divided by a square plus b square into a sin bx plus c minus b times cos bx plus c, right? Here we have dx, right? Here we have dx. So this is the formula for this, right? Now we just compare this with integral. We just compare this with integral. So what we have here is, so in place of x we have t, right? So here we have dx, here we have dt. That means you need to replace x by t, and then you need to find the value of a, b, c, right? Because a, b, c and x, there are 4 unknowns here. So let's compare this with here. We have found that x is equal to t here. So a is minus s, right? You just compare here. So a is minus s, and I can write this sine at plus 0 as, I can write this as, so we have sine at dt, right? So this I can write this as sine at dt, same as integral 0 to infinity e power minus st sine of at plus 0 dt, right? Now you compare this with here. So a is minus s, and what is b? B is a, right? Here b is equal to a, and what is c? C equal to 0, right? You just compare this integral with this integral, and then you just equate that, right? Yes. Integral of e power minus st sin at dt. Now compare this integral, we have these 4 values, right? Now just up now, so therefore integral of 0 to infinity e power minus st sine of at plus 0, so this will be equal to, so apply the formula now, e power ax. So what is a? A is minus, what is x? S is t divided by a square plus b square. So a square plus b square, here a is s, a is minus s, b is a, so we will have this to be equal to a square plus a square. A, what is a? A is minus s sine bx plus c, so b is a, so ax plus 0, sorry, x is t, right? So x is t, so at plus 0, at plus 0 minus what is b? B is a, so a times cos what is b? B is equal to a here, so at plus 0, right? So in this formula you replace x by t, a by minus s, b by a and c by 0, right? So limit is from what? It is from 0 to infinity. So we will have this to be equal to e power minus st divided by s square plus a square into, so minus s into sine of at minus a into cos of at, limit is from 0 to infinity. Now when you apply upper limit, so this will be e power minus infinity divided by square plus a square into minus s into sine of infinity minus a into cos of infinity, right? This is the upper limit value. This is upper limit minus, when you apply lower limit, you will have e power minus 0 divided by s square plus a square into minus s into sine of 0 minus a into cos of 0, right? Now you can see this full integral will be equal to 0, right? Because e power minus infinity, this value is equal to 0, therefore this full value will be equal to 0. So we will have 0 minus e power 0 is 1 by s square plus a square into, so sine 0 is 0 minus a into cos 0 is equal to 1, right? So therefore we will have minus 1 divided by s square plus a square of minus a. So we will have a divided by s square plus a square is the formula for L of sine at, right? So L of sine at is a by s square plus a square, right? Yes, using this, s is greater than 0, because then only we can use this formulas, right? Yes. Now we'll move on to fifth formula. The fifth formula is L of cos at, right? Sixth formula, L of cos at, right? L of cos at is equal to s by s square plus a square, right? So you can see L of sin at is a by s square plus a square. Now we are finding Laplace transform of cos at, which is s square by s by s square plus a square, right? Yes. So here we have a by s square plus a square. So here we're going to have L of cos at, which is s by s square plus a square, right? Now we're going to prove this formula. Again, this s is strictly greater than 0, right? Yes. So again, I'm going to use of the same method. So we will find the Laplace transform for this. So we know L of f of t is equal to integral 0 to infinity e power minus st into f of t dt. So this will be integral 0 to infinity e power minus st. My f of t is cos at into dt, right? So this I can write this as integral 0 to infinity e power minus st cos of at plus 0 into dt, right? So in the previous problem we have used this formula, right? Integral e power ax sin bx plus c. Now we are going to use integral e power ax cos bx plus c, right? So integral e power x cos bx plus c is, so same here we have cos first and then sin second, right? So same formula. So here we have sin, but here we have cos, and here we have cos, here we have sin, but here in between you have plus here, right? So we will use that formula now. So we know that I'm going to apply the formula, that we know that integral of e power ax cos of bx plus c is equal to e power ax divided by a square plus b square into a cos x plus c plus b sin bx plus c, right? So these are the basic integration formulas that we are using in these problems, right? So e power ax by a square plus b square, a cos bx plus c plus b sin bx plus c, right? Now just compare this integral with this integral, right? You just compare this with these two integral. We have x to be equal to t, right? Now you find the value of a, b, c. Now a is minus s. Now what is b? B is equal to a and c is equal to 0 here, right? So just compare here. So in place of x we have t, and in place here we have minus s, but here we have a. So a is minus s cos of bx plus c. So in place of b we have a, and in place of c we have 0. Now apply the formula now here, you will get the required answer, right? So therefore integral 0 to infinity, we'll change the pen color so that it will be easy for you to. So therefore integral 0 to infinity e power minus st cos of at plus 0 dt is equal to, now apply the formula, e power ax. What is a? A is minus x. What is x? X is t divided by a square plus b square. So a is minus s, so it will be s square plus b square. So b square is a square into a. What is a? A is minus s cos of, what is b? B is a. What is x? X is t, at plus 0 plus b times, what is b? B is a sin of, so what is b? B is a, so at plus 0, right? In this formula you replace all these four things. Now limit is from 0 to infinity, so this will be e power minus st divided by s square plus a square. So here we will have minus s into cos at, right, plus a into sin at. Limit is from 0 to infinity, right? Now when you apply upper limit, so this will be upper limit minus lower limit. Upper limit will be equal to 0, right? Because when you put infinity, e power minus infinity, so 0 into something, all will be equal to 0. So minus, when you put lower limit as 0, we will have e power 0 divided by s square plus a square minus s into sin of cos of 0 minus s into cos of 0 plus a into sin of 0, right? So this will be minus 1 divided by s square plus a square. So here we have minus s into 1 plus 0, right? Sin 0 is 0, cos 0 is 1. So we will have this to be equal to s by s square plus a square, right? This is the formula for L of sin 80 and L of cos 80. Thus we have proved very two important formulas, that the Laplace transform of sin 80 is given by a by s square plus a square, and the Laplace transform of cos 80 given by s by s square plus a square. For example, let me give you an example. Suppose if you need to find Laplace transform of sin 4t, that means here we have 4, so you replace a by 4, so we will have s square by 4 square, that's it, right? Suppose you need to find the Laplace transform of cos of minus 2t, so here a is minus 2, so we will have s by s square plus minus 2 square, which is equal to s by s square plus 4, right? So in place of a we have minus 2, substitute that a, s will remain as it is, right? The only thing that you're going to change is at, t is fixed, a is the number that you're going to do. So L of sin of 4t, L of sin 4t is a by s square plus a square. So a is 4, but here in cos 80 we have a only here, right? S by s square plus a square, a by s square plus a square. So we have proved seven formulas as of now, right? Okay, six formulas as of now. So L of 1 is 1 by s, L of t power n is gamma of n plus 1 by s power n plus 1 if n is belongs to real number greater than minus 1 will be equal to n factorial by s power 1 if n is equal to number, and L of e power at is 1 by s minus a, L of e power minus a by s plus a, L of sin at is a by s square plus a square, L of cos at is s by s square plus a square. So still we have left with two more formulas. So now we'll move on to the seventh formula. So seventh and eighth formula, right? So there are only two formulas that we're going to derive now. After that, we will be doing some problems based on these formulas, right? Yes, this is what we're going to do now. So I'll just put charge. So we're going to start with L of sin h80, right? We're going to derive the formula for L of sin h80, right? L of sin h of 80. So we have derived L of sin 80. L of sin 80 is a by s square plus a square. Now we are deriving Laplace transform of hyperbolic sin h of 80, right? Sin 80 is a by s square plus a square. Now we are deriving for sin h80, right? This is a by s is a by s square minus a square. That's it, right? So for sin 80 we have a by, and see for sin 80 we have a by s square plus a square. Here we have s square minus a square for sin h80, right? So for sin h80, and this s is strictly greater than modulus of a, right? Yes. So for this condition only that interval will be convergent, right? For this condition only that interval will be convergent, right? Yes. No problem, we will do this proof. So we know that L of f of t is equal to integral 0 to infinity e power minus st f of t dt, right? So you just replace f of t by sin h80. This will be equal to integral 0 to infinity e power minus t sin h of at into dt, right? Now what is the formula for sin h80? I'm just going to use the hyperbolic formulas. So integral 0 to infinity e power minus st. Now what is sin h80? This will be e power at minus e power minus at divided by 2, right? For 80 divided by 2 into dt, right? So sin of theta is equal to e power theta minus or minus theta divided by 2. So in place of theta we have at, right? In place of theta we have at. So e power at minus e power minus at divided by 2. If you put in place of minus, if you put plus, you will have cos h theta, right? So we will integrate this. So this will be integral 0 to infinity e power minus e. So I can take this 1 by 2 outside, right? I can take this 1 by 2 outside. So here we have e power at minus e power minus at into dt. This will be 1 by 2 integral 0 to infinity e power minus st into e power at minus e power minus st into e power minus at dt, right? So this is same as, this will be equal to 1 by 2 integral 0 to infinity. If I can take e power minus t outside, so if I take e power minus t outside in this here, so we will have s minus a, right? We will have s minus a, yes or no? So I'm taking minus t outside, so we will have s minus a minus, so here I'm going to take minus t outside again. If we take minus t outside, we will have s plus a, right? Plus a into dt, right? Now we will just integrate this, so this will be equal to 1 by 2. Now if you integrate this, you will have e power minus t s minus a divided by minus of minus a minus, and when you integrate this, you will have e power minus t s plus a divided by, so this will be minus of plus a, limit is from 0 to infinity, right? So this will be equal to, now when you put the upper limit, so this will be equal to upper limit minus lower limit. Now when you put the upper limit, this again 0 minus 0, right? This will be 0, right? Because e power minus infinity is 0, e power minus infinity is 0. So my upper limit full term will be equal to 0. I'll write it as 0 minus, so you put the lower limit now, it will be e power 0 divided by minus of s minus a minus e power 0 divided by minus of s plus a, right? So this will be equal to 1 by 2, yeah, minus, so this will be 1 by minus of s minus a, this minus minus will become plus, so 1 by s plus a, right? So I can also write this as 1 by 2. If we take minus minus inside, we will have 1 by s minus a minus 1 by s plus a, right? If you multiply minus into plus, this will be minus. Now this will be equal to 1 by 2, just cross multiply this or take LCM, so s plus a minus a divided by plus a to s minus a, right? Second LCM or just cross multiply, plus a s minus a divided by s minus a into s a. So this will be equal to 1 by 2 b s plus a minus s plus a, right? Divided by a plus b, a minus b. So it will be a square minus b square. These two will get cancelled. So we will be left with 1 by 2 into 2a divided by square minus a square. So these two will get cancelled. So we are left with a by s square minus a square. That is what we need to prove, right? So L of sin h at is a by, therefore L of sin h at is equal to a by square minus a. Suppose if I have L of sin at, we will have a by s square plus a square. If you have sin h at, we will have a by s square minus a square, right? So similarly, now we're going to prove, we're going to find the formula for cos h at, right? L of cos h at, L of cos h at. So this will be equal to s by s square minus a square. In cos 80 we have s by s square plus a square. Here we have s by s square minus a square, and this s is simply greater than a. Why we are using this condition? Because for this condition only that interval will be convergent, right? This interval will be convergent only for that condition, right? Yes. So we will prove this formula now. So proof. So we know that L of f of t is equal to integral 0 to infinity e power minus st f of t dt, right? This will be equal to integral 0 to infinity e power minus st f of t is cos h t into dt. So this will be equal to, sorry, so this will be equal to integral 0 to infinity e power minus st. Now what is cos h at? E power at plus e power minus at divided by 2 to dt, right? So if you have sin h at, here you will have e power theta minus e power minus theta by 2. So cos h theta will be e power theta plus e power minus theta divided by 2, right? So this will be equal to, now we just integrate this. So this will be equal to, I can take 1 by 2 outside. So this will be integral 0 to infinity. So if you just multiply this, you will have e power minus st into e power at plus e power minus s into e power minus at t, right? So this will be equal to 1 by 2 integral 0 to infinity. If you take e power, you always take minus t outside. Then only if you apply infinity, this will tend to 0, right? This will be equal to s minus a plus e power, if you take minus t outside, we will have this to be equal to s plus a to dt. Now when you integrate this, integrate this, so this will be equal to e power minus t into s minus a divided by minus of s minus a, right? Derivative of t is 1, so we'll have minus of s minus a plus e power minus t into s plus a divided by minus of s plus a. Limit is from 0 to infinity, right? Now when you apply upper limit, this will be equal to upper limit minus lower limit. Now when you put the upper limit, it will be equal to 0, right? Because e power minus infinity is 0, e power minus infinity is 0, 0 plus 0 is 0, minus, now when you apply lower limit, this will be e power 0 divided by minus of s minus a plus e power 0 divided by minus of s plus a, right? So Simplify this, you'll get the required answer. This will be equal to 1 by 2. Now, if you take minus inside, we will have 1 by s minus a minus 1 by plus, right? Because already we have minus here, so minus minus will be plus, minus will be plus, so 1 by s plus a, right? So you take LCM now, it will be equal to 1 by 2, so s plus a plus s minus a divided by plus a into s minus a, right? You just take cross multiply, so s plus a into s minus a divided by s minus a into s plus a. So this will be equal to 1 by 2. So this 2 will get cancelled. So we have 2s divided by, so a plus b, a minus b. So we will have s square minus a square. Again these 2 will get cancelled. We have left with by s square minus square, right? Therefore, we have proved two more formulas. We have proved two more formulas, that L of sin h at will be equal to a by s square minus a square, and L of cos h at is equal to s by s square minus a square, right? So for example, if you need to find L of sin h of 3t, this will be equal to 3 by s square minus 3 square. That's it, right? We have a to be equal to 3. Suppose if you need to find L of cos h of 4t, this will be equal to s by square minus 4 square. These two are the very important formulas. So we have proved 8 formulas as of now, right? So that's it. In the next video, we will start solving some problems based on these formulas, right? These are very fundamental 8 formulas that we have proved, right? So we have started with L of 1, L of t power n, L of e power at, L of e power minus at, L of sin at, L of cos at, L of sin h at, L of cos h at. So these 8 formulas are very very important to solve all the problem. Now you just take a note and then write all the 8 formulas line by line, so that you will have more clarity about this, right? If you want me to write, I can also write that. So conclusion. So first is L of 1. So L of 1 is 1 by s. Second is L of t power n. This will be equal to gamma of n plus 1 by s power n plus 1. If this n belongs to a real number and n is greater than minus 1, it will be equal to n factorial by s power n plus 1. If this n belongs to full number, and L of e power at will be equal to 1 by s minus a. The fourth is L of e power minus at is equal to 1 by s plus a. Fifth is L of sin at will be equal to a by s square plus a square. Sixth is L of cos at, which is s by s square plus a square. Now seventh is L of sin h of at will be equal to a by now we have proved, right? This will be equal to a divided by s square minus a square. The sixth is L of cos h of at is equal to s divided by s square minus a square, right? These are the very basic 8 formulas. There are some conditions: s is greater than 0 and this s is greater than a, right? And here we have s is greater than 0. Now s is greater than 0. Here we have is greater than mod a, and these are the conditions, right? For these conditions only this formula will be valid, because for that only that integral will be convergent, right? So we have 1 2 3 4 5 6 7 8, right? So you just go through all the formulas, then it will be very easy for you to do the problems. So do some problems. So before doing some problems, we're going to prove one property, that Laplace transformation satisfies linearity property, right? So Laplace transformation satisfies linearity property. So linearity property, right? Linear property, right? Linear property of Laplace transform, right? It satisfies linearity property, that is L of alpha into f of t plus beta into g of t is same as alpha into L of f of t plus beta into L of g of t. That is Laplace transform satisfies linearity property, right? That is you can take alpha outside. Alpha and betas are scalars, right? Alpha and betas are some constant, right? Here alpha beta are scalars. These are some numbers. That means you can take that number outside and you can apply L to the function f of t, and similarly you can bring L inside. You can take this beta outside, right? So we will prove this. So we have we need to prove L of f of t, L of alpha times f of t plus beta times g of t is equal to alpha times f of t plus beta times L of g of t, right? So we know that L of f of t equal to integral 0 to infinity e power minus st f of t dt, right? This will be equal to integral 0 to infinity e power minus st. What is f of t? So we want, okay, first what we will do is we will do like this. So we will break this. So we will have like, so this is the basic formula, right? L of f of t into dt. Now in place of f of t, I'm going to substitute this, right? This will be, so therefore L of alpha times f of t plus beta times g of t. So this will be equal to integral 0 to infinity e power minus st. So in place of f of t, I am substituting alpha times f of t plus beta times g of t. So this will be equal to integral 0 to infinity. So just multiply e power minus st outside, sorry, inside, alpha into e power minus st f of t plus beta into e power minus t of t dt, right? So this dt is common for both the term. Now this is same as if you take alpha outside, integral 0 to infinity e power minus t of t dt plus take beta outside, integral 0 to infinity e power minus st of t dt, right? I'm just integrating term by term, right? Because we know that integration satisfies linearity property, right? So therefore this is same as alpha into, what is this? This is nothing but Laplace transform of f of t, right? Laplace transform f of t, because L of f of t is integral 0 to infinity e power minus st f of t dt. And what is this? Beta into, this is nothing but Laplace transform of g of t, right? So Laplace transform g of t is integral 0 to infinity e power minus st g of t dt. So we have started with L of alpha f of t plus beta g of t. We have proved that it is equal to alpha times L of f of t plus beta times L of g of t, right? So therefore it satisfies linearity property, right? So you can also extend this, right? That is here we have only two function, right? Here we have only two function. You can also extend for any number of function, right? So in general alpha times, let us say the scalars are alpha 1 f1 of t plus alpha 2 f2 of t plus alpha 3 f3 of t and so on up to alpha n fn of t. I'm generalizing this, right? So here we have only two function, but it is not only true for two function. You can also take n number of functions. This is same as alpha 1 into L of f1 of t plus alpha 2 into L of f2 of t and so on up to alpha n into L of fn of t, right? So therefore we have proved very important property, which is called linear property of Laplace transform. So with the help of this property, we can do problems very easily, right? Yes, we'll do some problems as problems now. Take problems. So we'll start the first problem. First problem will be find the Laplace transform of the Laplace transform of e power 2t plus 4t cube minus 2 times sin 3t 3 times cos 3t, right? We need to find the Laplace transform of this function. Very easy, right? Don't get panic. So we need to find L of, we need to find the Laplace transform of, you don't need to integrate now, right? Because you already found all the formulas. L of e power 2t plus 4t cube minus 2 times sin 3t plus 3 times cos 3, right? We know all the formulas. So we just go through all the 8 formulas now, because for that reason only we have derived these 8 formulas. With the help of these 8 formulas, we are going to apply directly, right? So we know that Laplace transform satisfies linearity property. So therefore I can write this as L of e power 2t plus 4 times L of t cube minus 2 times L of sin 3t plus 3 times L of cos 3t, right? Now you know all the formulas, right? So what is L of e power at? L of e power at is 1 by s minus a. So in place of a we have 2 here, right? So just recall L of e power at is 1 by s minus a, right? Just go through the formula. So L of e power plus at is 1 by s minus a. So here we have e power 2t, right? So I'm just replacing a by 2. So we will have 1 by s minus 2, right? 1 by s minus 2 plus 4 times. Now what is L of t power n? This n is a whole number. Therefore this will be equal to n factorial by s power n plus 1, right? Okay, first what we will do is we will prove it. Okay, what I will do is just for simplicity, I'm writing this as a, right? After that we will replace all. Minus 2 times. So what is L of sin 80? So it is a by square plus a square. And what is L of cos 80? It is s by s square plus a square, right? Now you replace all the term, right? So here we have a to be equal to 2. So this will be equal to 1 by s minus 2 plus 4 times. So here we have t power n. N is 3 here, right? It will be 3 factorial by s power 3 plus 1 minus 2 into. Now what is sin 80? A is 3 here. So we will have 3 divided by s square plus 3 square plus 3 times. Here my a is 3 again, right? So therefore this will be equal to 1 by s minus 2 4 into 6 by s power 4 minus 6 by the square plus 9, right? 2 3s are 6 plus 3s divided by s square plus 9, right? This is the Laplace transformation for the given function. If you want, you can also simplify by taking 1 by s minus 2. So 24 divided by s power 4. Here there are two same denominator. So if I take 1 by s square plus 9 outside, so here we have 3s, here we have minus, right? This is the Laplace transformation for the given function. So from now on, you don't need to integrate, right? Whenever you need to find Laplace transformation, you will integrate this, right? But we have already integrated, and then we already derived all these 8 formulas. With the help of the 8 formulas, you just apply the formula directly. L of e power at is 1 by s minus a. So in place of a we have 2, so this will be 1 by s minus 2. L of t power n, we have 2 formulas for L of t power n. So this will be equal to n factorial by s power n plus 1. If the n is a whole number, here we have 3. So that means 3 factorial by s power 3 plus 1. Sin 80 is a by s square plus a square. So here we have sin 3t. So a is 3. So 3 by s square plus 3 square. Cos 80 is s by s square plus a square. So in place of a we have 3. So substitute that directly, you will get the answer, right? Do one more problem. So find the Laplace transform of sin t minus cos t whole square, right? You don't need to integrate, right? Because you can also use this form, you can also do this formula by definition. This will be equal to integral 0 to infinity e power minus st f of t dt. You take this full term as f of t, it will take so much of time. But we have already derived all those 8 formulas. With the help of 8 formulas, you just apply that directly, right? Now we need to find the Laplace transform of solution. We need to find the Laplace transform of sin t minus cos t whole square, right? This is same as L of, now apply a minus b whole square formula, a square plus b square minus 2 times ab, right? Minus 2 times ab. So this will be equal to L of, so sin square t plus cos square t is 1 minus 2 times sin t cos t, right? So what is sin 2 theta? Sin 2 theta is 2 theta cos theta. I can write this as sin 2t, right? Sin t cos sin 2 theta is 2 sin theta cos theta, right? Yes. Now apply L. L is linear, so therefore this is same as L of 1 minus L of sin 2t. So what is L of 1? The L of 1 is 1 by s minus what is L of sin 2t? Is s by s square plus a square. So instead of a, we have this to be equal to 2. Therefore, my Laplace transform is 1 by s minus by square 1 by sin 80, right? Sin 80 is a by s square plus a. So sin 80 is a by s square plus a square. Apply that, you will get the answer. 2 by s square plus 4, right? So 1 by s minus 2 by s square plus 4 is the required Laplace transform. If you want, you can also take LCM. Square plus 4 minus 2s divided by s into s square plus 4. So you can also write this like s square minus 2s plus 4 divided by s into square plus 4, right? This is the required Laplace transformation for given function, right? L of sin 80, L of sin 80 is a by s square plus a, right? Sorry, so this will be 2 by 2 by, and see L of sin 80 is a by s square plus a square. So my a is 2 by s square plus 2 square. We will have 2 by s square plus 4. You can also leave at this stage, or you can also cross multiply and then simplify, right? So if you understand that 8 formulas, then everything will be very easy for you. You just have to apply the formula directly. So in place of a, you need to put the number, right? So now we'll continue with the third problem. So in this video, we'll try to finish on 3 more problems. So three is find the Laplace transform of find the Laplace transform of sin 2t cos 3t, right? Yes. So we need to find the Laplace transform of sin 2t cos 3, right? So we need to find the Laplace transform of sin 2t to cos 3, right? So you should not bring Laplace transform inside, right? If you have plus only, you can bring. If you have multiplication, means you should not bring Laplace transform inside, right? So Laplace transform satisfies only linearity property, right? That means if you have plus, means you can bring Laplace transform inside, but if you have multiplication, means you should not bring L inside, right? That means you need to simplify this term. You need to simplify this term. It means L of. So we know that what is the formula for sin A cos B. So I have given the basic trigonometric formula identities here, trigonometric formulas here. So sin A sin B is cos of. We will be using these 6 formulas more often in Laplace transform, right? Just note down all the 6 formulas. Sin A sin B is cos of A minus B minus cos of A plus B by 2. Cos A cos B is cos of A minus B plus cos of A plus B by 2. Sin A cos B is sin A plus B plus sin A minus B by 2. Cos A sin B is sin A plus B minus sin A minus B by 2, right? So remember these 4 formulas. Now here you can see we have sin A cos B, right? So sin A cos B. So we need to find the Laplace transform for this. So what is sin A cos B? We know that. So what is sin A cos B, right? So just see the formula. Sin A cos B, it will be sin A plus B plus sin A minus B by 2, right? Sin A plus B plus sin A minus B divided by 2, right? You just go through all the 4 formulas. This is a very elementary formula that you come across in 12th standard level, right? So whenever you have same sin cos, you will have cos. Whenever you have sin cos, you will be sin, right? You just remember that. So apply here. So here we have, in place of A we have 2t, in place of A we have 3t. So it will be sin 2t cos 3t. It will be equal to sin of 2t plus 3t plus sin of 2t minus 3t divided by 2. So this will be sine of phi t. This is same as minus sine t, right? Because sine of minus theta is same as minus sine theta. So here you will have 2t minus 3t, which is minus t. Sine of minus t is minus sine t divided by 2, right? Whole divided by 2. So what we have did is we have transformed sine 2t cos 3 to, right? So now we'll find the Laplace transform of sine 2t cos 3t. This is same as Laplace transform of, so sine 2t cos 3t is same as sine phi t minus sine t divided by 2, right? Now you can apply linearity property, right? Now you can apply linearity property. This is same as 1 by 2 plus or minus, no problem, right? You can apply linearity property if you have plus or minus, right? This is L of sine phi t minus L of sine t, right? Now you know the formula for L of sine at. So L of sine at is given by a by s square plus a square. So here we have a to be equal to 5. This is equal to 1 by 5. 5 by s square plus 5 square minus, here a is equal to 1, right? That means this will be 1 by s square plus 1. So here a is 5, here a is 1. So that's it, right? So this will be equal to 1 by 2 5 by s square plus 25 minus 1 by s square plus 1 is the required Laplace transform. If you want, you can also simplify by taking LCM, but I don't think that is needed, right? Yes. You want to fourth problem. Find the Laplace transform of cos cube 2t, right? Cos cube 2t, right? Yes. So that is we need to find L of cos cube 2t. So if I don't have cube here, I can write the Laplace transform of cos 2t in a single stroke. That will be equal to s by s square plus a square. But what here is we have cos cube t. That means we need to use some trigonometric formulas here to simplify this to some simpler term, right? So we know that now what is you can see that cos 3x is 4 cos cube x minus 3 cos x, right? So cos 3x equal to 4 times cos cube x minus 3 cos x, right? Minus 3 cos x. So that means you just keep this term here. So that means my 4 cos cube x is equal to cos 3x plus 3 cos x, right? Cos 3x plus 3 cos x, yes or no? So you can see I have taken this term to that side. So that means my cos cube x will be equal to 1 by 4 cos 3x plus 3 times cos x, right? So therefore here we have cos cube of 2t. That means you just replace x by 2t. Will be cos cube of 2t will be equal to 1 by 4 cos 3 of 2t plus 3 into cos of 2t, right? I'm just replacing x by 2t, right? Yes. This will be equal to 1 by 4 cos of 6t plus 3 times cos 2t, right? This is the required simplification of cos cube 2t, right? So we need to find the Laplace transform of cos cube 2t. This is same as L of, so cos cube 2t is 1 by 4 cos 6t plus 3 times cos 2t, right? So you just simplify the inside term first and then apply Laplace transform, right? Here also we did the same thing. So you first simplify this inside term using trigonometric formulas and change and apply linear. You try to change that to linear, right? You try to change this to linear. I have changed this to linear, right? Linear means it can be plus or it cannot, it can be minus also, right? It can be plus or it can be minus also in between, right? So I can write, suppose if I have minus also, you can see why I'm bringing, you can see why I'm bringing minus L, because I can write this as L of sine phi t plus minus 1 into sine phi t by 2, right? So therefore now I can bring L inside because you have plus here, right? even if you have minus here, I can write that as plus into minus of that thing, right? So therefore, even if you have plus or minus, you can bring L inside. Now apply L. So I can take 1 by 4 outside. 1 by 4 into L of cos 60 plus 3 times L of cos 2t, right? 1 by 4 is common for all, so I taken 1 by 4 outside. So this will be equal to 1 by 4. Now what is L of cos 60? It is s by s square plus a square, right? So L of cos 80 is given by s by s square plus a square. So L of cos 60 will be s by s square plus 6 square plus 3 times s by s square plus 2 square, right? S square plus 2 square. So this will be equal to sorry, will be equal to 1 by 4 s by s square plus 36 plus 3s divided by s square plus 4, right? So therefore this is the required linear transformation. If sorry, Laplace transformation, right? I'm just saying linear transformation just because I'm taking a linear algebra unacademic classes, right? Don't think this is Laplace transform, right? So if you want, you can also take LCM, right? If you want you can all take LCM and simplify, right? This is the required Laplace transformation for cos cube 2t, right? So we have solved almost 4 problems as of now, right? So we'll continue with the 5th problem, right? Yes. So make sure that you have watched all the previous videos. So problem number 5, find the Laplace transform of so it is sin AT sin B, right? That is, we need to find Laplace transform of sin AT sin BT, sin AT sin BT. So you cannot take Laplace transform inside, right? It's has only linearity property. That means you need to simplify this. So in the previous class I have given the formulas. So you can see sin A sin B is given by, so we know that sin A sin B equal to, you just see the formula, sin A sin B is equal to cos A minus B minus cos A plus B divided by 2, right? So here we have sin AT cos BT, that is, in place of A we have AT, in place of B we have BT. So this will be equal to cos of AT minus BT minus cos of AT plus BT divided by 2, right? So this will be equal to cos of A minus B into T minus cos of A plus B into T divided by 2, right? Because A and B are numbers, right? Yes. So now I'm going to apply Laplace transform. So Laplace transform of sin AT sin BT. So this will be equal to Laplace transform of, now what is sin AT sin BT? Is cos A minus B into T minus cos A plus B into T divided by 2, right? Now you can apply linearity property. Now I can take 1 by 2 outside. So Laplace transform of cos of A minus B into T minus Laplace transform of cos of A plus B into T, right? Now we know the formula. Now what is Laplace transform of cos AT? So L of cos AT is given by s by s square plus a square. So here my A is A minus B and here my A is A plus B, right? So this will be equal to 1 by 2 s by s square plus a square. My A is A minus B whole square. Again here s by s square plus a plus b whole square, right? A plus b whole square. If you want, you can also take LCM, right? I'm not going to do that. So if you want, you can also take LCM, right? Yes. So now I'll move on to Sixth problem, a very easy problem if you understand all the in trigonometric formulas, right? Find the Laplace transform of sine of Wt plus delta, right? Sine of Wt plus delta, you need to find the Laplace transform. So what is sine a plus b? So sine a plus b is sine a cos b plus cos a sin b, right? So we need to find the Laplace transform of sine of Wt plus delta, and this delta is some number, right? This is same as L of, so what is sine a plus b? So it is sine a cos b plus cos a sin b, right? That means you can treat this as constant, this as constant, right? Therefore when you apply Laplace transform inside, so cos delta of sin Wt plus sin delta of cos Wt, right? Now this is equal to cos delta. Now what is L of Wt? So L of sin At equal to a by s square plus a square. So this will be w by square plus w square plus sine delta is constant here. So this will be s by s square plus a square. So a is w, right? Therefore the required answer is cos delta. If you want, you can take 1 by s square plus w square outside. This will be equal to w times cos delta plus s times sin delta, right? You can also write like this to find the Laplace transform. So far in the last four problems, we are finding Laplace transform for trigonometric functions. Whenever you have trigonometric functions, you need to reduce that to linear problem, right? Here you can see this is not linear. You try to use some trigonometric formulas and convert that to linear. Linear means plus or minus, right? You can see plus minus plus minus. I'm converting that to plus. Here you can see this is not linear, right? So sixth problem. So I'll give you some more problems based on these formulas. Seventh problem. Seventh problem is find the Laplace transform. Find the Laplace transform of the Laplace transform of sine cube sin cube 2t. We have already found the Laplace transform for cos cube 2t in the previous class, right? So here now you can do this in your own, right? You just need to find the Laplace transform for sin cube 3t. Before that, what we will do is we will simplify sin cube 3t, right? We will simplify sin cube 3t. So we know that, so what is sin 3x? So in the previous class you can see sin 3x is 3 sin x minus 4 sin cube x, right? So 3 sin x minus 4 times sin cube x, right? Therefore my 4 sin cube x is equal to 3 sin x minus sin 3x, right? So you can see I'm just taking this term to that side and this term to this side. So that means my sin cube x is equal to 1 by 4 3 sin x minus sin 3x, right? But here we need sin cube 2t. So sin cube 2t will be equal to 1 by 4. So 3 into sin 2t minus sin 3 into 2t. This will be equal to 1 by 4 3 into sin 2t plus sin 60, right? So we have simplified sin cube 2t to 1 by 4 sin 1 by 4 3 sin 2t minus 4 sin 60. So therefore the Laplace transform of sin cube, right? Laplace transform of sin cube 2t is same as Laplace transform of, so sin cube 3t is 1 by sin cube 2t is 1 by 4 3 sin 2t minus sin 60, right? So this will be equal to 1 by 4 L of 3 sin 2t minus L of Sin 60, right? So here I can take 3 outside, right? So I can take 3 outside. So 1 by 4, 3 into L of sin 2t minus L of sin 60, right? So same as L of cos cube t, right? If you have seen L of cos cube t, same method that we have did, right? Here also, so this will be equal to 1 by 4. So what is L of sin 2t? So it will be a by s square plus a square, and this is a by s square plus a square. This will be equal to 1 by 4. 1 by 4, 6 by 8. So 1 by 4, 6 by s square plus 4 plus 6 by s square plus 36, right? Therefore this is the required Laplace transformation. If you want, you can also simplify also, right? 6x square plus 36 into s minus, you can simplify like that, but I don't want to do that, right? So if you understand the L of sin cos cube 3t, then it is somewhat similar, right? So I'm just using cos cube formula here. So here we have sin 6, right? If you want, you can also simplify. So we'll move on to 8th problem. So I'll give you some exercise problem for you. Find the Laplace transform for the following. First is sin 2t sin 3t. Second is sin 60 4t. Third is e power minus 5t t square plus 60, right? You just find the Laplace transform for okay, let me add some more problem. T power 10 plus t power 4 plus 2, right? So very easy problem, right? If you just apply sin a sin b formula, you just apply sin a sin b formula. So you will have split up like this and then apply L inside, problem will be over. Again you apply, you can directly tell the answer. This will be e power minus at is 1 by s plus a. So we will have 1 by s plus 5. L of t power n is n factorial by s power n plus 1. This will be 2 by s cube and 6 into L of t. So L of t power 1, right? T power 1. So n factorial by s power n plus 1. So we will have 1 by s square. So my answer will be 1 by s plus 5 plus 2 by s cube plus s6 by s square. That is the required answer. Again, this is L of t power 10 plus L of t power 4 plus L of 2. So L of 2 I can write this as, so this is n factorial by s power n plus 1, right? And this is 4 factorial by s power 4 plus 1. You just take 2 outside, you just apply L of 1, right? So 2 by s will be this, right? That's it. Elementary problem. For these two problem, apply these formulas, right? Apply these formulas. So if you want, I can also give some more problems like cos pi t sin 4t, right? Now you also find this. So for cos pi t sin 4t, use this formula. Use this formula and then in place of a and in place of b, I have given phi t and 4t. Substitute that and apply Laplace, right? So in the next class, we will continue 9th problem. We will move on to 9th problem. 9th problem. Find the Laplace transform. Find the Laplace transform of sin h cube 2t, right? Sin h cube 2t, right? We need to find Laplace transform for this function. So we need to find L of f of t, right? So my f of t is given to be sin h of 2t whole cube, right? Both are same. Now what is sin h of at? So what is sin h of at? My sin h of at formula will be e power at minus e power minus at divided by 2. This is the hyperbolic sine formula, right? Sin h at is e power at minus e power minus at to, or in general sin h theta. Sin h theta is equal to um, uh, sin h theta is equal to e power theta minus e power minus theta divided by 2, right? So here we have sin h 2t, so this will be same as e power 2t minus e power minus 2t divided by 2 whole cube, right? So I'm just replacing theta by 2t, so you will have e power 2t minus e power minus 2t 2, or you can also use this formula, replace a by 2, both are same, right? Yes. Now we need to find the Laplace transform for this function. For that, what we will do is we will simplify this and then we will apply Laplace transform. So if I expand this, we will have, so I can take this 1 by 2 outside, that means this will be 1 by 8, right? Because 2 cube is 8, so if I take that outside, we will have 1 by 8. So inside we will have e power 2t minus e power minus 2t whole. So I'm going to apply a minus b whole cube formula. This will be a cube minus 3a square b, right? 3a square b plus 3ab square minus b cube, right? I've just applied a minus b whole cube formula. A minus b whole cube formula will be, this will be a cube minus 3a square b plus 3ab square minus b cube. You just take this e power 2t as a and e power minus 2t as b. So a cube, take this as b, take this as a, take this as b. So you'll be having a minus b whole cube formula. So a cube, so e power 2t whole cube minus 3 a square b. So e power 2t square into e power minus 2t plus 3ab square, 3 into a into b square minus b cube, right? I've just expanded this in minus b whole cube formula. So now this will be equal to 1 by 8. This is same as e power 3 into 2, so e power 60, right? So both are in power, so you can multiply that. So e power 60 minus 3 times this same as e power 4t into e power minus 2t plus 3 times this is e power 2t into e power minus 4t minus e power minus 6, right? I just multiplied minus 2t into 3 and then I multiply this 2 with this, I multiply this 2. Now I will simplify this to some more extent. So if we are having this as 1 by 8 e power 60 minus 3 times, so this is so both are e, right? So therefore I can add the powers. So 4t minus 2t, so this will be e power 2t plus 3 times e power minus 2t, right? Because 2t minus 4t is minus 2t, this will be having e power minus 6. Now I'm going to apply Laplace transform, right? So far I haven't applied Laplace transform yet. So far I have just simplified the question as of now, right? The question is sin h cube of 2t. As of now I've just simplified the question, right? Yes. So now what we'll do is we will apply Laplace transform on both sides. So apply Laplace transform on both sides. So if I apply Laplace transform, here we will have L of f of t. So my f of t is equal to sin h cube of 2t, right? Yes. So and I can apply Laplace transform inside, right? I can take L inside. Why? Because L satisfies linearity property. This is same as L of e power 60 minus 3 times L of e power 2t plus 3 times L of e power minus 2t plus L of e power minus 6, right? Actually I should have L here. I can also take L inside because L satisfies linearity property, right? I've taken L inside because L satisfies linearity property. Okay, so this will be, so we know the formula. What is the first formula? L of e power at equal to 1 by s minus a and L of e power minus at equal to 1 by s plus a, right? These two are the formulas that we already derived also. So apply that, you will have the answer, right? Apply that, simplify, you will have answer. So this will be equal to 1 by 8. Now what is L of e power at? So this is 1 by s minus 6, right? E power at plus at is 1 by s minus a. So my a is 6 here. Minus 3 divided by L of e power 2t is 1 by s minus 2. What I will do is give some space here. Yes. So what I'll do is we'll leave some space. So this will be equal to 1 by 8. Now L of e power 60 is 1 by s minus 6 minus 3 times this will be 1 by s minus 2 plus already we have 3, and L of e power minus 2d is 1 by s plus 2 minus L of this will be 1 by s plus 6, right? This is the required Laplace transform for the function sin h cube of 3t. If you want, you can also simplify. It will be 1 by 8. If you want, you can also simplify, right? That is actually here we have e power. What you can do is you can take LCM, right? So you can take LCM. So just combine this and this 1 by s minus 6 minus 1 by s plus 6, and then you can also combine these two terms by taking 3 outside, be 1 by 2 minus by s minus 2. Actually you can leave at this stage itself, but if you want some smaller answer means you can also simplify this to some more extent. So this will be, you just take LCM here, it will be 1 by 8. So cross multiply this, so you'll be having s plus 6 minus 6 divided by minus 6 to s plus 6. And the second LCM, right? Or you can also cross multiply s 6 minus s minus 6 by s minus 6 6 plus 3 times minus 2 minus plus 2 divided by plus 2 into minus 2, right? Be equal to 1 by 8. This and s will get cancelled. So 6 minus half minus 6 will be 12 divided by, so this will be a plus b, a minus b, right? So it will be a square minus square plus 3 times. So again this s will get cancelled. Here it will not get cancelled, right? Here we have s minus 2 minus s plus 2. So yes, s will get cancelled. Here we are having minus 2 minus 2. So it will be minus 4 divided by, again a plus b, a minus b, will be having a square minus b square. So this will be equal to 1 by 8 divided by s square minus 6 divided by square minus 4. If you want to simplify this some more extent mean, again you take LCM for these two, you can also do that, right? You have time. So again you take cross multiply this, so you'll be having 2 times 4, 12 times here minus 36 divided by s square minus 4 into s square minus 36. Right? So this is the required Laplace transform. If you want, you can also simplify for extent. It will be 1 by 8, 12s square, and this 12s square will get cancelled. So if you simplify this, what you will have is after simplifying, what you will have is, I'll just directly write down the answer. So you will be having the answer as, 48 divided by s square minus 4 square minus 3 required. You keep this this denominator as it is. You multiply this 12s square, and get cancelled. You'll be having this here. You will be having 12 into minus 44. So 12 into minus 4 is minus 48. So minus 48 plus this divided by 8. You'll be having this as 48. 48 divided by s square minus 4 into square minus. So this is the required Laplace transform for sin h cube 2t, right? It's very easy. First I have simplified sin h cube 2t, and then I have used an a minus b whole cube formula. I have applied sin h theta formula, and then I have used an a minus b whole cube formula, expanded, applied L, and then I have simplified, right? Very what we will do is we will solve 10th problem, right? So far we have solved 9 problems. After solving this, we will be moving on to the next subtopic. We will be seeing some properties of Laplace transform. Right, yes. So we will solve this problem quickly. We will solve this quickly. So first we need to find the Laplace transform of f of t is equal to 1 plus 2 root t divided by t by root t, right? Yes. So we will find this. So we have f of t is equal to 1 plus 2 times root t plus 3 divided by root t, right? Yes. Now we will apply L on both sides, and then need to find the Laplace transform. So apply L on both sides. So you'll be having L of f of t is equal to L of 1 plus 2t divided by t by root t, right? Now we know that L satisfies linearity property. This is L of 1 plus 2 times L of root t plus t into L of 1 by root t, right? Yes. Now this is same as, now we know that L of 1 is 1 by s, and we will keep this as it is, right? L of we will write this as L of t power 1 by 2, L of t power 1 by 2 plus 3 into L of t power minus 1 by 2, right? Because t power 1, root t is t power 1 by 2. If we take that to numerator, here we will have minus 1 by 2. Now we need to find the Laplace transform for L of t power 1 by 2 and L of t power minus 1 by 2, right? Yes. Now recall the formula of L of t power n, right? L of t power n will be gamma of n plus 1 divided by s power n plus 1 if n is strictly greater than minus 1 and if that n is real number, and this will be equal to n factorial by s power n plus 1, and this will be equal to n factorial by s power n plus 1 if that n is a whole number, right? A whole number is if n is equal to 0, 1, 2, 3, etc. This is the formula that we already discussed, right? Yes. Now you need to apply this formula because this 1 by 2 is not whole number, right? This 1 by 2 and this minus 1 by 2 is not whole number. If that is whole number means we can apply n factorial by s power n plus 1. But here you have 1 by 2 which is not whole number, and also both are greater than minus 1 and belongs to real number. Therefore, we can directly use this formula. This will be after applying the formula, what we will have, this will be equal to 1 by 6, already we have 2. Now apply the formula L of t power n, it will be gamma of n plus 1 divided by n power n plus 1, right? Now this substituted in formula and substitute n to be equal to 1, 2, and here we will having 3 times gamma of minus 1 by 2 plus 1 divided by s power minus 1 by 2 plus 1, right? So in formula I just substituted n to be equal to 1 by 2 and n to be equal to minus 1 by 2, right? So this will be equal to 1 by s plus 2 into gamma of 3 by 2 divided by s power 3 by 2 plus 3 times will be gamma of 1 by 2 divided by power, this will be s power 1 by 2, right? S power 1. Now I'm going to make use of two results. The first result is gamma of n plus 1 is same as n into gamma of n. These are the basic properties of gamma integral. And then gamma of 1 by 2 is equal to root pi, right? Root of pi clearly root of pi, right? So it will be equal to root of pi. If you can easily prove this, right? So what you can easily prove this, that is gamma of n plus 1 is same as n times gamma of n. You can easily prove this. How? Because we know the formula for gamma of n, right? I already given the formula. You can see what is gamma of n. What is gamma of n? Gamma of n is integral 0 to infinity x power n minus 1 e power minus x dx, right? You will take this formula. If you want, I can also prove that. So gamma of n is, you will take that formula, right? So we have gamma of n to be equal to integral 0 to infinity x power n minus 1 e power minus x. So x power n minus 1 e power minus x dx, right? Dx. Now what will be my gamma of n plus 1? This will be integral 0 to infinity. Replace n by n plus 1. So you'll be having this as n plus 1 minus 1 e power minus x dx, right? E power minus x dx. This will be equal to integral 0 to infinity x power n into e power minus x dx, right? E power minus x dx. Now integrate this, you keep u to be equal to x power n and you take b dv is equal to e power minus x. That means what is du? Du will be n into x power n minus 1 and b is equal to minus e power minus x, right? Now I'm just applying integration by parts. This will be uv minus integral v du. So what is u? So u is x power n. And what is b? B is minus e power minus x. Limit is from 0 to infinity minus integral v du p is minus e power minus x, and du, this du by dx, right? And du is same as n into x power n minus 1 dx, right? Now when you apply limit, this will tend to 0, right? Because e power minus infinity is 0 and 0 into something, so this upper limit and lower limit both will be equal to 0. And here if you take this minus inside, it will be plus integral 0 to infinity will be e power minus x n into x power n minus 1 dx, right? Now this is same as if I take this n outside, we will be left with integral 0 to infinity x power n minus 1 e power minus x dx, right? Now what is this formula? This formula is nothing but gamma of n plus 1, right? So gamma of n is integral 0 to infinity e power n minus 1 e power minus x dx. Now what is gamma of n plus 1? It will be x power n e power minus x dx, right? We will be having x power n minus 1 e power minus x dx, right? This will be n plus 1 minus 1, right? E power minus x, and here we will be having x power, sorry, this is the formula for gamma of n, right? So this is same as gamma of n. Gamma of n, so integral 0 to infinity x power n minus 1 e power minus x dx, right? Sorry, it's a gamma of n plus 1. Gamma of n is 0 to infinity. We'll take this n outside, it will be e power minus x power n minus 1 dx, right? So therefore this is same as integral 0 to infinity x power n minus 1 e power minus x dx. Now what is this? This is again gamma of n, right? This is nothing but gamma of n. Gamma of n is integral 0 to infinity x power n minus 1 e power minus x dx, right? So again we have got same gamma of n into gamma of n. So we have started with what? We have started with gamma of n plus 1, right? Started gamma of n plus 1, and then we have proved that it is equal to n into gamma of n. Therefore, gamma of n plus 1 is as n into gamma of n, and this n is greater than 0, right? This is the basic results from gamma integral. I'm going to use this result now, right? And also similarly, you can also prove that gamma of 1 by 2 is equal to root of pi. These are very basic definitions of gamma integral. So I'll repeat, gamma of n is this formula, right? So I have already given the formula for gamma integral. It is gamma of n is equal to integral 0 to infinity x power n minus 1 e power minus x. I'm going to find gamma of n plus 1. My gamma of n plus 1 will be integral 0 to infinity x power n plus 1 minus 1 e power minus x dx. So I'm getting this, right? Gamma of n plus 1 is this. I'm going to integrate this. I'm going to do it by integration by parts. So take this as u, take this as b. So integral u dv, right? Integral u dv, uv dv is equal to uv minus integral v du. So I've taken this as u. U into p is e power minus differentiate. Integrate that, you'll be having minus of minus e power minus x minus integral v du. Very elementary, right? So if I apply integration by parts, this term will get vanished. So here we'll be having this as plus e power minus x n into x power n minus 1 dx. Take the n outside. This is the formula for gamma of n. So we have started with gamma of n plus 1. If I integrate this, I am getting this as n into gamma of n. So gamma of n plus 1 is same as n into gamma of n. And also you can also similarly prove that gamma of 1 by 2 is equal to root pi, right? Yes. So I'm going to make use of these two formulas, right? Gamma of n plus 1 is n into gamma of n. Gamma of 1 by 2 is equal to root pi. So this will be equal to 1 by 2. I'm going to write this 3 by 2 as 1 plus 1 by 2 or 1 by 2 plus 1, right? So I'm going to write this as 1 by 2 plus 1 divided by power 3 by 2 plus 3 into, I'm going to write, let us keep this as it is, right? Gamma of 1 by 2 divided by s power 1 by 2. Now you can see I'm going to use the formula that the gamma of n plus 1, right? Gamma of n plus 1 is equal to n into gamma of n, right? So gamma of n plus 1 is same as n into gamma of 1. So already we have 2 here. So gamma of n plus 1 is same as n into gamma of n. Right? Gamma of n plus 1 is same as n into gamma of n divided by s power 3 by 2. And we know that gamma of 1 by 2 is root pi. divided by power 1 by 2. Right? Yes. So these two will get cancelled. Again we have gamma of 1 by 2. So this will be 1 by s plus gamma of 1 by 2 is root pi divided by power 3 by 2. Root pi divided by s power 3 by 2 plus 3 root pi divided by s power 1 by 2. The required Laplace transform for the given function, right? 1 by s plus root pi divided by s power 3 by 2 plus 3 root pi by s power 1. Very easy problem. Need to find the Laplace transform for this function. I'm using this formula. In this formula, I'm using the two basic results of gamma integral. That gamma of n plus 1 is equal to gamma of equal to gamma of n plus 1 is same as n into gamma of n, and gamma of 1 by 2 is equal to root pi. So I'm making use of these two formulas. I'm getting the answer very easy. I have just given the proof for gamma of n plus 1 is same as n into gamma of n here. Right? In exam point of view, don't do this, but I cannot simply say that, right? So always remember that gamma of n plus 1 as n into gamma of n, that n is strictly greater than 0, right? So using that here, and then I find the Laplace transform. So far what we did in Laplace transform is that we have defined Laplace transform, and then we have derived the Laplace transform for some elementary functions like L of 1, L of sin, L of cos at, and then L of t power n, L of e power at, L of e power minus at, etc. And then we have solved 10 problems as of now based on Laplace transform, and then we also proved that satisfies the linearity property, right? And then we have solved 10 problems as of now based on Laplace transforms, right? Yes, I mean, what's the previous lectures go through that. So now we'll be moving on to the next subtopic on Laplace transform. We're going to see some properties of Laplace transform. The first property that we're going to see is first shifting property. It is called shifting property. It is called shifting property of Laplace transform, right? So I'll just write it down. We will prove that. Then we will do some problems based on shifting property, right? Shifting property. We will prove shifting property, and then we will do some problems based on shifting property, right? Yes. So what it says is if L of f of t, if L of f of t is equal to some function of s. Suppose L of f of t is the Laplace transform f of t, we will have some answer, call that as f of x, because it is a function of x, right? Then Laplace transform of power at e power at into t, same as f of s minus e, right? This is the first shifting property. Also L of power minus of t equal to of s. This is the shift, is called the shifting property of Laplace transform. Right? Very important property. Suppose if you need to find the Laplace transform of e power at into f of t, it is enough to find f of s. That is it is okay. First we'll prove that, and then I will simplify, right? And then I will see, and then I will tell how to do in problem point of view, right? That is, you find L of f of t. In that answer you replace s by s minus a. That's it, right? Because what is f of x? F of x is the Laplace transform of f of t. So that means you find the Laplace transform of f of t, and then you replace this s by s minus a. That's it, right? So okay, first we'll prove this, and then I will explain in problem point of view, right? Yes, proof. We'll prove this, right? Yes. Now, so we need to prove. Okay, we know that what is L of f of t. So L of f of t is integral 0 to infinity e power minus st f of t dt, right? This is the Laplace transform definition. Now we need to prove that L of, let us call this as f of x, right? It is given that the answer will be some f of x, right? Yes, because it's a function of x, answer will be. Now what is L of e power at into f of t? That is, you replace this f of t by e power at into f of t. It will be integral 0 to e power st. So instead of f of t, I am going to write this as e power at into f of t dt, right? So you can see if I have f of t, we should have f of t here. Here we have e power at f of t, so I'm substituting e power at f of t. So just integrate this, or we will simplify this into 0 to infinity. We just combine these e terms, so that means this is same as e power minus st plus at into f of t dt, right? Yes. Now this is equal to integral 0 to infinity e power, if I take this minus s common, right? If I take this minus s common, so what we will be having? We will be having okay, we will take minus t common, right? We will take e power minus t common. So if I take e power minus t common, we will be having this as s minus a, right? S minus a into f of t dt. What is this? E power minus st f of t dt. So we know this is nothing but f of s minus a. This is nothing but f of s minus a. Yes or no? So because what is f of s? F of s is integral 0 to infinity e power minus st f of t dt. Now what is f of s minus a? Replace s by s minus a. This will be integral 0 to infinity e power minus, replace s by s minus a. We will be having this, right? This is nothing but f of s minus a. So we have started with L of e power at f of t dt, and then we have put that it's equal to f of s minus a, right? Because the Laplace transform of this function is assuming it is equal to f of s, right? L of f of t is assuming it is equal to f of x. Now what is f of s? What is f of s minus a? Replace s by s minus a. That is what we have got here, right? So therefore, L of e power at f of t is equal to f of s minus a, where f of s is the Laplace transform or f of t, right? First we will prove that, and then I will tell you in very easy manner, so that it will be very easy for you to follow. Now similarly, we need to prove L of e power minus at f of t is equal to. So similarly, we will prove the second part. Similarly, we know that L of f of t is equal to integral 0 to infinity e power minus at f of t dt. So therefore, L of e power minus at f of t will be equal to integral 0 to infinity e power minus t. Now what is f of t? E power minus at into f of t dt, right? So this will be integral 0 to infinity. So if I take this minus t outside, you will be having this as s plus a into f of t dt. This is nothing but f of s plus a, right? Because all this as f of s. So replace s by s plus a, you will be having the e power minus s plus a t f of t dt, right? So therefore, this is the actually we have proved the theorem, right? Very easy theorem. So in problem point of view, what you need to do is, suppose you need to find L of e power at into f of t. You need to find L of f of t. Find Laplace transform or f of t, and then you replace s by s minus a. That's it, right? Replace s by s minus a, because L of e power at is f of s minus a, right? So theorem point of view, you understand like this. What it means is f of s is the Laplace transform or f of t. In that f of s, you replace s by s minus a. That's it, right? So understand like this, right? So if you have L of e power at f of t, you find Laplace transform or f of t. In the answer, replace s by s minus a. Similarly, if you have L of e power minus at f of t, you find Laplace transform for f of t, and then you replace s by s plus a, because L of e power minus at f of t is same as f of s plus a. What is capital F? Capital F is the Laplace transform for f of t. So in that you replace s by s plus a, right? That is, you understand. You need to understand this. That's it, right? So L of e power at f of t. L of e power at f of t is, you find Laplace transform for f of t, replace s by s minus a, and then L of e power minus at f of t is equal to, so find Laplace transform for f of t, and then you replace s by s plus a, right? If you have a, replace s by s minus a. If you have minus a, replace s by s plus a, right? Very important property. It is called shifting property, right? L of if L of f of t is equal to s, this if Laplace transform for f of t is capital F of x, then the Laplace transform for e power at f of t will be, so you find Laplace transform for L of f of t, that is find the Laplace transform for f of t. In the answer, you replace s by s minus, That's what it means, right? That is this is what it means. If you want to find the Laplace transform for e power at f of t, find the Laplace transform for f of t alone. In that answer, replace s by s minus a. Similarly, if you want to find the Laplace transform for e power, this f of t can be anything, right? So, but if you have e power at into something, e power minus at into something, you can use shifting property that you find Laplace transform by this alone and replace s by a, and you find Laplace transform by this alone and replace s by s plus a. Okay, very important property. So, based upon this property, we will prove problems based on shifting property. Problems on shifting property. As of now, what we did is we have solved. First, we have introduced the definition of Laplace transformation, and then we have find the Laplace transform for some elementary functions. And we have solved 10 problems based on that. After that, we are moved on to shifting property of Laplace transform. So we have proved shifting property in the previous video. Now we will do some problems based on shifting property. This video and the upcoming. So find the Laplace transform. Find the Laplace transform of the following. Okay? Find the Laplace transform of the following. First, we need to find the Laplace transform of L of, find L of e power 2t sine 2t. Right? Now we can apply shifting property, right? Because L of e power at f of t. This is nothing but you find the Laplace transform for sine 2t and then you replace s by s. That's it, right? Because you can see L of e power at is f of t is L of f of t. You find the Laplace transform for f of t and then you replace s by s minus a. So here my a is 2 here, right? L of e power 2t sine t, and the Laplace transform for sine e power at f of t, right? Just compare this with e power at f of t. Find Laplace transform for sine 2t, replace s by s minus 2. Now what is L of sine 2t? So we know that L of sine at will be a by s square. What is L of sine at? So we have already proved this, right? So L of sine at will be s divided by s square plus a divided by s square plus a square is the formula for L of sine at, and then you will use this. Sorry, sine 2t will be 2 divided by s square plus 2 square, and then you replace s by s plus 2. So it will be equal to 2 divided by square plus 4. Then you replace s by s plus 2. That is, when the Laplace transform for sine t is that answer, replace s by s minus 2. Right? So replace s by s minus 2. So we'll be having this as 2 divided by s minus 2 whole square. So that's it. This is the required answer, right? Very easy. We want to simplify on this. So square plus b square minus 2ab plus 4 will be 2 divided by s square minus s plus 8, the required Laplace transform, right? On to second problem. The Laplace transform of L of e power minus t cos 3. This is same as you find the Laplace transform of cos 3t. In that you replace s by s plus 2, right? Because if you have e power minus at means s plus a, e power at means s minus, right? What is the Laplace transform of cos at? Of cos at will be s divided by square plus a square, will be s divided by s square plus 3 square, the Laplace transform for cos 3t, and then you replace s by s plus 2. So this will be s divided by s square plus 9. So in that this is the Laplace transform for cos 3t, that you replace s by s plus 2. This will be same as s plus 2 divided by s plus 2 whole square plus 9 is the required Laplace, the required. And if you want, you can also. So we'll move on to third problem. So L of e power minus 5t into t square. So just compare this with L of e power minus 80 f of t. So you find the Laplace transform of t square. In that you replace s by s plus 5, right? Because we have e power minus at. In that case, you need to replace s by s plus a. So you find the Laplace transform for L of t power n. So L of t power n will be n factorial by s power n plus 1 because my belongs to whole number. This is nothing but 2 factorial divided by 2 s power 2 plus 1. Replace s by s plus 5 because we need to find the Laplace transform for e power minus 5t t, right? So you can apply shifting property whenever you have e power 5t into something or e power minus 5t into something. That is e power 8t into something or e power minus 80 into something. This is nothing but 2 by s cube. In that you replace s by s plus 5, so that we will be having the answer as 2 divided by s plus 5 whole cube. The required answer, right? It's very easy. So I'll move on to fourth problem. L of e power t into cos h 2t, right? Cos h 2t. What this will be? To find the Laplace transform of cos h 2t. In that answer you replace s by s minus 1 because e power at. So a is 1 here, we have plus, that means you replace s by s minus 1, right? This if you have e power at means it will be replaced by s minus a, right? So go to shifting property again. L of you have plus e power at means replace s by s minus a, and if you have L of e power minus at means replace s by s plus a. So what is L of cos h 80? We know that L of cos h 80, right? What is the formula for cos h 80? Cos it proved, right? S divided by s square minus a square. S divided by s square minus a square. Say that s divided by s square minus a square. So apply this, will be s divided by s square minus 4, right? Because a is 2 here, and then you replace by minus 1, so that we will be having the required answer as s minus 1 divided by s minus 1 whole square minus the required Laplace. On to fifth term. So L of e power minus 5t into let us create some new function, whatever we want, right? We can find whatever. Let us write this, let us keep this as sin phi t, right? What this will be? So you find the Laplace transform of sin phi t, that you replace s by s plus 5, right? In that you replace s by s 5. What is L of phi t? 5 divided by s square plus 5 square, because L of sin 80 is a divided by s square plus a square, that you replace s by s minus 5. So this will be 5 divided by s plus 5 whole square 25 is the required Laplace transform of e power minus 5t sin 5t. So now we move on to sixth problem. So find the Laplace transform of cos h 80 into sin 80. Cannot apply L directly because it is not plus, it is multiplication here. So we need to find the Laplace transform of cos h 80 to sin 80. Okay. Now what is cos h theta? Cos h theta is e power theta plus e power minus theta divided by 2. Right? Sin h theta will be e power theta minus e power minus theta by 2. Cos theta will be e power theta plus e power minus theta by 2. So therefore I can replace this cos h 80 as e power 80 plus e power minus 80 divided by 2, right? E power 80 plus e power minus 2. Let us keep this sin 80 as it is. Now I can take this 1 by 2 outside. If I take this 1 by 2 outside, we will be having, I'm going to multiply this e power 80 separately, and I'm going to apply L to the inside because we have plus here. L of e power 80 sin 80 plus L of power minus 80, right? Very easy. After applying the formula for cos h 80, you can see how easy problem becomes. 1 by 2 outside, and I multiply this e power 80 with e and this with sin 80, and then I have applied L. I have taken L inside because we have plus here. This is equal to 1 by 2 into, so you know how to do this, right? You find the Laplace transform of sin 80. In that you replace s by s minus a because you have plus 80, right? And similarly plus put you find the Laplace transform of sin at. In that you replace s by s plus a, because here you have e power at, here you have e power minus at, but both we have sin at, right? No problem. This will be 1 by 2. Now what is L of sin at? A divided by s square plus a square. In that you replace s by s minus a. 1 by 2 is common for both, right? 1 by 2 is common for both. So 1 by 2 is common for both, because 1 by 2 is common for both, right? So this will be a divided by square plus a square, replace s by s plus a, right? A. So this will be equal to 1 by 2. If we replace s by s minus a, we will be having this as s minus a whole square plus a square plus a divided by plus a whole square plus a square is the required Laplace transform for the given function, right? If you want, you can also simplify like taking LCM and so on, but I don't want to do it. You just make use of cos h theta formula, and then you split up, and then you apply Laplace transform this function to this function, and then add L of sin at replace s by a, L of sin at replace s by s plus a. So you will have the required answer. If you want, you can simplify by taking LCM, by taking cross multiplication, etc. But I don't want to do that. If you have time, also take LCM for both, right? So we have solved 6 problems as of now based on shifting property, right? So we will continue with the 7th problem. Continue with 7th problem. So find the Laplace transform of find the Laplace transform of, we need to find the Laplace transform of e power minus 2t power minus 2t sin t to cos t, right? We will find. Very easy problem, right? Laplace transform. So we need to find L of e power minus t sin t into cos 3. Now what we can do is L of e power at f of t is same as L of f of t replace s by s minus a. But what I'm going to do is, here I'm going to simplify this first, right? I'm going to simplify sin t cos t first. What I will do is, I will keep this e power minus 2t as it is. We will simplify sin t cos 3t, right? So we know that sin theta cos theta. What is the formula for that? Already said, right? So sin a cos b. So sin a cos b will be sin a plus b plus sin a minus b divided by 2, right? Sin a plus b. Know that. So we know that sin a cos b 1 by 2 sin a plus b plus sin a minus b, right? Sin a plus b, you can see sin a plus b divided by 2. So what here we have sin t cos 3t. That is you replace so you replace a by t, b by cos 3t. So therefore my sin t cos 3t will be 1 by 2 sin a plus b t plus 3t plus sin t minus 3t, right? So this will be same as 1 by 2 sin of 4t. So sin of minus 2t. So sin of minus theta is same as minus sin theta because it's an odd function. So I can write this as minus of sin 2t. So therefore I can write this sin t cos 3t as, therefore I can write this sin t cos 3t as sin 4t minus sin 2t 1 by 2, right? Write like this, and write this like, right? 1 by 2 sin 4t minus sin 2t. So therefore now I can take L inside because it is a linearity property, right? Because you have plus or minus. So therefore when you find the Laplace transform of this function, I can easily find this. So we have L of, let us take this 1 by 2 outside. So okay, we will write like this, right? E power minus 2t sin 4t minus sin 2t is same as you take L by 2 L, you take 1 by 2 outside. So therefore this is same as L of e power minus 2t into sin 4t minus L of e power minus t to sin t. Right, now we can easily do, very easy, right? How to do this? This will be 1 by 2. So you find the Laplace transform for sin 4t, and then you replace s by s plus 2 because you have e power minus 2t, right? And similarly you find the Laplace transform for sin e, and then the answer you replace s by s plus 2, right? Because you have e power minus 2t. So now this will be equal to 1 by 2. So what is L of sin 80? So we know that L of sin 80 will be a divided by s square plus a square. This will be 4 divided by s square plus 4 square. So in that you replace, actually we have 1 by 2 for both the term, right? Let me put one curly bracket here. So in that you replace s by s plus 2 minus, and what is L of sin 2t? So 2 divided by s square plus 2 square. Here my a is 4, here my a is 2, right, in the formula. Now you replace s by s plus 2. This will be equal to 1 by 2. So this will be 4 divided by s plus 2 plus 16 minus divided by plus 2 plus 4 is the required Laplace transformation. If you want, you can also simplify also, right? You can also simplify by taking LCM for these two terms, right? By taking LCM for these two terms. If you want to simplify, you can simplify, right? On simplify, like, so just multiply this, cross multiply, then cross multiply with this, then you multiply these two terms and simplify, no problem, right? So I'll stop it here. Both are same only, right? Both are same. So now we will on to some more problems. On to ninth problem, right? Sorry, how many problems you have solved? Eighth problem, right? So very easy problem. So you just have to, I'm just converted sin t cos sin a cos b formula, using this formula, and then I apply linearity property, and then I apply shifting property. I'll move on to the eighth problem. Find the Laplace transform. Find the Laplace transform of e power minus 3t 2 times cos phi t minus 3 times sin phi t, right? Yes, and this t is greater than or equal to. Very easy, right? You can do this directly because already it is in linear, as it is plus or minus. So we need to find L of e power minus 3t 2 times cos phi t minus 3 times t. This is same as L of e power minus 3t into 2 times cos phi t minus L of 3 times power minus 3t sin phi t. Okay. Now I can take this 2 outside. So 2 times L of 2 times L of e power minus 3t cos phi t minus 3 times L of power minus t sin phi t. Now is very easy, right? So that means you just keep this 2 as it is. You find the Laplace transform for cos phi t. That answer you replace s by s plus 3 minus, already we have 3 here. So you just find the Laplace transform for sin phi t, that you replace s by s plus 3. So so it is easy for you, right? What is L of cos at? L of cos at will be a divided s divided by s square plus a square, will be s divided by s square plus 5 square. Then you replace s by s plus 3 because we have e power minus 3d, right? I'm using shifting property. T divided by sorry, here we have sin 80, right? So this will be 5. Sin phi t will be 5 divided by s square plus 5 square, because of sin 80 is a divided by s square plus a square. So in that you replace s by s plus 3. So will be 2 times plus 3 divided by plus 3 whole square plus 5 square minus, multiply this inside, we will be having this as 15 divided by, okay, replace s by s plus 3, right? So this will be s plus 3 whole square plus 25, the required answer. X square plus a square, here we have cos phi t, right? If you want, you can simplify. So how can you simplify this? That you can see both the bases are same, right? S plus 3 whole square plus 25 will be 2 times s plus 3 minus 15 divided by s plus 3 whole square plus 25, because both the same, both the base are same, right? It is 5 square is 25. So by simplify this, we will be having this as 2s. So this will be 6, right? And the 6 and the 6 minus 13. So 6 minus 13 will be 2s plus 6. Sorry, it is 15. Sorry, 15. This will be s plus 6, 15 divided by s plus 3 whole plus 25, same as 2s 9 divided by s plus 3 whole square plus 25 is the square Laplace transform for e power minus 2 cos phi times sin phi, right? So we will solve ninth problem, right? So ninth problem, find the Laplace transform, find the Laplace transform of sin h3t, sin h to cos square t, right? We need to find the Laplace transform of this function. What we will do is, before finding Laplace transform, we will simplify this function, right? Because it is not linear, it is not plus or something. What we will do is, we will transform this, right? We will transform this. So how I'm going to transform this there? So we know that cos square theta is same as 1 plus cos 2 theta by 2. We already used formulas. So I'm going to write, we need to find the Laplace transform of sin h3t into cos square t, right? Same as L of, let us keep this sin h3t as it is. Let us keep this h3 as it is, and I'm going to replace this cos square t as 1 plus cos 2t divided by, right? Cos square theta is 1 plus cos 2 theta by 2. Instead of theta, here we have this to be equal to t. Now this is same as, if I multiply this with the sin h3 by 2, this will be L of sin h3t divided by 2 plus 1 by 2 sin h2 cos t. See, let's multiply this with by 2 and cos 2t. Now this is same as what I can do is, you just take this 1 by 2 outside. So 1 by 2 into L of h3t plus 1 by 2 into L of sin h3t into cos 2, right? Into cos 2. Now what is L of sin h2, sin hat? So we know that L of sin hat, L of sin h of at will be a divided by square minus a, right? We already proved this. So therefore I can replace this, I write this as 3 divided by square minus 9, and let's keep this as it is, right? Let's keep this as it is, 1 by 2 into L of sin h dt cos 2. Don't know the Laplace transform for this function, right? Because we cannot like this, we cannot, because L of AB is not L of A into L of B. If I have plus here, I can write L of sin dt plus L of cos 2t. But the problem is here we have multiplication, right? In between sinus 3t and cos 2t, here we have multiplication. That means we need to make some other substitution here. Call this as equation number 1. The equation 1 is the final answer, but what we will do is, we will find the Laplace transform for sin h3t cos 2, right? So now what we will do is, we will find the Laplace transform. So we will find the Laplace transform of sin h3t into cos t. So I'm going to find the Laplace transform of this. How to find this, right? What is L of sin h at e power at minus e power minus t divided by 2 into cos 2t, because we know that sin h theta is equal to e power theta minus e power minus theta by 2. Replace theta by 3t. You will be having this as e power 3t minus e power minus 3t divided by 2. Now you can find the Laplace transform very easily, right? Because you can take this 1 by 2 outside and you just multiply this e power 3t with cos 2t, e power minus with cos 2t, and then apply L of e power 3t cos 2t minus, because you have minus here, L of power minus 3t to cos 2. Very easy problem, right? You know how to do this now. This will be equal to 1 by 2. Find the Laplace transform of cos 2t. After that, you replace s by s minus 3. And similarly, you find the Laplace transform for cos 2t, and then you replace s by s plus 3. Required. When you simplify this, you will get the required answer, right? Because I'm using the shifting property, right? Use shifting property. Use shifting property. So find the Laplace transform of cos 2t. So what is the Laplace transform of cos 2t? It will be s divided by s square plus a square. So my a is 2. So in that you replace s by s minus 3 minus, what is L of cos 2t? Again it is s divided by s square plus 2 square. Will be s divided by s square plus 4. Here you replace s by s plus 3. Will be equal to 1 by 2 s minus 3 divided by s minus 3 whole square plus 4 minus s plus 3, because here you need to replace s by s plus 3, here you need to replace s by s minus 3, right? So this will be s plus 3 whole square plus 4. This is the Laplace transform for sin h 3t into cos 2t. If you want, you can also simplify, right? How to simplify? Cross multiply and then simplify. This will be equal to 1 by 2. If you cross multiply this, you will be having s minus 3 into, you will be having one very long term, right? We will be having the very long term s minus 3 into s minus 3 into plus 3 whole square 4 minus, and this into this, right? Plus 3 into minus 3 whole square plus 4 divided by minus 3 whole square plus 4 s plus 3 whole square plus 4, right? So and this is the Laplace transformation for this function. I think we don't even need this, right? Actually 2 by 4 is same as 1 by 2, right? 2 by 4 is same as 1 by 2. So here we have 2 by 4, no problem. Let me keep that as it is, right? We don't need to simplify this. Let me keep this as the Laplace transform for the given function, right? Yes. So this is, remember the problem is not yet over, right? Problem is not yet over, because we are only we need to substitute back here, right? Yes. Substitute back here. So let me call this as equation number 2, right? So put equation number 2 in 1. Put 2 in 1. So we need to find the Laplace transform of, put 2 in 1, what you will have. So this is Laplace transform of sin h 3t into cos square t. Sin h 3t to cos square t. So this will be equal to, so we have already got this as 1 by 2 into 3 divided by s square minus 9 plus this is from 1, right? From 1 we have plus L of, actually we have 1 by 2 also, right? Plus 1 by 2. Now we have L of sin h 3t cos 2t. That answer is given here, right? That answer is this full answer. We put that here. We will be having this as by 2 s minus 3 divided by minus 3 whole square plus 4 minus s plus 3 divided by plus 3 whole square 4 is the required Laplace transformation for this function, right? If you want, you can simplify 3 into 2 divided by s square minus 9 plus 1 by 4, multiply this 1 by 2 inside, 1 by 4 minus 3 plus 4 minus plus 3 whole square plus 4. If you want, you can also simplify, right? If you want, you can also simplify by taking LCM, right? By taking LCM. If not, you can leave at this stage itself. This is the required Laplace transformation for sin s 3t cos square t. On to next problem. Find the Laplace transform of so this question is e power minus 5t cos h 3t, right? E power minus 5t cos h 3t. So we know that cos h 3t formula also, right? It's very easy. So we need to find the Laplace transform for e power minus 5t into cos h 3t. This is nothing but L of the Laplace transform for cos h 3t. In that after that you replace s by s plus 5. Now what is Laplace transform for cos h 3t? So it will be s divided by s square plus 9, right? S divided by s square plus a square. A is 3 here. In that you replace s by s plus 5. This will be equal to s plus 5 divided by s plus 5 divided by s, sorry, cos h 3t is minus, right? Sorry, minus 9, right? Yes, will be s square minus 9, right? Because cos h at will be s divided by square minus a. Cos at will be s divided by s square plus a square, but yeah, cos h at, so will be minus. So replace s by s plus 5. So this will be s square minus the required Laplace transformation. Or you can also do like this is very easy, right? If not, you can suppose if you forget the formula, for cos h 3t, that is, if you forget the formula for L of cos h 3t, you can also do like this, as you need to find the Laplace transform of e power minus 5t cos h 3t, right? Cos h 3t. You can also do like to apply the formula for cos h theta, right? This will be L of e power minus 5t. Now what is L of cos h 3t? Sorry, what is cos h 3t? E power 3t plus e power minus 3t divided by 2, right? This is the formula for cos h 8. What is cos theta? What is cos h theta? It is e power theta plus e power minus theta by 2, right? Here we have cos h 3t, so we will be having e power 3t plus e power minus 2. You can also do like this will be, I will take this 1 by 2 outside. So you take this 1 by 2 outside, you apply, this will be, this into this will be e power minus 2t plus L of e power minus 8t, right? This into this will be minus 5 plus 3 is minus 2, minus 5 minus 3 is minus 8, right? This will be 1 by 2. L of e power minus 2t is 1 by s plus 2, and this will be 1 by s plus 8, right? 1 by s plus 8. If you want, you can also cross multiply this. To cross multiply this, what you will have, so this will be equal to 1 by 2 s plus 8 plus s plus 2 divided by s plus 2 into s plus 8. So this will be equal to 1 by 2s plus 10, right? 2s plus 10 divided by s plus 2 into s plus 8. So if you want, you can also take this 2 outside and cancel this out. So you'll be having s plus 5 divided by we'll be having this as you will be having this as s plus 2 into s plus 8. So both are same actually, right? Here we having here you can see numerator is s plus 5, here also numerator is s plus 5. If you simplify this term, if you simplify this s plus 5 whole square minus 9, you will be having this as s plus 2 s plus 8, right? Both are same. So if you want, also you can also write this as plus 5 whole square minus, both are same, right? So this seems to be very easy, right? In single stroke, if you know the formula for cos h3t, apply Laplace transform for cos h3t directly, replace s by s plus 5. If not, you can also replace cos h3t by e power 3t plus e power minus 3t by 2. Apply multiply e power minus 5t separately. You will be having L of e power minus 2t, L of e power minus 8t. This will be 1 by s plus 2, this will be 1 by s plus 8. Cross multiply this, you will get the same answer, right? Don't think both are different. Here you having s plus 2 s plus 8. If you just expand this in a minus b whole square formula and then subtract 9 and then factorize, you will have both, right? You just expand this in a plus b whole square formula, you will be having a quadratic equation, and if you factorize that quadratic equation, you will be having s plus 2 into s plus s plus 2 into s plus 8. That's what it means, right? We will start, we will do 11th problem, and then I'll give you some homework for you, and then we'll move on to the next video. We'll move on to next subtopic, right? Yes. Problem number 11. So problem number 11 is show that Laplace transformation of sin h t by 2 or sin h 1 by 2, both are same, right? Sin h 1 by 2t into sin sin h sin h 1 by 2t sin root 3 by 2t equal to root t into s divided by 2 times power 4 plus s square plus 1. Right? Very easy problem. Don't think the question is tough, right? Very easy problem. You just have to find the Laplace transformation for this function. You need to put it is equal to this, right? Yes. Solution. So first you find the Laplace transform for this function, right? Yes. So before that, what we will do, here we have product, right? Here you have product. If you have plus means the problem we can finish in 1 second, right? You just apply Laplace transform for this function, apply Laplace for this function, problem will be over. But here we have multiplication, right? Yes. So what we will do is we will give this sin root 3 by 2 as it is. We will apply sin h at. So sin h at will be L of, let me take this here, L of sin h t by 2 into sin at. So here my a value is root 3 by 2. This is same as L of, so instead of sin h t by 2, so sin h theta will be e power theta. So sin h theta will be e power theta minus e power minus theta by 2. So that means here instead of theta we have t by 2. This is e power t by 2 minus e power minus t by 2 divided by 2 into sin root 3 by 2 into t, right? Now I can take this 1 by 2 outside. So we have Laplace transform of power t by 2 into e power t by 2 minus e power minus t by 2 into sine of root 3 t by 2, root 3 t by 2. So this will be equal to 1 by 2. Now this we can apply linearity property, right? So this is same as L of, let me write this, multiply e power t by 2 with this, e power minus t by 2 with this, will be e power t by 2 sine root 3 t by 2 minus of e power minus t by 2 into of root 3 t by 2, right? Now the problem will be very easy. You can apply shifting property now. So find the Laplace transform for sine root 3 t by 2, replace s by s plus 2, right? Will be equal to 1 by 2. So find the Laplace transform for sine, find the Laplace transform of sine root 3 t by 2. In that you replace s by s minus 1 by 2, because e power at, a is 1 by 2. So if you have e power at, replace s by s minus a. Here you find the Laplace transform for sine root 3t by 2, and then you replace s by s plus 1 by 2, because here you have e power minus at, a is equal to minus 1 by 2, right? Yes. Now very easy. Now this will be 1 by 2. Now what is L of sine 80? So a divided by s square plus a square, right? L of sine 80 will be a divided by s square plus a square. A is root 3 by 2. So root 3 by 2 divided by s square plus a square. In that you replace s by s minus 1 by 2 minus, similarly here also sine root 3 by 2. So a divided by s square plus a square. So in that you replace s by s plus 1 by 2, right? Plus 1 by 2. So this will be equal to 1 by 2. So you replace s by s plus 1 by 2. What you will have? So this will be root 3. Okay, I can take this root 3 by 2 outside, right? Because it is disturbing for me. So what I can do is I can take this root 3 by 2 outside. Because root 3 by 2 here also, here also we have root 3 by 2. Let me take this root 3 by 2 outside. Already we have 1 by 2. Let me take this root 3 by 2 outside. So inside what we will be having is, so 1 divided by, now you replace s by s minus 1 by 2 whole square. So if you square this, we will be having 3 by 4, right? 3 by 4 minus, I have taken this root 3 by 2 outside. So 1 divided by, replace s by s plus 1 by 2 whole square. Here we will be having this as 3 by 4, right? Because root 3 square is 3 and 2 square is 4. Now this will be, now you just take LCM for these two terms. So if we take LCM for these two terms, what we'll be having is that, so here we will be having root 3 by 4. So just cross multiply these two terms. So we'll be having this as s plus by 2 whole square plus 3 by 4 minus s minus 1 by 2 whole square plus 3 by 4 whole divided by s minus by 2 square plus 3 into s plus by 2 whole square plus 3 by 4, right? So easy. Now this is very elementary, right? So as some child's play, just have to simplify this, right? Expand this in a plus b whole square formula, expand this in a minus b whole square formula, and then you can simplify this very, right? So you can see this plus 3 by 4 and this minus 3 by 4 will get cancelled. So here you will be having this as root 3 divided by 4. So in the numerator, what you will have is s plus 1 by 2 whole square minus of s minus 1 by 2 whole square. To expand this, you will be having a square plus b square plus 2 times ab. So plus 2 times 1 by 2 into s. That 2 and 1 by 2 will get cancelled. So you will be having this as 3s minus, again similarly, a square plus b square minus 2ab. So 2 times 1 by 2 into s. That 2 and 1 by 2 will get cancelled. So we are having this as s divided by, so divided by, so I think you can do this very easily, right? So similarly you expand this and then you expand s minus 1 by 2 whole square plus 3 by 4, right? And this you will be having this as, sorry, I don't directly, I'm not going to do that. You'll be having this as s square minus s plus 1 into s square plus s plus 1, right? Just expand this in a minus b whole square formula, and then you add 3 by 4, you will have this, right? Very easy. You can see a square plus b square. So we will be having s square plus 1 by 4. That 1 by 4 and 3 by 4 will be 4 by 4, which is 1, minus 2ab will be minus s, right? Here also you can see a square plus b square plus 2ab. So a square you will have s square, 2ab. So 2 times a into b will be s. Here we will be having plus b square is 1 by 4. 1 by 4 plus 3 by 4 is 4 by 4, which is 1, right? Very. Now you can simplify this. So you can see this s square 1 by 4 minus 1 by 4, s minus half minus s. So you will be having this as yes, right? Having this as 2s divided by 2s divided by this will be s square minus s plus 1 into s square minus square plus s plus 1, right? Now what we need to prove? We need to prove it is equal to root 3 s divided by 2 times s power 4 plus s square plus 1, right? Again, very easy. You just have to multiply this with every term, and then you get this, you will be having the required answer, right? So this will be equal to this, and this 2 will get 2, and this 2 will get cancelled. So you'll be having root 3s divided by, here we have 1 2. Now you just multiply this, you just multiply these two terms and then simplify. You will be having this as s power 4 s square plus 1, right? Very easy. Just multiply s square with all three terms. You will be having 3 terms, and multiply minus 8 with these 3 terms. You will be having another 3 terms, and multiply 1 with these 3 terms. So overall you will be having 9 terms, right? Of all the 9 terms, you cancel this, cancel all the 9, cancel whatever it may be cancelled, and simplify that. You will be having this as s power 4 plus s square plus 1. This is what we need to prove, right? This Laplace transform of sin h t by 2 into sin root 3 by 2t is equal to root 3 s divided by 2 times s power 4 plus s square plus 1, right? Yes. So I'll give you some exercise problems for you, that is problems based on shifting property, right? Problems on shifting property. So I'll give you some problems. So find the Laplace transform of, so my problems are 3 cube e power minus 3 will be e power minus 2t and 4t power minus t cos t cos 2t. Very easy. You just apply cos a cos b formula, and then you will have some you'll have plus in between, multiply e power t, e power minus t separately, and then you find Laplace transform of this function and replace s by s plus 1, right? Yes. So d will be sin h at into cos at. That is, you replace sin h at as e power at minus e power minus at by 2. Then you multiply with cos at. You will have two separate terms, and you use shifting property. Power sin h at e power minus t, e power minus 2t sin t into cos q. So I'll just tell you the answer for some of the problems. So I'll just tell you answer for this problem, right? For this problem, my answer will be after simplification, that is after taking LCM, having s square plus 4s plus 14 divided by s square plus 4s plus 3 into s square plus 4s plus 8. That is, these are the answer that you get after taking LCM, right? These two problems are very easy. I'm not going to give you the answer. For this problem, my answer is this, and for sin h at cos at, right? Sin h at into cos at, answer is, for this my answer is a into s square minus 2a. This is after taking LCM, right? This is after taking LCM. S square minus 2a square whole square plus 4a square s square, and for e power minus t cos t, and for this my answer is, this is after taking LCM, right? LCM and simplification, and for this my answer is s plus 1 into s square plus 2s plus 6 divided by s square plus 2s plus 10 into s square plus 2s plus 2. Just try these problems. If you have doubt, you can comment, right? So let's say shifting property is over. What you're going to do is how to find the Laplace transform if we have t power n into f of t, right? So if you have L of e power at into f of t means you can easily use shifting property, right? You just find the Laplace transform for f of t and then you replace s by s minus a. But here if instead of e power at, if you have t power n means what is the Laplace transform for L of t power n into f of t? That is what we are going to see now, right? So what is the formula is, if L of f of t is equal to f of s, right? If Laplace transform of f of t is taken to be f of capital F of s, then L of t power n into f of t is same as minus 1 whole power n dn by dsn of f of s, where f of s is the Laplace transform of f of t. This is what we are going to prove now, right? Very important result, right? We are going to prove this, right? Yes. That is, if you have t power n into f of t means the Laplace transform of this function will be minus 1 whole power n dn by dsn f of s, where f of s is the Laplace transform of f of t, right? Yes. So we will prove this. We will prove this and then we will do some problems based on this, right? Yes. So effect of multiplication of f of t by t power n finding the Laplace transform. So we are going to prove by mathematical induction. We are going to prove by mathematical induction. So we are going to prove by mathematical induction, right? So how we are going to prove is that we are going to prove mathematical induction. So that is, you need to prove it is true for n is equal to 1, right? We need to prove it is true for n is equal to 1. So for n is equal to 1, we need to prove it is true, right? That is, we need to prove L of t into f of t is equal to minus 1 whole power 1 d by ds of f of s, right? D by ds of f of s. That is, we need to prove this. This is what we need to prove, right? L of t into f of t is equal to minus 1 into d by ds of f of s. This is what we need to prove. What is f of s? F of s is the Laplace transform of f of t, right? Yes. So we know that I'm going to make use of the formula. So what is the formula for L of f of t? So we know that L of f of t is, L of f of t is equal to integral 0 to infinity e power minus st f of t dt, right? Yes. Now what I'm going to do is I'm going to differentiate both sides with respect to x, right? So differentiate both side with respect to s. So that means this will be d by ds of L of f of t equal to d by ds of integral 0 to infinity e power minus st f of t dt, right? Now what is L of f of t? It is nothing but f of s, right? So this is d by ds of f of s is equal to, here I'm going to make use of Leibniz rule, right? So what Leibniz rule says is that Leibniz rule, that is differentiation under integral sign. So d by dx of, this is the Leibniz rule you come across in college level, right? That is differentiate under integral sign, right? So that is, if you need to find d by dx of integral u of x to v of x f of x comma dt, this is same as if you are taking this inside, you need to differentiate this partially. So dou by dou x of f of x comma t dt plus, now you just replace t by the upper limit and then you differentiate the upper limit minus you replace t by lower limit and differentiate lower limit. This is what the Leibniz rule says, right? You just make a note of it. D by dx of integral u of x to v of x f of x comma t dt is same as integral u of x to v of x dou by dou x of f of x comma t dt plus you replace t by upper limit and then you differentiate the upper limit with respect to x minus replace t by lower limit and differentiate du by dx, right? This is what Leibniz rule. Now I'm going to make use of Leibniz rule here. Now here it is a function of s comma t, right? You can see this as a function of s comma t, right? You can see this as a function of s comma t. So that means this is same as, so I'm going to apply rule here. So that is, this is same as integral 0 to infinity. So you can see integral 0 to infinity dou by dou s of the function. So dou by dou s of, remember we are differentiating with respect to x, right? So dou by dou s of the given function e power minus st f of t dt. So I completed this process plus f of x comma v of x plus f of x comma t, right? Here it is a function of s comma t, right? Instead of x we have s comma t. That means s comma upper limit. What is upper limit? S comma infinity, right? That is, you need to put t as infinity into d by ds of upper limit, right? That is, you need to differentiate the upper limit, right? So yeah, we have u of x to v of x, d by dx of dx, but here we will be having d by ds, right? Because instead of x we will be having v, right? So f of x comma t, so replace x by s, right? Yes, minus f of s comma lower limit is 0 into d by ds of the lower limit, right? Very easy. I'm just applying the rule as it is. I'm just replacing x by s and t, I'm giving t as it is. I'm putting upper limit v of x to be infinity and I'm putting u of x to be equal to 0 in this formula, right? So replace x by s, keep t as it is. Now you replace this t by upper limit, which is v of x. In our case, it is infinity. So this will be equal to what? This will be equal to integral 0 to infinity rho by dou s of e power minus st f of t dt. Now this entire term will be vanished. Why? Because what is s comma infinity? S comma infinity is e power minus infinity into something. E power minus infinity is 0. And what is again d by ds of 0? This every term will be 0, right? So even though it is not 0, d by ds of 0 is 0. So this every term will be equal to 0. And again here also this will be equal to 0 because in place of t, if you put infinity here, we will be having e power minus infinity, right? Yes. So this is our f of x comma t, right? This is our f of x comma t. Our f of x comma t is equal to e power minus st. It is equal to e power minus st f of t dt. It is our f of yes, right? It is our f of s comma t. Okay, our f of s comma t is e power minus st f of t, right? Yes. So when you put infinity, this will be 0, and when you here we will be having 0 to something, this will be 0. So we will be only having 0 to infinity. So dou by dou s. So differentiate with respect to s. So we will be having e power minus st into minus 1, right? We are differentiating with respect to minus t, right? Minus t into f of t dt. So this will be equal to we will be having this as. So here we are having minus t, right? So this will be minus t into integral 0 to infinity e power minus st f of t dt. So I will write this as minus integral 0 to infinity t into e power minus st f of t dt, right? Now what is this? This is nothing but L of t into f of t. Yes or no? Because L of t into f of t is t into e power minus st f of t dt. So what we have started? We have started with d by ds of f of s. So we have started with d by ds of f of s. So just bring this minus to this side. So we will be having L of t into f of t is equal to minus 1 into d by ds of f of s. This is what we need to prove, right? So therefore it is true for n is equal to 1. Yes or no? So you can see we need to prove it is true in general. If n is equal to 1, we need to prove L of t into f of t is minus 1 d by ds of f of s. So we have started with L of f of t. I have differentiated both sides with respect to s. So it will be d by ds, d by ds. I am applying Leibniz rule, very easy, right? This will be 0, this will be 0. So if we differentiate with respect to s partially, we will be having e power minus st into s will be 1, so it will be minus t. So you take minus outside, so we will be having this as t into e power minus st f of t dt. So this will be equal to L of minus, if I take minus outside, this will be t into f of t, right? E power minus st t into f of t dt. So we have proved that it is true for n is equal to 1. Now we will assume it is true for n is equal to m plus 1 and true for in general, right? Yes. Now what we will do is you will assume it is true for n is equal to 1, right? So assume that it is true for n is equal to 1. So assume it is true for n is equal to 1. Sorry, assume it is true for n is equal to m, right? Now we'll prove it is true for n is equal to m plus 1, right? So assume it is true for n is equal to m. So that is L of t power m f of t is equal to minus 1 whole power m dm divided by dsm of dm by dsm of f of s, right? This is what by your assumption. So what we need to prove? We need to prove it is true for n is equal to m plus 1, right? That is, we need to prove L of t power m plus 1 into f of t is equal to minus 1 whole power m plus 1 dm by dsm plus 1 into f of s. This is what we need to prove, this capital F of s, right? Yes. This is what we need to prove, right? Yes. Now by assumption, what we have is, by assumption, it is true for n is equal to m, right? So therefore we have L of, so by assumption we have it is true for n is equal to m, right? Yes. So what I'm going to do is, so we have it is true for n is equal to m, right? So it will be L of t power m into f of t is equal to minus 1 whole power m dm divided by dsm of f of s. This it is true for n is equal to by assumption, right? Yes. Now what I'm going to do is this same as I can write this as integral 0 to infinity t power m into e power minus st f of t dt, right? L of f of t is integral 0 to infinity e power minus t f of t dt. Here we will be having t power m into f of t. This will be equal to minus 1 whole power m. Let's keep this as it is, right? dm by dsm f of s, right? Yes. Now I'm going to differentiate this both sides with respect to x. So differentiate both sides with respect to s. So this will be equal to d by ds of integral 0 to infinity t power m into e power minus st f of t dt is equal to minus 1 whole power m. If I differentiate this with respect to x, this will be dm plus 1 divided by ds m plus 1 into f of s, right? Now again you apply what? Leibniz rule here. If you take this inside, this will be integral 0 to infinity dou by dou s of t power m into e power minus st f of t dt plus upper limit will be 0, lower limit will be 0, right? Same idea here, right? You can see when you put upper limit f of s comma infinity d by ds of infinity, so f of s comma infinity will tend to 0, and here lower limit also is equal to 0. So again this will be 0, 0. This will be equal to minus 1 whole power m dm divided by ds whole power n plus 1 into f of s, right? Yes. Now you differentiate with respect to s. So t power m keep it as it is. So this will be e power minus st into minus s into f of t dt equal to minus 1 whole power m dm plus 1 divided by ds m plus 1 into f of s, right? Yes. Now what we need to prove, it is true for n is equal to m plus 1, right? It is true for n is equal to m plus 1. This is what we need to prove. Actually we have proved, right? So let us keep this term as it is. Now you just multiply this here we are having t power is minus t, right? Sorry. So differentiate with respect to s means e power minus st into minus t. Yes. So let us keep this minus outside. So integral 0 to infinity so this will be t power m plus 1, right? So multiply this t under t power m. So e power minus st f of t dt is equal to, let us keep this term as it is. Now this is same as what? L of t power m plus 1 into f of t, right? because if we integrate this, we will be having L of f of t is integral 0 to infinity e power minus st f of t dt. Here L of t power m f of t dt is equal to minus 1 whole power m dm plus 1 divided by ds m plus 1 into f of s. So take this minus to this side. So we will be having this as minus 1 whole power. So this will be L of t power m plus 1 into f of t is equal to minus 1 whole power m divided by, so if we bring this inside, we will be having this as minus 1. Now this will be equal to minus 1 whole power, so minus 1 here minus 1, right? So this is same as okay, let me write like minus 1 whole power m plus 1, right? So multiply this with this, so this will be dm plus 1 divided by ds m plus 1 into f of s. So it is true for, therefore it is true for n is equal to m plus 1. So therefore we have proved mathematical induction. So first what we have proved, it is true for n is equal to 1, and then you assume it is true for n is equal to m, and then we have proved that it is true for n is equal to m plus 1, right? Very easy. You just have to make use of Leibniz rule here, right? So therefore hence L of t power n into f of t is equal to minus 1 whole power n dn by dsn of L of f of t, or L of f of t is same as f of s, right? So very easy. So very important in problem point, in exam point of view, you will be using this often, right? So whenever you have t power n with something, you need to make use of this formula, right? You apply Laplace transform or f of t, and then you make this adjustment, and then you differentiate this term, you will get the answer, right? To see effect of division of f of t by t power n and find the Laplace transform. In the previous video, we have discussed the effect of multiplication of f of t by t power n finding the Laplace transform. Now we are going to find the effect of division of f of t by t power n finding the Laplace transform, right? Yes, that is, if you haven't watched the previous video, this is very important. L of t power n f of t is equal to minus 1 whole power n dn by dsn of f of s, where f of s is the Laplace transform of f of t, right? So we will do this problem after proving one more theorem, that is, we are going to prove effect of division of f of t by t power n, right? So we will do that. So effect of division of f of t by t in finding the Laplace transform, right? Hello everyone, welcome. This is lecture number 16 of Laplace transform. In the previous class, what we did is we have proved what is the effect of multiplication of f of t by t power n in finding the Laplace transform. So we have derived this formula that L of t power n f of t is equal to minus 1 whole power n dn by dsn of f of s, right? So very important formula. This f of s is the Laplace transform of f of t, right? So we will do problems based on this after proving one more theorem, that is this theorem, that effect of division of f of t by t in finding the Laplace transform, right? That is what we are going to prove is, let me write the statement and then I will explain this, right? So if f of t is a piecewise continuous on 0, infinity, if f of t is piecewise continuous on the closed interval 0, infinity, and is exponential order n, and if L of f of t is equal to f of s, then Laplace transform of 1 by t into f of t, right? In the previous class we have seen Laplace transform of t power n into f of t, which is minus 1 whole power n dn by dsn of f of s. Here we are going to see the effect of division of t by f of t in finding the Laplace transform. This is same as integral s to infinity. Remember, limit is very important here. It is s to infinity f of s ds, right? Where f of s is the Laplace transform of f of t. This is what we are going to prove now, right? So if f of t is a piecewise continuous on closed interval 0, t, and if L of f of t is f of s, then L of 1 by t f of t is equal to integral s to infinity f of s ds, right? So we'll prove this. We'll prove this. We have what is we know that what is L of f of t. So we know that Laplace transform of f of t is equal to integral 0 to infinity e power minus st into f of t dt, right? Yes. Now this is same as f of s, right? So we have f of s is equal to integral 0 to infinity e power minus st f of t dt. Now what I want to do is I am going to integrate both sides from s to infinity, right? Integrate both sides with respect to we will integrate both sides with respect to s. We integrate both sides with respect to s from s to infinity. That is, I'm going to integrate with respect to s from s to infinity. That is, I'm integrating from s to infinity. Already we have f of s. I'm integrating with respect to ds, right? So I'm going to integrate with s to infinity. Already we have integral 0 to infinity e power minus st f of t dt, and then I'm integrating both sides with respect to with respect to ds with the limit from s to infinity, right? Already we have f of s, and already we have this term. I'm integrating both sides with respect to s to infinity, right? Yes. Let us keep this as it is. So integral s to infinity f of s ds. Let us keep this as it is. Now I'm going to change the order of integration, right? So I'm going to change the order of integration. So this is integral 0 to infinity. I'm going to find integral s to infinity e power minus st f of t ds into dt, right? I'm going to changing the order of integration as the limits are independent, right? Yes. So just integrate this. Let's keep this 0 to infinity as it is. Now integrate this e power minus st f of t dt. So this will be equal to what? We integrate with respect to s, right? So therefore my f of t will be constant. So if I integrate e power minus st, we'll be having e power st divided by minus t, right? We differentiate this s, we'll be having 1. So we'll be having minus t. Since we're integrating, you need to put in the denominator. The limit is from s to infinity into dt, right? Yes. Upper limit and lower limit, this will be equal to integral 0 to infinity. Remember, we are integrating with respect to s means, so that means you need to put upper limit and lower limit to s, right? So this will be f of t into e power s into infinity divided by minus t minus lower limit. So f of t e power minus st divided by minus t. So you just have to replace s by infinity s by s, right? We are integrating with respect to s means, so in s you replace by t, and then you replace s by s as it is, right? Yes, into dt. So this will be equal to integral 0 to infinity. This will vanish because this will tend to 0. So we will be having this as plus f of t e power minus st by t into dt. Now can I write this as L of f of t by t? Can I write like this? I can write like this, right? Because L of f of t is f of t into e power minus f of t dt. So instead of f of t, I am writing f of t as f of t by t. Both are same, right? So where we have started with integral s to infinity f of s. So therefore, what we have proved is L of f of t by t is same as integral s to infinity integral s to infinity f of s ds, right? This is one of the very important property that we will be using in solving the problem, right? So in the previous class, what we did so far is, for the last two videos is conclusion. L of t power n into f of t is equal to -1 whole power n dn by dsn of f of s. This is the first formula we have derived in the last class. Now we have derived L of f of t divided by t is equal to integral s to infinity f of s ds. These are the Laplace transform for these two functions, right? So very important. Here we are differentiating integrating with respect to s, right? That means you need to replace upper limit by infinity, lower limit by s. You need to replace in s, right? Because with respect to s only we are integrating, right? So replace s by infinity and replace s by s as it is. So therefore we will be having f of t by t e power minus f of t dt. This is same as L of f of t by t, right? Remember L of f of t is this. If I divide this by t, we will be having f of t by t, right? That is what I am doing here. So L of f of t by t is equal to integral 0 to infinity e power minus st f of t by t dt. That is what I am using here also, right? Yes. So these are the very most important formulas in Laplace transform. We will do some problems based on this. Right? Yes. Right? Problems. We'll move on to first problem. So find the Laplace transform of t into sin h at, right? T sin h at. That is, we need to find Laplace transform of t into sin h at, right? I'm going to make use of the result that we know. So what we have proved is L of t power n into f of t is same as -1 whole power n dn by dsn of f of s, right? Where f of s is the Laplace transform of f of t. So here we have n to be equal to 1. So this will be equal to -1 divided by d by ds of f of s, right? So this is equal to -1 into d by ds of, what is f of s? F of s is the Laplace transform of f of t. This will be -1 into d by ds of, so what is L of f of t? So we need to find Laplace transform of f of t, right? L of t into f of t, right? So L of f of t is here sin h at. So sin h at, right? This will be equal to -1 into d by ds of L of sin h at. It will be a divided by s square minus a square, right? These are the very formulas that you would be very comfortable, right? So L of sin h at is a by s square minus a square. So we already proved all these, right? Yes. So we will differentiate this with respect to s. So this will be -1 into, you can take a outside. So this will be d by ds of 1 by s square minus a square, right? We differentiate this, you will get the answer. So this will be -1 into a. So what is d by dx of 1 by x? It is -1 by s square, right? So -1 by s square minus a square whole square, and differentiate inside. So s square will be 2s, right? So d by dx of 1 by x is -1 by x square. So instead of instead of x we have s square minus a square. So replace this x by s square minus a square and differentiate inside. So we'll be having this. So you can see here, -1 into this plus here, right? So this minus will be plus, and this will be a into, so we'll be having 2as divided by s square minus a square whole square as the answer, right? So very easy. You just have to differentiate with respect to s, right? You just have to make use of the formula L of t power n f of t is equal to -1 whole power n dn by dsn. Here n is equal to 1, right? t power 1 into f of t. So this will be -1 into d by -1 whole power n. Here n is equal to 1, right? You just put n is equal to 1. Here n is equal to 1. So you find the Laplace transform for sin h at, differentiate with respect to d by ds, you will get the required answer, right? Very easy. So now we'll move on to problem number 2. Find the Laplace transform of t into sine square t, right? T into sine square t. So we need to find the Laplace transform of t into sine square t, right? So again I'm going to make use of the formula L of t power n into f of t is equal to minus 1 whole power n dn by dsn of f of s, where f of s is the Laplace transform of f of t, right? So this is same as, again you put n to be equal to 1. So minus 1 divided by d by ds of f of s. This will be equal to minus 1 into d by ds of, what is L of f of t is f of s, right? L of f of t is f of s, right? Yes. So L of f of t. So this will be minus 1 into d by ds of, now what is L of f of t? You just find the Laplace transform of sine square t, right? L of sine square t, and then you need to substitute here. Call this as equation number 1, right? Now we will find the Laplace transform of sine square t, and on the obtained answer you need to differentiate and then you put minus sign, right? We already know how to find the Laplace transform of sine square t, right? So now we will find Laplace transform of sine square t, right? So we will find this. So L of sine square t. So what is L of sine square t? So it is 1 minus cos 2t by 2, right? So sine square t is 1 minus cos 2t by 2. So this is same as, you just take 1 by 2 outside. So this will be L of 1 minus L of cos 2t, right? L of 1 minus L of cos 2t. So L of 1 is 1 by s. L of 1 is 1 by s, and L of cos 2t, right? This will be s by s square plus a square. L of cos at will be, these are very basic formulas, right? S by s square plus a square. So this will be equal to 1 by 2, 1 by s minus s by s square plus 4 is the Laplace transform for sine square t, right? Let's call this as equation number 2. Now substitute, put 2 in 1. So put 2 in 1. So we have L of t into sine square t is equal to minus 1 into d by ds of L of sine square t, right? L of sine square t. So substitute back here. So this will be minus 1 into d by ds of, so what is L of sine square t? It is 1 by 2 into 1 by s minus s by s square plus 4, right? So this will be equal to minus 1 into, I can take this 1 by 2 outside. So it will be minus 1 by 2 d by ds of 1 by s minus s by s square plus 4, right? So differentiate, you'll get the required answer. So this will be minus 1 by 2. So what is d by ds of 1 by s? It will be minus 1 by s square minus d by ds of s by s square plus 4. Now apply u by v method. This will be minus 1 by 2 minus 1 by s square plus, minus. So you take this as u. So u by v is equal to v into u into v dash by v square. So this will be s square plus 4 will remain as it is. If you differentiate this, this will be 1 minus s into 2s plus 0 divided by s square plus 4 whole square, right? I'm just using quotient rule here. So this will be minus 1 by 2 minus 1 by s square. Now if I simplify this, we'll be having this as s square minus 2s square. So it will be minus s square plus 4 divided by s square plus 4 whole square, right? S square plus 4 whole square. So this is the required answer. This is the required Laplace transform for L of t into sine square t, right? Very easy. you just make use of the formula, find the Laplace transform for sine square t and then differentiate with respect to s and then multiply this. Now find Laplace transform for sine square t, which is 1 by 2, 1 by s minus s by s square plus 4. Now substitute back here. So you need to differentiate with respect to s. So I'm differentiating that. So 1 by s is minus 1 by s square. I'm applying u by v quotient rule here. So we will be having the required answer, right? Next, so we'll start problem number 3. So find the Laplace transform of find the Laplace transform of t square into e power 2t, right? Yes. So we need to find the Laplace transform of t square into e power 2t, right? So we know that L of t power n into f of t is same as minus 1 whole power n dn by dsn f of s, where f of s is the Laplace transform of f of t, right? Put n is equal to 2 here. So this will be minus 1 whole square d square by ds square of f of s, right? What is f of s? F of s is the Laplace transform of f of t. So this will be equal to, this will be plus, so this will be d square by ds square of L of f of t. So f of t is e power 2t, right? So L of t power n f of t. So this is equal to d square by ds square of, so L of e power at will be 1 by s minus 2, right? You just have to differentiate this twice. So if I do once, so 1 by s is minus 1 by x square, right? D by dx of 1 by x is minus 1 by x square. So this will be minus 1 by s minus 2 whole square. You again differentiate this. So I can apply UV method here. So take that minus outside. So s minus 2 whole square into derivative of 1 is 0 minus 1 into, so derivative of this is 2 into s minus 2 divided by s minus 2 whole square, right? I'm taking minus outside and then I'm making use of quotient rule. So this will be equal to, this minus will be plus. So we'll be having this as, this minus will be plus. So this term full will be 0. So 2 times s minus 2 divided by s minus 2 whole square. So this 1 and will cancel. So we'll be having this as 2 by s minus 2, right? 2 by this, when you apply rule, we'll be having x minus 2 whole square, right? This will be s4, right? So we'll be having 2 by s minus 2 whole cube, right? This is the required answer, right? So I'm just writing this as minus 1 into d by ds of 1 by s minus 2 whole square, right? So you keep this minus inside, you apply quotient rule. So d by ds of u by v is equal to v into u into v dash by v square. So keep s minus 2 whole square as it is, differentiate 1, we will be having 0 minus 1 into, differentiate this, we will be having 2 into s minus 2 divided by v square. So v square will be s minus 2 whole square. So it will be s minus 2 whole power 4. So 1 s minus 2 will get cancelled. So we'll be having x minus 2 whole cube here, right? This is the Laplace transform for this. We'll move on to problem number 4. So find the Laplace transform of t into e power minus 2t into sine 2t, right? Here we're going to make use of two property for one problem, right? I'm going to make use of shifting property as well as multiplication of t with f of t also, right? So we need to find Laplace transform of t into e power minus 2t sine 2t, right? First I'm going to make use of shifting property. So you find Laplace transform of t into sine 2t, and then in this answer you replace s by s plus 2, right? I'm making use of shifting property. So what shifting property says, L of e power at f of t is equal to, you find Laplace transform of f of t and then you replace s by s minus a, right? So here we have a to be or L of e power minus at f of t is equal to, you find Laplace transform for f of t and then you replace s by s plus a. That's what I done here, right? Find the Laplace transform for t into sin 2t. In that answer you replace s by s plus 2. So call this as equation number 1. Now we will find the Laplace transform for t into sin 2t, right? So now we will find Laplace transform for t into sin 2t. For that I am going to make use of what? Multiplication property, right? So that is L of t into sin 2t is same as minus 1 into d by ds of f of s. Yes or no? Again I don't want to write the property. Okay, so you just go through the property. What is the property is that L of t power n f of t is equal to minus 1 whole power n dn by dsn of f of s. Put n is equal to 1, then only we will have t here, right? So if you put n is equal to 1, we will be having minus 1 d by ds of f of s. So I'm using that here, right? Yes. This will be minus 1 into d by ds of, now what is f of s? F of s is the Laplace transform of f of t, right? So this is our f of t now. So this will be minus 1 into d by ds of Laplace transform of sin 2t, right? Laplace transform of sin 2t. So what is the Laplace transform of sin 2t? So L of sin 80. So it will be a by, what is the formula for L of sin 80, right? So I already proved all those formula, right? So L of sin 80 will be a by s square plus a square, right? You can see L of sin 80 is a by s square plus a square. So I'm going to make use of the property that a by s square plus a square, right? Yes. So this will be, so differentiate this, it will be minus 1 into d by ds of 2 by s square plus 4. So here constant, right? So you can either use quotient rule or you can directly use u by v, directly use 1 by x formula. So no problem, whatever you can use. So I'll make use of quotient rule. Take this as u, take this as v. So v into u dash minus u into v dash divided by v square divided by v square. So this will be equal to minus of, this term will be vanished. So we'll be having minus 4s, right? Minus 4s divided by s square plus 4 whole square. If we take minus out inside, we'll be having 4s divided by s square plus 4 whole square is the Laplace transform for t sin 2t. Remember, the problem is not over. So from 1 we need to find Laplace transform for t into e power minus 2t sin t, right? L of t into e power minus 2t sin 2t. This will be L of, you just find Laplace transform of t into sin 2t and then you replace s by s plus 2. So we have already found the Laplace transform of t into sin 2t, which is nothing but 4s divided by s square plus 4 whole square. In this you replace s by s plus 2. So this will be 4 into s plus 2 divided by, so 4 into s plus 2 divided by s plus 4 whole square, right? So s plus 2 whole square plus 4 whole square is the required Laplace transform, right? So far very easy problem, right? So we have started with two problems. So we need to find L of t into e power minus 2t sin 2t. So you just find Laplace transform of t into sin 2t, replace s by s plus 2. So for finding L of t into sin 2t, I am making use of the multiplication property. L of t into f of t will be minus 1 into d by ds of L of f of t. So L of sin 2t will be 2 by s square plus 4. So make use of that and then differentiate that. D by ds of f of s will be this will be minus 1, you can either use any of the formula, right? 1 by x is minus 1 by x square. So you can either use one of the formula, right? So I'm applying quotient rule uv. So s square plus 4 into 0 minus 2 into 2s divided by s square plus 4 whole square. 2 square is 4, right? So this will be minus 4s divided by s square plus 4 whole square. This is the Laplace transform of t sine 2t. Now substitute back in 1, replace s by s plus 2. You will get the required answer. Right? Problem. Find the Laplace transform. So find the Laplace transform of t square minus 3t plus 2, t square minus 3t plus 2 into sine 3t, right? So we need to find the Laplace transform for this function. So very interesting problem, easy problem as well, right? Yes. Solution. So we need to find Laplace transform of t square minus 3t plus 2 into sine 3t, right? This is same as Laplace transform of t square into sine 3t minus 3 into t into sine 3t plus 2 into sine 3t. I have just multiplied sine 3t inside, and we know Laplace transform satisfies linearity property. I can take L inside, so this will be L of t square sine 3t minus 3 into L of t into sine 3t plus 2 times L of sine 3t, right? So this is equal to, we don't know this, we will find this L of t square sine 3t minus 3 times, again we don't know what is L of t into sine 3t, and we know this, right? Because L of sine 3t is nothing but a by s square plus a square, a by s square plus a square. Now we don't know these two terms. Now we will find the Laplace transform for this and this, right? Yes. So let us call this as equation number 1. Now we will find these two Laplace transform and then we will substitute back here. Now we will find Laplace transform of t square into sine 3t, right? This is same as minus 1 whole square d square by ds square of f of s, right? I'm making use of the multiplication property that L of t power n into f of t is equal to minus 1 whole power n dn by dsn f of s, right? So put n to be equal to 2. So because we have t square, right, put n to be equal to 2. So we'll be having minus 1 square d square by ds square of f of s, where f of s is the Laplace transform of f of t, right? So this will be equal to, so minus 1, this will be plus 1 into d square by ds square of f of s, where f of s is the Laplace transform of f of t. This is our f of t, right? Yes. So this will be equal to d square by ds square of, now what is L of f of t? So L of sine 3t, right? Remember, you need to take this as f of t now. Okay. Now this will be equal to, so let us keep this as it is, d square by ds square. Now what is L of sine 3t? It will be 3 divided by s square plus 9, right? L of sine 3t is s by s square plus a square. So this will be equal to, so you need to differentiate this twice. So first we will differentiate this. So first time d by ds of 3 by s square plus 9, right? So this will be equal to what? This will be equal to d by ds of, now if we differentiate this, derivative of 1 by x is minus 1 by x square. So it will be minus 3 divided by s square plus 9 whole square. Now again you differentiate this. So you can either use 1 by x square formula or you can use UV method. So you just take minus 3 outside, right? You just take minus 3 outside. You apply UV method. Take this as u, take this as b. So b into u dash minus u into b dash. So 2 into s square plus 9 into 2s, right? Because you need to differentiate inside also. This will be s square plus 9 whole square, right? So b into u dash minus u into okay, minus outside, right? So I'm keeping this 3. So differentiate this, will be having 2 into s square plus 9 and differentiate inside, which will be 2s. So this will be equal to minus of, so this term full will be vanished. So you can see 3 into 2 into 2. So we'll be having this as 3 2s are 6, 12. So 12 into, sorry, this is whole square, right? Bu dash minus u dash by b square. B is s square plus 9 whole square. So this will be 12 into s square plus 9 divided by s square plus 9 whole power 4, right? So 3 2s are 6, 6 2s are 12, sorry, 12s. So 12s into s square plus 9. So this one and this one term will get vanished. So we'll be having this as minus 12s divided by s square plus 9 whole cube is the Laplace transform for L of t square sin 3t. Similarly, we need to find Laplace transform for t into sin 3t. So similarly, we need to find Laplace transform for, we need to find L of t into sin 3t, right? L of t into sin 3t. So this will be equal to what? L of t into sin 3t is equal to minus 1 into d by ds of f of s, where f of s is the Laplace transform for f of t. Here my f of t is sin 3t. So this will be minus 1 into d by ds of, so what is f of s? It will be 3 by s square plus 9, right? Now differentiate this one time. So this will be minus 1 into, so derivative of 1 by x is minus 1 by x square. So this will be s square plus 9 whole square, right? So now 1 becomes, substitute these two values in equation number 1. So 1 becomes L of t square, what we need to find? L of t square minus 3t plus 2 into sin 3t, right? Into sin 3t is equal to L of t square into sin 3t minus 3 times L of t into sin 3t plus 2 times L of sin 3t, right? So substitute all those values here, you will get the required answer, right? So what is L of t square sin 3t? So L of t square sin 3t is minus 12s divided by, so minus 12s divided by s square plus 9 whole cube minus 3 into L of sin t into sin 3t is what? This will be plus, right? So 3 divided by s square plus 9 whole square plus 2 into L of sin 3t is 3 by s square plus 9, right? This is the required Laplace transform. If you want, you can also take LCM, but you can stop at this stage itself, right? So 3 into 3 is 9, so it will be 9 times s square plus 9 whole square plus 6 times s square plus 9. If you also take LCM also, you can take LCM as s square plus 9 whole cube. You can also multiply that, you can multiply by that also, but I don't want to do that. You will keep this as it is, right? So very easy problem. You need to find the Laplace transform for t square minus 3t plus 2 sin 3t. So multiply sin 3t inside and make use of linearity property and find Laplace transform for this, find Laplace transform for this, find Laplace transform for this, and then substitute back all these here, right? Yes. So we'll move on to sixth problem. So find the Laplace transform. Find the Laplace transform of t into e power minus t cos ht, right? Yes. So to find this, so we will be having L of e power minus t into cos ht. So you just find Laplace transform for t into cos ht, and then you replace s by s plus 1, right? Because we have again use of shifting property. So what is L of, call this as equation number 1. So you find L of t into cos ht. So make use of again the multiplication property. It will be minus 1 divided by d by ds of f of s. So this will be, this is our L of f of t, right? This will be minus 1 into d by ds of, so what is f of s? F of s is the Laplace transform for L of f of t, which is cos ht. So this will be equal to minus 1 into d by ds of, so cos s at will be s by s square minus a square, right? cos st will be s by s square plus a square. Cos ht will be cos t will be cos at will be okay, I will write it down neat here. So write it down the formula. So cos ht is s by s square minus a square. So we have cos hat is equal to s by s square minus a square. Right? These are the formula that you already derived. So you can see cos hat, right? So you can see L of sin h at, L of cos h at, and then you have defined L of sin h at, and L of cos h at is s by s square minus a square. Here a turns out to be equal to 1, right? Yes, you can see cos h 1t. So differentiate this. So this will be minus 1 into d by ds of s by s square minus 1. So differentiate one time, you need to apply UV method, right? So minus 1 into, so s square minus 1, derivative of s is 1 minus s into 2s divided by s square minus 1 whole square. So this will be minus, so s square minus 1 minus 2s square divided by s square minus 1 whole square, right? So s square minus 1 minus 2s square. So this will be equal to minus of s square minus 2s square is minus s square minus 1 divided by x square minus 1 whole square, or this will be s square plus 1 divided by s square minus 1 whole square is the Laplace transform for t into cos h at, right? Remember, problem is not over. So one becomes we need to find Laplace transform for t into e power minus t cos st. This is same as L of t into cos st. In this answer, replace s by s plus 1. So we already found L of cos t times cos ht. So this will be s square plus 1 divided by s square minus 1 whole square. In this you replace s by s plus 1. So this will be equal to s plus 1 whole square plus 1 divided by s plus 1 whole square minus 1 whole square is the required Laplace transform. Is the required Laplace transform. We have been discussing what is the effect of multiplication of f of t by t power n in finding the Laplace transform, and what is the effect of multiplication of f of t by 1 by t in finding the Laplace transform, right? So we already proved this both the property in the previous videos, and we have been solving the problems based on this first property, right? Now what we're going to do is we're going to solve some problems based on this property, that is what is the effect of multiplication of f of t by 1 by t. So we already proved that it is equal to integral s to infinity f of s ds, where f of s is the Laplace transform of f of t, right? Yes. So remember the formula, L of 1 by t f of t is equal to integral s to infinity f of s ds, where f of s is the Laplace transform of f of t, right? Yes. Now what we're going to do is we're going to do some problems based on this property, right? Yes. The first is find the Laplace transform of, so find the Laplace transform of, the first question is e power minus t into sin t divided by t, right? Yes. So you can see we need to find, so we need to find L of e power minus t sin t divided by t, right? Now you can see it is of the form L of 1 by t into f of t. So here my f of t is e power minus t sin t. So I can make use of the previous property, it will be equal to integral s to infinity L of f of t into ds, right? So you can see integral s to infinity f of s ds, where f of s is the Laplace transform of f of t, right? So here my f of t is equal to e power minus t sin t. Now we will find Laplace transform of e power minus t sin t, and then we will integrate with respect to with the limit from s to infinity, right? Yes. So this will be equal to integral s to infinity. Now what is the Laplace transform of e power minus t sin t? Very easy. What we can do? We can use shifting property, right? So this will be equal to, so we know the property. So what is the property? We already proved this, right? So we know that L of e power minus at into f of t, right? L of e power minus at into f of t L of e power minus at into f of t is same as, we already proved this, right? So you find the L of Laplace transform of f of t, in that you replace s by s plus a, right? We already proved this. So now I'm going to make use of that. So this will be, so find the Laplace transform of sin t. So find the Laplace transform of sin t. In that answer you replace s by s plus 1, because my a is equal to 1 here, right? E power minus at, a is equal to 1 here. So already we have ds. Now we can continue with problem. So this will be integral s to infinity. Now what is Laplace transform of sin t? So L of, what is Laplace transform of sin at? It is a by s square plus a square. So here a is 1, so it will be having 1 by s square plus 1. In that you replace s by, s plus 1, right? In that you replace s by s plus 1. Already we have ds, right? So you can see integral s to infinity ds will remain. So we are finding the Laplace transform of e power minus t sin t. So it is same as L of sin t, replace s by s plus 1. So L of sin at, right? So what is L of sin at? It is a divided by s square plus a square. So a is 1 here, so 1 by s square plus 1, right? Yes. So in that you replace s by s square plus 1. So this will be integral s to infinity 1 divided by s plus 1 whole square plus 1, right? So now we need to integrate this, and then we need to apply upper limit minus lower limit. We'll get the required answer, right? So this will be equal to integral s to infinity 1 divided by s plus 1 whole square into ds. Now we know that integral 1 by 1 plus x square is equal to tan inverse of x, right? So I'm going to make use of this. So this is nothing but tan inverse of s plus 1, right? Because instead of x we have s plus 1, so 1 by 1 plus x square. So instead of x we have s plus 1. Limit is from s to infinity. So this will be tan inverse of infinity minus tan inverse of s plus 1. That is in s you substitute upper limit, so it will be infinity plus 1. This s will remain as it is, right? So tan inverse of infinity is pi by 2, and this will remain as it is, which is tan inverse of s plus 1. If you want, you can also write this as cot inverse of s plus 1. So therefore the Laplace, because pi by 2 minus tan inverse of x is cot inverse of x, right? So trigonometric inverse trigonometric identity is that tan inverse of x tan inverse of x plus cos inverse of x is equal to pi by 2, right? Yes. So pi by 2 minus tan inverse of s is cot inverse of s. We have s plus 1, so I'm writing this as cot inverse of s plus 1. So therefore my Laplace transform of e power minus t sin t by t will be equal to cot inverse of s plus 1, right? Yes. So I'll move on to second problem. Find the Laplace transform of 1 minus cos 2t divided by t, right? 1 minus cos 2t divided by t. So again you can see it is of the form L of 1 by t f of t. So this will be equal to integral s to infinity L of 1 minus cos 2t into ds, right? So L of f of t into ds. So here my f of t is 1 minus cos 2t. So this is equal to integral s to infinity. Now what is L of 1? L of 1 is 1 by s minus, what is L of cos 2t? It is s by s square plus a square. So my a is equal to 2, right? So L of 1 is 1 by s, L of cos at, right? We know these formulas. L of cos at will be equal to s by s square plus a square. So therefore my a is equal to 2 here. Now we will integrate this. So this will be equal to integral s to infinity 1 by s ds minus integral s to infinity s by s square plus 4 ds, right? S by s square plus 4 ds. Now what I will do is we will integrate this. So we know integration of 1 by s is log s, right? So this will be log s, right? Limit is from s to infinity. Now we know that integral f dash of x divided by f of x is same as log of f of x, right? This is a basic integration formula that we come across in previous classes, right? Now you can see if I take this as f of s, so this is same as here instead of x we have s, no problem, right? So if we take this as f of s, it will be s square plus 4. If we have this derivative in the numerator means I can use this formula, right? If we have the derivative of this in the numerator, I can use this formula by integrating. But the problem is, what is the derivative of this? It is 2s plus 0, right? So derivative is 2s, but here we have only 1s. So what I will do is, I will multiply and divide this by 2. So we will be having 2s by s square plus 4 ds. The limit is from s to infinity. Now I can use the formula that this is equal to, so we will be having this to be equal to log s, limit is from s to infinity, minus this is 1 by 2 log of s square plus 4, right? Log of s square plus 4. I think you're getting my point, right? So integral f dash of s divided by f of s is equal to log of f of s. So instead of f of s, we have s square plus 4, right? Yes. Now limit is from s to infinity, right? Yes. We will apply the limit. Before that, we will simplify this. So we will be having log s, limit is from s to infinity. I can write this as log of root of s square plus 4, right? Because if I take this 1 by 2 to the power, we will be having log s square plus 4 whole power 1 by 2. Because log a power x is x log a. So I can take this 1 by 2 to the power of this, so which is root of s square plus 4. The limit is from s to infinity. Now log a minus log b is same as log a by b. So we will be having root s by root of s square plus 4. Limit is from s to infinity. We apply upper limit minus lower limit. Now the important thing is, you cannot apply this infinity directly, right? So when you apply this, when you put s is equal to infinity, you will be having infinity by infinity, right? Which is indeterminate form. So we'll try to find what happens when s is tending to infinity, right? So this will be, upper limit will be limit s tending to infinity log of s divided by root of s square plus 4 minus lower limit, so which is log of s divided by root of s square plus 4, right? So we cannot apply infinity directly, right? Because whenever we have limit in the integration, we cannot apply that directly. So what we will find is, we can find what happens when s is tending to infinity. We can find, we cannot find that we cannot find it directly at infinity, right? Because infinity is not a number. So we will try to find what happens when s is tending to infinity, right? Yes. Now upper limit is when s is tending to infinity, log of this value, and lower limit is you will keep s as it is, right? Yes. Now we will try to find the limit for this. So this will be limit s tending to infinity. Now this will be log of s divided by, now if I take s outside here, we will be having log of, if I take s common here, that is I'm taking s square common here. If we take x square common in the outside, we'll be having s. So we'll be having this as 1 by 4 by s square, right? So what I'm doing is, let me write this in steps so that you will have more clarity, right? So what I'm doing is, so I'm writing this as root of, you just take s square common, we'll be having 1 divided by 4 by s square. Let us keep this term as it is, that log of s by root of s square plus 4, right? Now if I take this s square outside, so I need to take root of s square outside, right? So this will be limit s tending to infinity log of s divided by, so if I take this s square outside, so I need to take outside with root, so we'll be having s into root of 1 plus 4 by s square minus log of s divided by root of s square plus 4, right? So these two will get cancelled. Now when s is tending to infinity, this will tend to 0, right? This will tend to 0. So because 1 by infinity is 0, so we will be left with only 1, right? So here we have 1, here we have root 1 plus 0. So which is, we will be left with log 1, right? Log 1 minus log of what we have, s by root of s square plus 4, right? S by root of s square plus 4, okay. Now log 1 is 0, so this will be 0 minus log of s divided by root of s square plus 4. So this 0 will be vanished, so I can write this as, or I can also write this as log by s divided by root of s square plus 4 whole power minus 1, right? Because I can take this minus to the power if I have log. So this is same as log of root s square plus 4 divided by s, right? I'm just taking reciprocal to remove inverse, right? Yes, this is the Laplace transform. If not, you can also write this as log s square plus 4 divided by root of s square, right? I'm just writing s as root of s square, so therefore this will be log of root of s square plus 4 divided by s square is the required Laplace transform, right? I'm just simplifying to some more extent. Is the required Laplace transform for the function 1 minus cos 2t by t, right? Very important problem. So very easy, right? So only thing is you cannot apply infinity directly, so we'll try to find what happens when s is tending to infinity. So this will tend to 0, so we'll be having root of 1 plus 0, which is 1, so we'll be having 1 by 1, so log 1 is 0. So very easy, right? Third problem, right? Yes. Third problem is find the Laplace transform of, so find the Laplace transform of sin at divided by t. Does the Laplace transform of cos at divided by t exist, right? This is the question, right? So first we need to find the Laplace transform of sin at by t, and then we need to find the Laplace transform. We need to check whether the Laplace transform of cos at by t exists or not, right? Yes. So we'll do this. So we need to find the Laplace transform of this, right? So very easy. So first we will find Laplace transform of sin at by t, right? So Laplace transform of sin at divided by t, this is equal to integral s to infinity L of f of t dt, f of t ds, f of t is sin at into ds, right? Because L of 1 by t f of t is integral s to infinity L of f of t to ds, so 1 by t f of t, so f of t is sin at here. So this will be equal to, so this will be equal to integral s to infinity, right? So what is L of sin at? It is a divided by s square plus a square into ds, right? Yes. Now we need to integrate this. So I can take this a square outside because I can take this a outside because we need to integrate with respect to s. So therefore I can take a as a constant. So we will be having inside, we will be having 1 by s square plus a square into ds, right? Now I am going to take this a square outside, so that we will be having 1 by s square plus a square into ds, right? Yes. Now I am going to take this a square also outside, so that we will be having a divided by a square integral 1 divided by 1 plus s by a whole square into ds, right? So I can cancel this 1a, so we will be left with this will be equal to integral 1 by a integral s to infinity 1 by a integral s to infinity. Remember, everything is integral s to infinity, right? So integral s to infinity, so we'll be having 1 by 1 plus s by a whole square, right? 1 by 1 plus s by a whole square into ds, right? Yes. So now integrate this, so this will be equal to, so we know that integral 1 by 1 plus x square is equal to tan inverse of x, right? So we'll integrate this, this will be equal to 1 by a, so this will be tan inverse of s by a, right? Remember, inside we have s by a, right? So we'll differentiate this with respect to s, so we'll be having 1 by a, so we'll write that as 1 by a here, right? So when you are integrating, when you are applying chain rule, means you need to differentiate inside and then you need to divide that, right? When you are integrating, yes. So this will be limit is from s to infinity, right? And I think you are getting my point, right? So here also we are applying the same here, right? But here I haven't said that. So you can see whenever you are using the formula, So we will divide this by inside, so which is inside will be 1 plus 0. So I'm not writing that, right? So assuming that everyone know how to integrate this, right? Very elementary. So this will be tan inverse of s plus 1. Now differentiate this term and write it in the denominator. So we'll be having 1 plus 0. So I'm not writing that, right? Similarly here also we'll be having tan inverse of s plus a. Now differentiate this term and write it in the denominator. We'll be having 1 by a, right? So this 1 by a and this 1 by a will get cancelled. So we will be left with tan inverse of s by a. Limit is from s to infinity. Now we can see when s is 10, so when you cannot apply infinity directly. So what we can do is limit s tending to infinity, tan inverse of s by a minus tan inverse of s by a. So this will be equal to pi by 2, right? Because tan inverse infinity is pi by 2. So pi by 2 minus tan inverse of s by a, or I can also write this as cot inverse of s by a, right? Cot inverse of s by a is the required Laplace transform for sin a t by t, right? Yes. Now we will find whether cos a t exists or not, right? So find the Laplace transform of sin a t by t. Does the Laplace transform of cos a t by t exist? So we will do that. So we will find the Laplace transform of cos a t by t. So L of cos a t divided by t, right? So this is integral s to infinity L of f of t into ds. So this will be integral s to infinity. So what is L of cos a t? This is s by s square plus a square into ds, right? Yes. Now we will try to use we will try to use logarithm formula, that is integral f dash of s divided by f of s is same as log of f of s, right? We already used this. So here we have s square plus a square. When you differentiate this, we will be having 2s plus 0, but we don't have 2s in the numerator. So what we will do is, so I will multiply and divide this by 2. So integral s to infinity 2s divided by s square plus a square. Now I can write this as log of s square plus a square, right? Because integral f dash of s divided by f of s is log of f of s. So my f of s is s square plus a square. Limit is from s to infinity, right? Now you try to apply the limit, that's it, right? So this will be 1 by 2. Now when you try to apply the limit, we cannot apply the limit directly. So what we will do is we will find limit s tending to infinity s square plus a square minus lower limit, which is log of s square plus a square. That is, you replace s by s as it is, right? Upper limit minus lower limit. Now this will tend to infinity, right? This will tend to infinity because when s is tending to infinity, s square plus a square will tend to infinity. This will tend to infinity plus a square, which will tend to infinity. So overall it will tend to infinity, right? So the overall this will tend to infinity, yes or no? Because infinity minus something into 1 by 2. So therefore does not exist. This is tend to infinity. So therefore integral cos a t, Laplace transform of integral cos a t by t, right, does not exist. So therefore Laplace transform of cos a t by t does not exist. So therefore Laplace transform of cos a t by t does not exist, right? Because you can see this integration is tending to infinite, that is this integration tending to infinity. So therefore the limit does not exist for this. So as a result my L of cos a t by t does not exist, right? So L of sin a t by t exists, and that value is equal to cot inverse of s by a, and L of cos a t by t does not exist, right? Yes. So we move on to fourth problem. The fourth problem is prove that using Laplace transform. So using Laplace transform, prove that integral 0 to infinity sin t by t is equal to sin t by t dt, sin t by t dt is equal to pi by 2, right? Very easy problem. So we know that So just now we have found the Laplace transform of sin at divided by t, right? It's a very easy problem. So which turns out to be cot inverse of, so you can see just now we have found Laplace transform of sin at by t, which turns out to be cos inverse of s by a, right? This is cos inverse of s by a, right? Call this as equation number 1. Now you just apply the definition, right? So by definition, what is L of sin at divided by t? This is integral 0 to infinity e power minus st into f of t dt. So my f of t is sin at divided by t into dt, right? So L of f of t, Laplace transform of f of t is a very elementary, right? This is equal to integral 0 to infinity e power minus st f of t dt. So my f of t is here is sin at by t, right? Call this as equation number 2. So that means I can equate these two, right? Because my LHS of 1 and 2 are equal. So from 1 and 2 I can equate the RHS, right? So from 1 and 2 I can equate the RHS. So that means integral 0 to infinity e power minus st sin at by t dt is equal to cot inverse of s by a, right? Cot inverse of s by a. So from 1 and 2 RHS has to be equal, right? Yes. Now what we need to find? We need to find integral sin t by t. That means put s is equal to 0, a is equal to 1, right? Put s is equal to 0, a is equal to 1. Then this will be integral 0 to infinity e power minus 0 into sin t divided by t dt is equal to cot inverse of 0 by 1, right? So this turns out to be e power 0 is 1. So we will be left with integral 0 to infinity sin t by t dt is equal to cot inverse of 0, right? So cot inverse of 0. So what is cot inverse of 0? So cot inverse of 0 is pi by 2, right? So these are very elementary result, that cot inverse of 0 is pi by 2, right? Yes. That is if x is equal to if 0 is equal to cot x, then x is equal to cot inverse of 0, right? Cot inverse of 0. Now cot of what is 0? Cot pi by 2 is 0, right? Cot 90 is 0. So therefore we will be having x to be equal to 90 degree, which is pi by 2, right? Yes. So therefore we have proved the required result, that using Laplace transform integral 0 to infinity sin t by t dt is equal to pi by 2. So cot inverse of 0 is pi by 2, right? Yes. So far what we have did in Laplace transform is that we have solved many problems on Laplace transform, like shifting property, and then what is the effect of multiplication of f of t by t power n, and what is the effect of multiplication of f of t by 1 by t in finding the Laplace transform. So we have solved all these problems, right? So if you haven't watched the previous videos, go through all that. Now we are going to move on to the next subtopic called Laplace transform of a periodic function, right? Yes. So you know what is a periodic function, right? So after some stage the curve starts to repeat, right? After some stage the curve starts to repeat. So that stage is called the period of that function, right? For example, sin x, cos x are periodic function of period 2 pi, right? That is after 2 pi the same graph will start to repeat, right? Yes. Let a function f of t be periodic with period w. So that what is the definition of periodic function? F of t plus nw is same as f of t. That is, if w is the period, f of t plus w is same as f of t, right? Yes. This is the basic definition of periodic function, right? Yes. Then Laplace transform of f of t is same as integral 0 to w e power minus st f of t divided by 1 minus e power minus sw dt, where w is the period of the given function, right? So we'll do problems based on this. It will be very easy for you, right? So if the question is given that this f of t is a periodic function of some period, you can straight away use this formula, right? Yes. So we'll do that. I will let you know, right? Yes. So we'll move on to problem. So find the Laplace transform of. So find the Laplace transform. So find the Laplace transform of a periodic function. A periodic function f of t is equal to k times t by capital T, and this t lies between 0 to capital T, and it is f of t plus t is equal to f of t, right? Yes. So very easy problem. So they have given that f of t is a periodic function. So this f of t is a periodic function. So it is given that it is a periodic function of period t, right? Of period t, because f of t plus something giving you f of t again. So therefore this something is a period. So f of t is a periodic function of period capital T, right? Of period capital T. Call this as W, because here we have mentioned period to be equal to W, right? Yes. So therefore we know that if f of t is a periodic function of W, the formula will be integral 0 to W, integral 0 to W e power minus st f of t divided by 1 minus e power minus s times W dt, right? This is what I mentioned in the previous page. That is, if f of t is a periodic function of period W, Laplace transform of the function is equal to integral 0 to W e power minus st f of t divided by 1 minus e power minus sw dt. So here W is equal to t. So substitute W to be equal to t. So we'll be having integral 0 to t e power minus st f of t divided by 1 minus e power minus st into dt, right? Yes. Now you can see we need to integrate with respect to small t. So therefore I can take this outside, right? 1 minus 1 by e power minus s times capital T I take outside. Inside we'll be having integral 0 to t e power minus st f of t dt, right? Inside we'll be having e power minus st f of t dt, because we need to integrate with small t, right? Yes. So this will be 1 divided by 1 minus e power minus st integral 0 to infinity e power minus st. Now what is f of t? They have given f of t to be equal to kt divided by capital T dt, right? Kt divided by capital T dt. Now again I can take this capital T outside, because we are integrating with respect to small t. So this will be equal to 1 divided by 1 minus e power minus st. So I can take this k by t outside, right? I can take this k by t outside. So if I take this k by t outside, inside we will be having integral 0 to t e power minus st t dt, right? E power minus st into t into dt. Now integrate this. So you need to always give preference to highlight. So if there is inverse trigonometric function, means you need to take that as u. If there is logarithmic function, means you need to take that as u first. If there is algebraic, means you need to take that as u. You need to take u in this order, right? I have already said. So that means here we have algebraic function as well as exponential function, but you need to give preference to algebraic, and then you need to give preference to exponential. That means you need to give preference only to algebraic first when you have algebraic and trigonometric, right? Sorry, algebraic and exponential. Here we are having algebraic function and exponential function. From these two you need to give preference to a, right? Therefore you take u to be equal to t, and then you take v dv is equal to e power minus st dt. Therefore du will be equal to dt. So we will be integrate this with respect to t. So e power minus st divided by minus s, right? So we will apply the formula. So integral e power minus st k by t. So this will be uv minus integral v du. So this will be equal to 1 divided by 1 minus e power minus st into k by t. So here we will be having u into v. So u is t, v is e power minus st divided by minus s. Limit is from 0 to t, right? Limit is from 0 to capital T minus integral v du. So e power minus st by minus s, du is dt, right? Yes. So we will be having this to be equal to 1 by 1 minus e power minus st into k by capital T. Now when you apply upper limit and when you apply lower limit, what you will be having? When you apply upper limit minus lower limit, so what we can do is, okay, so we need to apply limit to what? T, right? We need to apply, because we are differentiating with respect to t. So when you apply upper limit, we will be having capital T e power minus s capital T divided by minus s minus lower limit is 0. Lower limit will be 0, right? Because 0 into something is 0. So here we'll be having plus 1 by s integral e power minus st dt, right? So here upper limit, lower limit will be 0 here, right? Lower limit is 0. Lower limit is 0, upper limit is capital T into e power minus s capital T by minus s, right? Yes. So we will be having this to be equal to 1 by 1 minus e power minus capital St into k by t inside we will be having this to be equal to t into e power minus st divided by s. Now integrate this with respect to e power minus st dt. So already we are having plus 1 by s. Now integrate e power minus st, will be having e power minus st by minus s, right? With respect to t, limit is from 0 to t, right? Limit is from 0 to t. So we will be having limit is from 0 to t. So this will be equal to 1 by 1 minus e power minus st into k by t into t into e power minus st by s. Now this will be minus 1 by s square. Now apply upper limit, we will be having e power minus st minus lower limit will be 0, right? Lower limit will be 0. So we will be left with e power 0, right? Yes. So we will be left with what? We will be left with 1 by 1 minus e power minus st into k by t. So here will be having t into e power minus st by s. Now this will be 1, right? This will be 1 by s square e power minus st minus, sorry, this will be e power 0, right? Sorry, this will be e power 0, right? So I am putting s to be equal to capital T and s to be equal to 0. That we will be having this as e power 0, which is 1, right? Therefore this is the required Laplace transform for the given function, right? If you want, yes, this is the required Laplace transform. Is the required Laplace transform for the given function, right? Very easy problem. So you just remember that whenever they give find the Laplace transform of a periodic function with period means we make use of this formula to find the Laplace transform for the given function, right? So now we'll do second problem based on this method, right? Yes. So find Laplace transform. Find the Laplace transform. Find the Laplace transform of f of t, where f of t is equal to, it takes the value sin t, right? It takes the value sin t when t lies between 0 to pi, and it will take the value 0 if t lies from pi to 2 pi, right? Pi to 2 pi. It lies between pi to 2 pi, given that f of t as a period 2 pi, given that f of t as a period 2 pi, right? Yes. So they have given this f of t is a periodic function of period 2 pi. We need to find the Laplace transform for this f of t, right? Yes. Solution. So very easy problem. So you just have to make use of the previous result I have given. So Laplace transform of f of t is equal to integral. So just go to the previous formula. It will be equal to integral 0 to w. This will be integral 0 to w e power minus st f of t divided by 1 minus e power minus sw into dt, right? So just go through the formula. It will be equal to e power minus st f of t divided by 1 minus e power minus sw dt, where w is the period, right? Where w is the period, So here w is equal to 2 pi, right, because it is given that our f of t has a period 2 pi. So therefore this will be integral 0 to 2 pi e power minus st f of t divided by 1 minus e power minus s into 2 pi into dt, right. So I'm just replacing w by 2 pi, right, w by 2 pi. So therefore I can take this denominator outside, right, because we are integrating with respect to t. So therefore I can take this denominator outside. So I can take this 1 minus e power minus 2 pi s outside. So inside will be having integral 0 to 2 pi e power minus st f of t dt, right. Yes, now call this as 1, right, because I don't want to write I don't want to write this term in every step. So call this as equation number 1. We will find this value and then we'll substitute in equation number 1, right. Yes, so we need to find integral 0 to 2 pi e power minus st into f of t dt, right. Yes, now we have f of t when t lies between 0 to pi, my f of t is sin t, and when t lies between pi to 2 pi, my f of t is 0, right. So I'm going to break this into interval. When t lies between 0 to t, my f of t is sin t, right. Yes, my f of t is sin t dt, plus when t lies between pi to 2 pi, my f of t is equal to 0 dt, right. I'm just breaking the interval. I'm breaking the interval 0 to 2 pi as this is 0 to pi. So when t lies between 0 to pi, my f of t is sin t, and when p lies between pi to 2 pi, when t lies between pi to 2 pi, my f of t is 0. So this term will be vanished as we have 0 into something. So we will be left with integral 0 to pi e power minus st sin t dt, right. Yes, now I have already given the formula in the previous classes when we are doing Laplace transform, right. We already know the formula integral e power ax sin bx, right. So we know that we already know this formula, right. I have already given this integral e power ax sin bx. So integral e power ax sin bx, so I write it clearly, very elementary formula that I have already given you. So e power ax into sin bx dx, right, sin bx dx will be equal to e power ax divided by a square plus b square into a sin bx minus b cos bx, right, b cos bx, right. I have already given this formula in the previous class itself, right. Yes, now I'm going to make use of this formula. So that means here what is here you just compare this and this. So here my b is equal to 1, right, b is equal to 1 and x is equal to t. What is a is equal to e power a is equal to minus s and x is equal to t, right. Just compare this formula. If you replace b by 1 and x by t and a by minus s, you will be getting this integral, right. Integral x, I'm replacing x as t, a as minus s, so we'll be having e power minus st sin 1t because b is 1 sin dt. So in this formula you replace b to be equal to 1, a to be equal to minus s, x to be equal to t. So we'll be having this to be equal to, so when you integrate this you will be having this to be equal to, so e power ax divided by a square plus b square. So a is minus s, x is t, so we'll be having e power minus st divided by a square plus b square. So a square plus b square is s square plus 1, right, s square plus 1. So we'll be having this as s square plus 1 into a into sin bx, so minus s into sin 1x, so b is 1, right, a is minus s, so we'll be having minus s into sin 1x, I'm not adding that 1, minus b into, so b is 1, here also b is 1, so we'll be having minus cos x, right, minus cos x. So we'll be having this as minus cos t, right? Here also t, right? Because x is t, right? X is t. So x is t. So limit is what? The limit is from 0 to pi. Limit is from 0 to pi. Right? So in t you apply upper limit, and in t you apply lower limit. So when you apply upper limit, we will be having e power minus s pi divided by s square plus 1 into minus s into sin pi minus cos pi. This is the upper limit, minus lower limit. So lower limit is e power minus s into 0, because we are integrating with respect to t, right? So that means you need to apply upper limit and lower limit in t values. So e power, this will be minus s into sin 0 minus cos 0, right? So this is upper limit minus lower limit. So we will be having this as to be equal to e power minus s pi divided by s square plus 1. So sin pi is 0, right? Sin pi is 0, cos pi is minus 1. So we will be having 0 minus half minus 1, 0 minus half minus 1, and here we will be having minus, this will be 1, right? E power 0 is 1. So 1 by s square plus 1, and this will be sin 0 is 0, cos 0 is 1. So overall you will be having this value to be equal to so this is plus 1, so e power minus s pi divided by s square plus 1, this minus minus will be plus, so we will be having 1 by s square plus 1 again. So therefore if we combine these two terms, we will be having 1 plus e power minus s pi divided by s square plus 1 is the integration value for this, right? Remember, we are not yet over, we need to substitute in equation number 1, right? So call this as equation number 2. Now put 2 in 1. So substitute 2 in equation number 1. Substitute 2 in equation number 1. So what is 1? So we need to find L of f of t. So L of f of t is equal to 1 by 1 minus e power minus 2 pi s into integral 0 to 2 pi e power minus st f of t dt, and this value is the one that we have found now, which is we already have e power minus 2 pi s. So this value e power minus st f of t is 1 plus e power minus s pi divided by s square plus 1, right? Therefore is the required Laplace transform for the given function, right? Yes, is the required Laplace transform for the given function, right? So very easy. So we have solved two problems based on how to find the Laplace transform if the function is given to be a periodic function of period something, right? So far what we have done in Laplace transform is that in the very beginning we have introduced the definition of Laplace transform, and then we have found the Laplace transform for some elementary functions like sin at, cos at, e power minus st, and so on. And then I have given you lots of property, and then we have proved all those property, and then we have also solved problems based on that, like what is the effect of multiplication of f of t by t power n, find the Laplace transform. What is the effect of multiplication of f of t by 1 by t when finding Laplace transform. And in the last two videos we are discussing Laplace transform for a periodic function, right? Yes. Now we're going to find the Laplace transform for some function using the definition, right? Yes. So this will go on for 6 to 7 problems. So we're going to only make use of definition in finding the Laplace transform, right? Yes. So we move on to that. The first problem is, so find the Laplace transform. Find the Laplace transform. Very easy problems. Find the Laplace transform of, so f of t is given to be e power t if t lies between 0 to 1, and it will be 0 if t is greater than 1, right? So if you have a function like this, means you need to make use of, that is, if you have a function like this, means you should always make use of the definition, right? Is solution. So we'll find the Laplace transform for this. So by definition, what is the Laplace transform of L of f of t? That is, what is the Laplace transform of f of t is equal, this is equal to integral 0 to infinity e power minus st into f of t dt, right? So what we will do is, we will break this interval. We need to find limit, interval is from 0 to infinity, right? We're going to break this as from 0 to 1, my f of t is e power t, and when t is greater than 1, my f of t is equal to 0. Therefore, this will be, so I'm going to break this as, when the interval is from 1 to, when the interval is from 0 to 1, when the interval is from 0 to 1, so when the interval is from 0 to 1, my f of t takes the value e power t, right, into dt, plus when the integral is greater than 1, that means 1 to infinity, right, greater than 1 means 1 to infinity, e power minus st, my f of t takes the value 0 into dt, right? So every problem from now on will be like this. Find the Laplace transform of f of t. F of t will be, it will be a function of two functions, that is from interval to interval it may vary, right? Yes. So therefore this will get vanished. So we will be having integral 0 to 1. So when I combine this, we'll be having e power minus st plus t dt, right? Because e power m1 into e power m2 is same as e power m1 plus m2. So this is equal to integral 0 to 1 e power minus, I'm going to take minus t outside. So if we take minus t outside, we'll be having this as s plus 1 into dt, right? So just take minus t outside, so we'll be having plus s, and here we'll be having, here we'll be having minus 1, right? Ready? S minus 1. S minus 1. So integrate this, this will give you the required answer. So this will be integral 0 to 1. So we'll be having e power minus t into s minus 1 dt. So this will be, so integrate this. So integral e power minus t into s minus 1, right? So very easy. So you just have to integrate this. So this will be e power minus t into s minus 1 divided by derivative of t is 1. So we'll be having minus 1 into s minus 1. Limit is from 0 to 1. Therefore I can take this minus, I can take this, I need to vary t, right? That is, I need to substitute upper limit and lower limit in t, because we are integrating with respect to t. So just take this minus 1 divided by s minus 1 outside. So inside we'll be having e power minus t s minus 1, limit is from 0 to 1. So we'll be having minus 1 divided by s minus 1. So I'm just taking minus outside, 1 by s minus 1 outside. So when you put t is equal to 1, we'll be having e power minus 1 into s minus 1. And when you put t is equal to 0, we'll be having this, right? So this will be minus 1 divided by s minus 1. So this will be e power minus s minus 1, and this will be e power 0. E power 0 is 1, right? Therefore this is the required Laplace transform for the given function, right? Yes. So if you want, you can also replace this as 1 by s minus 1 as 1 minus s, so that this minus will be cancelled. So this will be 1 by 1 minus s into e power, if we take this minus out inside, we'll be having 1 minus s minus 1 is the required Laplace transform, right? So you can see what we are doing is, we are finding the Laplace transform when the function is like this, right? So I'll give you one problem for exercise problem for you. You try to follow the same method, right? Yes. I'll give you one exercise problem for you. So exercise, right? So find Laplace transform of f of t. This will take e power 2t when t lies between 0 to 1, and it will take 1 if t is greater than 1, right? Similar problem, I have replaced the 0 by 1 and t by 2t, right? So you try to do this problem in your own, right? Yes. So we'll start second problem, right? Yes. So find the Laplace transform. So find the Laplace transform. Find the Laplace transform of f of t. So f of t is given to be sin t when t lies between 0 to pi, and we will take 0 if t is greater than pi, right? If t is greater than pi. So very easy problem. So you just apply the definition, you will be getting the answer, right? So we know that what is L of f of t, what is the Laplace transform f of t? It is integral 0 to infinity e power minus st into f of t dt, right? So therefore this will be integral 0 to infinity okay, what we can do is we now we're going to break the interval. Now we can see my f of t takes the value sin t when t lies between 0 to pi. So what I'm doing is I'm making the integration to be 0 to pi. So in that case my f of t takes the value sin t, right? F of t takes the value sin t dt plus when t is greater than pi, that is from pi to infinity. So I'm just breaking the interval 0 to infinity as 0 to pi, pi to infinity. So from 0 to pi my f of t is sin t, and from pi to infinity my f of t is 0 into dt. So this term full will be vanished. So we will be having this term to be equal to integral 0 to pi e power minus st sin t dt, right? We know how to integrate this. We know the integration formulas, right? The previous video only I have given the formula, that is in the last two to 3 videos before. We know that integral e power ax sin bx dx will be equal to e power ax divided by a square plus b square into a sin bx minus b cos bx, right? So now we'll try to use this formula here, integral e. Now we need to find integral 0 to pi e power minus st sin t dt, right? Sin t dt. So compare this and this, right? So compare this and this. So when you compare this and this, we will be having, so a, you take a to be equal to minus s, b to be equal to 1, you take b to be equal to 1 and take s to be equal to t and take x to be equal to t. So by substituting these three values you can get this integral, right? So substitute a to be minus s, x to be equal to t. So you'll be having e power minus st. Put b is equal to 1 and x is equal to t. So therefore e power minus st sin 1t dt. So we know this integration formula. In this integration formula, when you substitute a is equal to minus s, b is equal to 1, x is equal to t, we can find the integration of this, right? So this will be equal to e power ax. So what is a? A is minus s, x is t, right? X is t divided by a square plus b square, which is s square plus 1 square, into a into sin bx. So a is minus s sin bx. So sin b is 1, so we'll be having 1 into x, minus b is again 1 cos bx, which is again 1, right? So you just substitute a to be equal to minus s, b to be equal to 1, x to be equal to t here, right? I just change the color of this. X is equal to t, right? X is equal to t. So you substitute these three in this formula, we will be finding the integration of this value. So what is the limit? Don't forget to apply the limit. The limit is from 0 to pi, right? Limit is from 0 to pi. So now we apply upper limit minus lower limit. So this will be e power minus s pi divided by s square plus 1. We are integrating with respect to t, right? That means you need to apply upper limit, lower limit. Wherever you have t, you need to apply upper limit. So here we have t. This is x is t, right? X is t, right? So we'll be having sin t cos t, right? Yes. So wherever you have t, you need to apply pi. So my upper limit will be minus s into sin pi minus cos pi. So this is the upper limit value, minus lower limit. So wherever you have t, you put 0 now. So we'll be having e power minus s0 divided by s square plus 1 into minus s into sine 0 minus cos 0, right? So I've just substituted, this is upper limit and this is lower limit, right? Yes. Now we'll try to simplify. So we'll be having this to be equal to e power minus s pi divided by s square plus 1. So here we'll be having sine pi is 0, cos pi is minus 1. So we'll be having 0 minus of minus 1, right? Already we have minus, cos pi is minus 1 minus, and this will be 1 by s square plus 1, right? Because e power 0 is 1 and here will be having sine 0 is 0, cos 0 is 1. So we'll be having this to be equal to 0 minus 1, right? So when you, this will be minus will be plus, so we'll be having e power minus s pi divided by s square plus 1 minus will be plus, so we'll be having 1 by s square plus 1. So 1 plus e power minus s pi divided by s square plus 1 is the required Laplace transform for the given function, right? Is the required Laplace transform for the given function. For the given function, right? Function. So you can see my f of t is given to be sin t when t lies between 0 to pi, 0 when t is greater than pi. So I break the interval and I using the known formula. I have got the answer as 1 plus e power minus s pi divided by s square plus 1, right? So we have solved two problems based on this. And the third problem, find the Laplace transform of. So find the Laplace transform of. So f of t is given to be f of t is given to be, so it will take 0 when t lies between 0 to 1 and it will take t when it lies between 1 to 2 and it will take 0 when t is greater than 2, right? Yes. So we will find the Laplace transform for this function, right? So very easy, you can do this problem in your own itself. Okay, so we know that L of f of t, right? L of f of t is equal to integral 0 to infinity e power minus st into f of t dt. Now I'm going to break this into interval. So I'm going to break 0 to infinity as, so 0 to 1. So from 0 to 1, my f of t takes the value 0, right? So e power minus st 0 into dt plus, and from 1 to 2, my f of t takes the value 2. So it will be e power minus st into 2 into dt, and from 2 to infinity, right? From 2 to infinity, my f of t will take the value 0, right? F of t will take the value 0. So this term and this term will be vanished. So we will be only having integral 1 to 2, sorry, it is t, right? Sorry, it is not t, so it is t. So from 1 to 2, my f of t is t, right? F of t is t, sorry. So f of t is t. So t e power minus st dt, right? Yes. Now very easy. Now what you need to do? This term will be vanished. This term will be vanished. So we will be having 1 to 2 t into e power minus st dt, right? Yes. Now we will make use of integration by parts. So we need to integrate 1 to 2 t into e power minus st dt, right? Yes. So you should always choose in this preference, right? Highlight. So here we have algebraic function and exponential function. So in that way you need to give the first preference to algebraic, then exponential, right? I have already said. So that means you take u to be equal to t, and vdv is equal to e power minus st dt, right? So therefore my du will be dt, that is with respect to t differentiate. So this will be v is equal to e power minus st divided by minus s. Integrate this, will be having v is equal to, integrate with respect to t, will be having e power minus st by minus s, right? So this will be equal to uv minus integral v du. So u is t, v is e power minus st divided by minus s. Limit is from 1 to 2 minus integral v du. So v is v is e power minus st divided by minus s into du is dt, right? Du is dt. So this will be equal to, now you just substitute upper limit minus lower limit, it will be very easy, right? So this will be, okay, let me keep this as it is, t into e power minus st by minus s, limit is from 1 to 2, this will be 1 by s, right? Minus minus will be plus, so 1 by s, integration of e power minus st is e power minus st by minus s, limit is from what, 1 to 2, right? Limit is from 1 to 2. So overall you will be having this to be equal to t into e power minus st by minus s, limit is from 1 to 2, limit is from 1 to 2. Here we will be having minus 1 by s square, minus 1 by s square e power minus st, limit is from 1 to 2, right? Now just apply upper limit minus lower limit. So here when you apply upper limit, we will be having, you need to apply upper limit to t, right? Yes. So we will be having 2 into e power minus 2s divided by minus s minus lower limit 1 into e power minus s divided by minus s, right? And here we will be having 1 by s square. So upper limit is e power minus 2s divided by, sorry, minus e power minus s, right? So this is the required Laplace transform of the given function. If you want to simplify this to some more extent, what you can do is to just multiply, you just write it, you just write all the terms first. So you'll be having minus 2 by s into e power minus 2s, and here will be having plus 1 by s into e power minus s. So when you multiply here 1 by s square by this term, we'll be having minus 1 by s square e power minus 2s, and this will be plus 1 by s square e power minus s, right? I'm just multiplying these two terms. Now what you can do is you can take e power minus 2s outside, right? Now e power minus 2s, e power minus 2s common, e power minus s, e power minus s common. So if we take e power minus s outside, so we will be having, here we will be having 1 by s, and here we will be having 1 by s square, right? And here I can take e power minus 2s outside, right? So if I take e power, or you can also take minus e power 2s outside, right? Because minus also common, right? So minus, I'm going to take minus e power minus 2s. So again I taken minus outside, e power minus 2s outside, so we will be having 2 by s here, and I've taken minus outside, e power minus 2s outside, we will be having 1 by s square here, right? This is the required Laplace transform for the given function. Right? So we'll continue with the fourth problem, right? Yes. The fourth is find the Laplace transform. So find the Laplace transform of the function f of t is equal to modulus of t minus 1 plus modulus of t plus 1, and this t is strictly greater than or equal to 0, right? We need to find the Laplace transform for modulus of t minus 1 plus modulus of t plus 1. Now what I'm going to do is I'm going to break this into interval, right? I'm going to break this into interval. Now what I'm going to do is I'm going to check, I'm going to write this f of t as, now when t lies between 0 to 1, what about this value? When t is greater than 1, what about this value, right? So what happens when t lies between 0 to 1? So if t lies between 0 to 1, right? I'm excluding 1. And what happens if t is greater than or equal to 1, right? I'm going to check these two, because you can see when I put t is greater than 1, what about this value? If t is greater than or equal to 1, okay, you just recall what is the definition of mod x. So mod x will be, so just recall the definition of mod x, then it will be easy for you to understand, right? So what is mod x? So it will be x. If x is greater than or equal to 0, it will be minus x. if x is strictly less than 0, right? Yes. So whenever the inside term is greater than or equal to 0, so you write x as it is, and whenever the inside term is less than 0, you need to write minus of that x, right? Yes. Now we try to apply the limit, we will try to apply the definition here. Now what happens if I take t is greater than 1? So when t is greater than 1, what about this value? This value will always be greater than or equal to 0. And what about this value? This value is always greater than or equal to 0. Yes or no? When t is greater than or equal to 1, for example, if you put t is equal to 2, what about 2 minus 1, which is 1? So therefore, the inside value is always greater than or equal to 0 whenever this t is greater than or equal to 1. So therefore, if this x is positive means, so we need to write x as it is, right? So therefore, my t minus 1 will be t minus 1 as it is, and this t plus 1 will write t plus 1 as it is, right? I'm just applying the definition. Mod x will be x if the x is greater than or equal to 0. So this t minus, you take t minus 1 to be equal to x, and this t minus 1 is always greater than or equal to 0 whenever t is greater than or equal to 1. So therefore, mod x will be plus x, mod t plus 1 will be mod x, right? Yes. Now here comes the important part. Now what happens if t lies between 0 and 1? So for example, you just take t to be equal to 1 by 2. If you take t to be equal to 1 by 2, what about this inside term? This term will be negative, yes or no? What if you take t to be equal to 1 by 2, what is 1 by 2 minus 1? It is minus 1 by 2. What about this term? This term is positive, yes or no? So when t lies between 0 to 1, this term, this inside term will be negative, this inside term will be positive. Now if this inside term is negative, we need to write minus x, right? And here this term is positive, so we will write this t plus 1 as it is. That's it, right? So if you understand this f of t, then problem will be very easy for you, right? So I'll repeat what I have did. So I have just applied the definition of mod x. So if this inside term is positive, you write the term as it is. If the inside term is negative, you write minus of that term. That's it, right? If the inside term is if the inside term is positive, write that x as it. If the inside term is greater than or equal to 0, write that x as it is. If the inside term is less than 0, write as minus of that x, right? Minus of inside term. So you can see when t lies between 0 to 1, my inside term for this will be negative, therefore minus of that term. And for this term, the inside term will be positive when t lies between 0 to 1. So I'm writing this x as it is, right? Very easy. So therefore, my f of t is equal to, so minus t plus t will get cancelled. Minus 1 will be plus 1. So 1 plus 1 will be 2. So it will take 2 when t lies between 0 to 1, and this will be 2t, right? So this minus 1 and plus 1 will get cancelled. So it will take 2t when t is greater than or equal to 1, right? This is the f of t. Now it is very easy to find the Laplace transform of f of t, right? Yes. So we will find this. So we know that L of f of t is equal to integral 0 to infinity e power minus st into f of t dt, right? So we need to find Laplace transform for the given f of t. I'm going to break this as from 0 to 1, my f of t is 2. So from 0 to 1, my f of t is 2 into dt plus, and from greater than or equal to 1, that is from 1 to infinity, my f of t is equal to 2t, right? My f of t is equal to 2t, yes or no? Yes, from 1 to infinity, my f of t is equal to 2t. So therefore, we will be having e power minus st into 2t dt, right? Yes. So we need to integrate this. So this will be 2 times integral 0 to 1 e power minus st dt, and we need to integrate this, right? So let us take this 2 outside here also. We will be having this is equal to integral t into e power minus st dt. Limit is from 1 to infinity. So I can integrate this straight away because we have only one function of s. So this will be e power minus st divided by minus s. Limit is from 0 to 1 plus 2 times integral 1 to infinity t into e power minus st dt, right? Now call this as equation number 1. Now we will integrate this term and then we will substitute back here, right? So let us call this term as I1, right? Let us name this term as I1. Now we will find integral 1 to infinity you will find the value of integral 1 to infinity t into e power minus st dt, right? T into e power minus st dt. You will find this value. So t into e power minus st dt is. So again put u is equal to t, v dv is equal to e power minus st dt. Therefore my du will be dt and b will be e power minus st divided by minus s, right? So therefore this will be equal to uv minus integral v du. So u is t, b is e power minus st divided by minus s. Limit is from 1 to infinity minus integral v du. So e power minus st by minus s into dt. So when you put upper limit, so it will be infinity into 0. So upper limit will be 0 minus. So when you put lower limit t to be equal to 1, so 1 into e power minus s divided by minus s. This is the upper limit minus lower limit value, right? E power minus infinity is 0 minus lower limit is 1 1, right? 1 1 minus again this limit is from 1 to infinity, right? Limit is from 1 to infinity. So I can take this 1 by s outside. We'll be having integral 1 to infinity e power minus st dt. So this will be equal to, so this minus minus will be plus, so we'll be having 1 by s e power minus s, and if you integrate this, we'll be having e power minus st divided by minus s. Limit is from 1 to infinity. This implies this will be equal to 1 by s e power minus s, and we'll be having minus 1 by s square outside. E power minus st, limit is from 1 to infinity. So again upper limit will be 0 because e power minus infinity is 0 minus lower limit. So 0 minus lower limit is e power minus s, right? So the overall answer will be this will be equal to 1 by s e power minus s plus 1 by s square e power minus s, right? Yes, we'll write that this will be equal to 1 by s into e power minus s, 1 by s into e power minus s will be plus 1 by s square plus 1 by s square e power minus s, right? We can see when you put limit is from 1 to infinity, right? Yes. So call this as 2. Now substitute 2 in 1. Now substitute 2 in 1. So what is equation number 1? So we just go to equation number 1. So in equation number 1, we don't know this value, right, that we have found. So from 1 we'll be having from 1 we have 2 times e power minus st divided by minus s. Limit is from 0 to 1 plus 2 times integral 1 to infinity t into e power minus st dt, right? So from 1 implies this is 1, right? This is 1. So we have L of f of t, and this is 1 to infinity. Now this will be, so we just take minus 2 by s outside. The upper limit will be e power minus s, lower limit will be e power minus 0, right? Plus 2 times, so we already found this value, which is 1 by s e power minus s plus 1 by s square e power minus s, right? So this will be e power 0 is 1, so we'll be having minus 2 by s into e power minus s minus 1 plus 2 into 1 by s e power minus s plus 1 by s square e power minus s is the required Laplace transform. So if you want, what you can do is you can also simplify this to some more extent. So what you can do is you just take what you can do is you just take 2 by s outside. So if you take 2 by s outside, so here we'll be left with minus e power minus s, and if you take 2 by s outside, here we'll be having plus 1. If you take 2 by s outside, we'll be having e power minus s, and if you take 2 by s outside, we'll be having 1 by s e power minus s, right? Is the required Laplace transform for the given function. If you want, you can also simplify like here we'll be having minus, right? So if we take 2 by s outside, we'll be having minus e power minus s plus 1 is. So you can cancel these two terms. So we will be left with 2 by s into 1 plus e power minus s divided by s, right? So is the required Laplace transform for the given function. Start fifth problem. So find the Laplace transform. So find the Laplace transform of the function f of t, and this f of t is equal to, it will take the value t when t lies between 0 to 2, and it will take 3 if t is strictly greater than 2, right? This is our function. We need to find the Laplace transform for this given function, right? Yes. Solution. So again, a very easy problem. So we need to find L of f of t. So this is equal to integral 0 to infinity e power minus st into f of t dt, right? Yes. So again we'll break the interval. From 0 to 2 my f of t is t, and from 2 to infinity my f of t is equal to 3, right? So therefore I can write this as from 0 to 2 e power minus st, my f of t is t into dt, and from 2 to infinity my f of t is equal to 3, right? 3 into dt. So this will be integral 0 to 2 t into e power minus st dt from 2 to infinity 3 into e power minus st dt, right? Let us call this as I1 plus I2, right? So we will find these two integrals and then we will substitute back in equation number 1. So call this as equation number 1. Now we will find I1 and I2. We will substitute back here, right? Yes. Now we will find I1. So I1 is integral 0 to 2 t into e power minus st dt, right? So we know how to integrate this, right? So put u is equal to t and put v dv is equal to e power minus st. Therefore my du will be dt and v will be e power minus st divided by minus s, right? Integrate with respect to t. So therefore this will be uv minus integral v du. Here u and v here. So u is t, so we'll be having t into, so v is e power minus st divided by minus s. The limit is from 0 to 2 minus integral v du. So b is e power minus st divided by minus s, and du is dt, right? The limit is from 0 to 2. So therefore this will be, so I can take this minus 1 by s outside. We will be having t into e power minus st. Limit is from 0 to 2. And if I take this 1 by s outside, we will be having limit is from 0 to 2 e power minus st dt. So this will be minus 1 by s. So when you put upper limit, we will be having 2 into e power minus 2s. Lower limit will be 0, right? Because 0 into e power 0. When you integrate this, we will be having 1 by s into e power minus st divided by minus s. Limit is from 0 to 2, right? So overall we will be having this to be equal to minus 1 by s 2 e power minus 2s, and here will be having minus 1 by s square e power minus st. Limit is from 0 to 2, right? So therefore this will be minus 1 by s into 2 into e power minus 2s. So minus 1 by s square. So upper limit is e power minus 2s minus lower limit is 0. So we will be having e power minus 0. Therefore this will be equal to minus 1 by s 2 into e power minus 2s minus 1 by s square e power minus 2s. So when here we will be having 1, right? E power 0 is 1. We will be having plus 1 by s square. Call this as 2. This is the integration value of I1, right? Now similarly we need to find I2 also. So I2 is integral 2 to infinity 3 into e power minus st dt, right? So similarly I is equal to 3 times integral 2 to infinity e power minus st dt, right? 3 into e power minus st dt. So therefore this will be 3 times, so e power minus st divided by minus s, limit is from 2 to infinity. So I can take this minus 3 by s outside. So when you put upper limit, we'll be having e power minus infinity is 0, and when you put lower limit, we'll be having t, you put t to be equal to 2, so you'll be having this as 2s. So we'll be having 3 into e power 2s divided by s, right? This is the this is the value of i2. So now we'll substitute i1 and i2 in equation number 1, so that we will be having the required answer, right? Yes. So substitute i1 and i2 value in equation number 1, right? So L of f of t is equal to i1 plus i2. So it is given, we have already found i1, so i1 is this is the i1 value, so minus 1 by s 2 into e power minus 2s minus 1 by s square e power minus 2s plus 1 by s square, plus i2 value is 3 into e power 2s divided by s, right? 3 into e power minus 2s, right? Sorry, e power minus 2s divided by s, e power minus 2s divided by s. Now what we can do is, if I take e power minus 2s outside, right? If I take e power minus 2s outside, we will be having this term to be equal to, okay, I can combine this term and this term, right? This I can combine this term and this term. So if I combine this term and that term, we will be having, just combine this term and this term. So if I take e power minus 2s by s outside from these two terms, we will be having e power minus 2s by s, so we will be having minus 2, e power minus 2s by s outside we will be having plus 3. Let us keep this term as it is, right? Minus 1 by s square e power minus 2s plus 1 by s square. So minus 2 plus 3 is 1, so we will be having e power minus 2s by s minus e power minus 2s by s square plus 1 by s square is the required Laplace transform, for the given function. Right, for the given function. Very easy problem. So after this problem, we will be finishing this subtopic, and from the next class we will be moving on to the next subtopic in Laplace transform, right? Yes. So find the Laplace transform of the function whose graph is given as follows. So they haven't given the function directly, but they have given the graph. Right? So I'm going to draw the graph now. So they have given the graph as, so this is our y-axis and this is our x-axis. So this is t and this is f of t, right? So usually we will write x f of x, but here we are writing the variable to be equal to t. So what the graph they have given is up to t, right? Up to t it is a straight line, right? Up to t it is a straight line. So up to t, up to k, sorry. So up to k, that is x is equal, when up to x is equal to k, y is equal to k, it is a straight line. After that it is passing along y-axis, right? This is the graph they have given. So they have given that when x is equal to k, y is equal to k, up to this coordinate it is a straight line passing through origin, and from k to from k onwards it is a straight line along x-axis, right? Now what is the graph? What is the graph of this? What is the equation of this graph? Very easy, right? So you can see what is this? This is same as this is straight line, right? Straight line means what is the equation? Y is equal to x, right? Y is equal to x. So therefore this is equal to f of t is equal to t, right? F of t is equal to t. and this is what is the equation of this line? It is f of t is equal to 0, right? Because it is a function of t, so therefore we will be having f of t to be equal to 0. So they have given the equation as from 0 to k my f of t is t, and from k to t, right? That is from k to infinity, right? From k to infinity, because it is x-axis, right? It will go on and on. So from k onwards, it will be f of t is equal to k. So therefore, the given function is f of t is equal to, this will take t when t lies between 0 to k, right? When t lies between 0 to k, and it is 0 when t is greater than or equal to k. Now it is very easy to do the problem, right? So straight line passing through origin and the x-axis and the y-axis point are same. That is, for this point both the x coordinate and y coordinate are same. That means what? Y has to be equal to x. So here it is a function of t, so therefore y has to be equal to t. So therefore f of t is equal to t is the equation of straight line that passing through k comma k, right? That passing through k comma k. You should ask like, so sir, there are many line pass that will pass through origin. For example, y is equal to 2x, y is equal to 3x, y is equal to 4x, all will pass through origin. But remember, we have one coordinate to be equal to k comma k. That means y and x are same. That means what? It has to be y is equal to x line. If you take y is equal to 2x, means for y is equal to 2x line, this coordinate will not be same, right? So therefore, when the coordinates are same and passing through origin, means it has to be y is equal to x line. So therefore here y is a function of t, so therefore f of t is equal to t. Now you can easily find the Laplace transform as given function, and this is easy, right? This is straight line passing through, it is straight line along x-axis, so therefore y is equal to 0 line, right? So f of t is equal to 0. So we can find the Laplace transform of this function. So L of f of t, so L of f of t is equal to integral 0 to infinity e power minus st into f of t dt. Now I am going to break this into two parts. So from 0 to k, so this will be from 0 to k, right? From 0 to k, my f of t is from 0 to k, so f of t is k, right? So I write it like 0 to k e power minus st, f of t is k dt, right? So from 0 to k, my f of t is t, and from k to infinity, my f of t is 0, right? F of t is 0, so therefore I can cancel this integral. So we'll be left with integral 0 to k into e power minus st dt, right? So we can easily find the integral now, right? So therefore this is equal to, from 0 to k, my f of t is t. So from 0 to k, so e power minus st f of t dt, plus from k to infinity, right? From k to infinity, my f of t is 0. So we'll be having e power minus st into 0 into dt, right? So now this will be vanished. So we'll be having integral 0 to k t into e power minus st dt. So take u to be equal to t, v dv is equal to e power minus st. So we'll be having du is equal to dt. So v is equal to e power minus st by minus s. Therefore this will be equal to uv minus integral v du. So uv, so t into v is e power minus st divided by minus s. Limit is from 0 to k minus integral v du. So v is e power minus st by s, du is dt, right? So therefore you just apply upper limit and lower limit. So I can take this minus 1 by s outside. So if you take minus 1 by s outside, we'll be having t into e power minus st, right? T into e power minus st, t into e power minus st. Limit is from 0 to k, I can take this 1 by s outside. We'll be having integral e power minus st dt. So this will be minus 1 by s. So when you put upper limit, we'll be having k into e power minus sk. Lower limit will be 0 because 0 into something. When you integrate this, we'll be having e power minus st divided by minus s. So limit is from 0 to k, right? Limit is from 0 to k. The limit is from 0 to k. So therefore this will be minus 1 by s k into e power minus sk, and this will be minus 1 by s square, and here we'll be having e power minus st 0 to k. So here we'll be having minus 1 by s k into e power minus sk minus 1 by s square. So when you put upper limit, we'll be having e power minus ks minus e power 0 is 1. So when you multiply inside, we'll be having minus 1 by s k into e power minus sk minus 1 by s square e power minus sk plus 1 by s square, right? Therefore this is the required Laplace transform for the given function. If you want, you can also take this one minus 1 by s square outside, so that we'll be having e power sk minus 1, right? So we can I want to do that. So is the required Laplace transform, is the required Laplace transform for the given graph. So they have given the graph. So from this graph you need to form a function, and from that you need to find the Laplace transform, right? So very easy. So that's it. Moving on to the next subtopic, which is evaluation of integral using Laplace transform. That is, we're going to evaluate this integral using Laplace transform without even integrating. That is what the beauty of the upcoming videos, right? We're going to evaluate this integral. That is, we're going to find the value of this integral, but we are not going to integrate itself, right? That is, we're going to evaluate this integral using Laplace transform, right? So you must know the importance of Laplace transform. You must know the importance of Laplace transform, right? Without even integrating, we are finding the integral value for this using the method of Laplace transform, right? That is what we are going to do now, right? Yes. Solution. So you can see we need to evaluate this integral t into e power minus 2t cos t dt, right? I'm going to evaluate using Laplace transform. Now just recall the definition of Laplace transform, right? So L of f of t is equal to integral 0 to infinity e power minus st f of t dt. This is equal to f of s, right? This is the definition of Laplace transform. Now you just compare this and this, right? Just compare this and this. So we have integral 0 to infinity e power minus 2t into t into cos t dt, right? So just compare this and this. So we have integral e power minus st f of t dt. This is equal to Laplace transform of f of t. So my f of t here is t into cos t, and the only important thing is when you compare this and this, so you can see in place of f of t we have t into cos t. So and in place of s we have s to be equal to 2, right? So you just find L of f of t and then you put s to be equal to 2. That's it, right? So evaluating this integral is same as finding the Laplace transform of t cos t and then putting s to be equal to 2 in that value, right? So just compare this and this, and you can evaluate this integral when the limit is from 0 to infinity, right? The limit is from 0 to infinity. You can evaluate this integral using the method of Laplace transform, because in Laplace transform also limit will be from what? 0 to infinity, right? So just compare this and this. In place of f of t we have e power minus 2t cos t, and in place of f of t we have t into cos t, and in place of s we have s to be equal to 2, right? So find Laplace transform of t cos t and then you replace s to be equal to 2. That is the required integral value for this. That's it, right? Yes. Now we'll find the Laplace transform of this value. Now we will find Laplace transform of t into cos t, and then we need to put s is equal to 2, right? Yes. Now what is L of t into cos t? Very easy, right? So L of t into cos t. So we know that L of t power n f of t will be equal to minus 1 whole power n dn divided by dsn of L of f of t, right? L of f of t. This is the property that I already proved, right? That is the effect of multiplication of t power n by f of t in finding the Laplace transform, right? That is L of t power n f of t will be equal to minus 1 whole power n dn by dsn of L of f of t. So here n is equal to 1 here. So therefore we will be having minus 1 whole power 1 d by ds of L of f of t, which is cos t, right? So L of t power 1 f of t. So we know that L of t power n f of t is this, right? So L of t power n f of t is this value. So you put n to be equal to 1, you'll be getting this, right? F of t is cos t. So this will be equal to minus 1 into d by ds of, so what is L of cos at? So L of cos at will be equal to s by s square plus a square. Remember all the basic formulas and all the properties and results, you can do any problem easily, right? So L of cos t will be s by s square plus a square. Now you need to here we need to find L of cos t, right? That means a will be equal to 1. So we will be having this to be equal to s square plus 1 square, which is 1, right? So we will be having 1 by s by s square plus 1, right? S by s square plus 1, because a is equal to 1 here, right? L of cos 1t, so 1 s by s square plus 1. Now differentiate this using the quotient rule. So already have minus 1 here, so s square plus 1 v into u dash minus u into v dash divided by v square, which is s square plus 1 whole square, right? I'm just differentiating u by v, right? U by v will be v into u dash minus u into v dash by v square. So you keep s square plus 1 as it is, derivative of s is 1, minus you keep s as it is, derivative of this is 2s plus 0 divided by v square, which is s square plus 1 whole square. Now this is equal to minus of, so this will be s square plus 1 minus 2s square divided by s square plus 1 whole square. So this will be equal to minus of s square minus 2s square will be minus s square plus 1 divided by s square plus 1 whole square. Now if we take minus inside, we will be having s square minus 1 divided by s square plus 1 whole square is the Laplace transform of t into cos t, right? So far we have found Laplace transform of t cos t, but remember we need to find this integral value, right? So therefore from start we have integral 0 to infinity e power minus 2t t into cos t is same as, so L of e power minus st f of t dt is equal to L of f of t. In that you need to put s to be equal to 2, right? S to be equal to 2. So what is L of t cos t? So L of t cos t is s square minus 1 divided by s square, you can see this is s square minus 1 divided by s square plus 1 whole square. So in this you need to put s to be equal to 2, right? So we just put this dt. So when you put s to be equal to 2, we will be having 2 square minus 1 divided by, so 2 square plus 1 whole square. So this will be equal to, we need to find L of e power minus 2t cos t, right? Yes. So this will be equal to, so 2 square minus 1 is 2 square is 4, 4 minus 1 is 3 divided by, so 2 square is again 4, 4 plus 1 is 5, so this will be 5 square, right? So we will be having this to be equal to 3 by 25, right? We will be having this to be equal to 3 by 25 is the value of this integral when you integrate. You can see the importance of Laplace transform, right? So we haven't even integrated that, but we have found the integral value. The integral value is equal to 3 by 25, 3 by 25, right? Because 2 square is 4, 4 plus 1 is 5, 5 square is 25. You will be having 4 minus 1, right? So therefore integral 0 to infinity e power minus 2t t into cos t dt will be equal to 3 by 25. So you can use the Laplace transform method, and remember the limit has to be from 0 to infinity, right? The limit is from 0 to infinity only. We can equate these two, because when we can equate these two, you can see 0 to infinity, 0 to infinity. F of t is t cos t. So you find Laplace transform of f of t. In that you replace s by 2, right? S by 2, right? Very easy. So these are the problems that we're going to see in the upcoming videos, right? We're going to evaluate the integral using Laplace transform. Without even integrating, we are going to find the integral values using the Laplace transform, right? So just write this in this format, right? You write this in this format. L of f of t is equal to integral 0 to infinity e power minus st f of t dt. So just compare the given question and this, right? You just compare the given question and this. So if you compare this, you will be having s to be equal to 2, f of t to be equal to t cos t. So this integral is same as L of f of t. So you just find L of f of t, but the important thing is instead of s, we have s to be equal to 2. So put s is equal to 2. So after finding this Laplace transform, in this Laplace transform value, put s is equal to 2. So I'm finding Laplace transform of t cos t. So it turns out to be s square minus 1 divided by s square plus 1 whole square. You put t to be s to be equal to 2, because here we have e power minus 2t, right? Suppose if the same question was asked like integral 0 to infinity, instead of e power minus 2t, if you have e power minus 3t, you need to put s to be equal to 3. That's it, right? If you put s to be equal to 3, instead of if you have e power minus 4t, you put s to be equal to 4. That's it, right? If you have e power plus 2t, you put s is equal to minus 2. That's it, right? If you have t into e power plus 2t, means when you equate these two, you need to put s is equal to minus 2. That's it, right? So to next problem in finding the evaluating the integral using Laplace transform, right? Yes. So we'll move on to problem number 2. So problem number 2. We evaluate so the problem number 2 is integral 0 to infinity t into e power minus t sin 4t dt, right? So we are going to evaluate this integral value without even integrating, right? Yes. So you can see the importance of Laplace transform, right? Yes. Now again we know the definition, right? So what is definition? So we know that L of f of t, right? Laplace transform of f of t is equal to integral 0 to infinity e power minus st f of t dt, right? Now just compare this with, I'm going to write this as integral 0 to infinity, I'm going to write this as integral 0 to infinity e power minus t into, so I'm going to take this term as f of t, that is t into sin power 4t dt, right? Now I'm going to make use of this definition. Integral 0 to infinity e power minus st f of t dt is equal to Laplace transform of f of t. So what is f of t here? This is f of t, right? This is f of t, integral 0 to infinity e power minus st f of t dt. So I'm going to find Laplace transform of t into sin power 4 tt, and the important thing is here we have s, but here we have what? Here we have e power minus st, here we have e power minus t. That means what is the value of s? S is equal to 1. So you just find the Laplace transform for t sin power 4t. In that answer you put s is equal to 1 to get the value of this integral. Call this as star, right? Same as previous problem. The previous problem s is equal to 2, here we have s is equal to 1, right? You just compare e power minus t and e power minus st. So that means s is equal to 1 here, right? Yes. Now we will find the Laplace transform of t into sin power 4t, right? These are very easy. So you know how to find the Laplace transform of t into sin power 4t, right? So what we will do is before finding this Laplace transform, we will simplify this sin power 4t, right? We will simplify sin power 4t. So now we will find the Laplace transform of, now we will find the Laplace transform Now we will find the Laplace transform of t into sine power 4 tt, right? So the t into sine power 4 t. So what we'll do is we will simplify this. So t sine power 4 t is same as t into sine square t whole square, right? Sine square t whole square is same as sine power 4 t. So what is sine square t? It is 1 minus cos 2t by 2 whole square, right? So sine square t is 1 minus cos 2t by 2. Sine cos square t is 1 plus cos 2t by 2, right? So sine square t, I think I don't want to write this, right? Sine square t is 1 minus cos 2t by 2, and cos square t will be 1 plus cos 2t by 2, right? Yes. So now you again expand this in a minus b whole square formula. So I can take this t by 4 outside. So a square plus b square minus 2 times ab, right? Minus 2 times ab. So what we will do is we will again apply this cos square t formula here. So I can write this as t by 4. So let us take this 1 minus cos 2t to one side. And what is the Laplace transform of cos square t? It is 1 plus cos 2t by 2. But here we have t to be equal to 2t. So this will be 1 plus cos 4t by 2, right? 1 plus cos 4t divided by 2, right? That is, so you put t to be equal to 2t, right? Because here we have cos square 2t. So if you put t to be equal to 2t here, so this will be t is equal to 2t. That means 2 into 2t is cos 4t divided by 2, right? Yes. This is cos square t. So just put t to be equal to 2t. So you just refer here, right? Put t is equal to 2t. So that you can find the formula for cos square 2t. Very elementary, right? Very elementary. So now we'll simplify this once more. So this will be equal to t by 4 into, so this I write this as 1 minus 2 cos 2t plus 1 by 2 plus cos 4t divided by 2, right? So I can combine this and this. So 1 plus 1 by 2 will be, so this will be t by 4. So 1 plus 1 by 2 is 3 by 2. So 3 by 2 minus 2 cos 2t plus cos 4t divided by 2, right? Now you just multiply t inside. If you multiply t inside, we will be having like so if you multiply t inside, so we will be having like what we can do is, okay, so this will be, so multiply t inside, we will be having 3t divided by 8 minus 2 by 4, right? So 2 by 4 will be 1 by 2. So this will be t into cos 2t divided by 4, right? So multiply 4 inside, this 2 will get cancelled. So this 2, right? Sorry. So this 2 and this 2 will get cancelled. So we'll be having 2 1s are 2 2s are, and when you multiply this inside, we'll be having t into cos 4t divided by 2, right? Now what is our aim? Our aim is to find the Laplace transform of t into sine power 4t. In that answer, you need to put s is equal to 1, right? So far we haven't found Laplace transform. We have only simplified t into sine power 4t. Now we will try to apply Laplace transform, right? So therefore Laplace transform of t into sine power 4t, t into sine power 4t is equal to, so sine power 4t is same as 3t divided by 8 minus t into cos 2t divided by 8 plus t into cos 4t divided by, sorry, this again 8, right? Sorry, because when you multiply this 4 inside, we'll be left with 8, right? Sorry, this will be multiplied divided by 8, right? Yes. So this will be this 8, right? Yes. Now try to apply Laplace transform, and we know Laplace transform satisfies linearity property. So this will be equal to 3 by 8. So what is Laplace transform of t? L of t power n is n factorial by s power n plus 1, right? Okay. Minus, you can take this 1 by 2 outside, L of t into cos 2t plus 1 by 8 L of t into cos 4t, right? Yes. Now we will try to use all those formulas here. So this will be 3 by 8. Now what is L of t power n? So L of t power n is equal to n factorial by s power n plus 1. So when you put n to be equal to 1, so L of t will be 1 by s square, right? So all are very basic formulas. So this will be 1 by 2 into, and we know effect of multiplication of t. So this is minus 1 into d by ds of L of cos 2t, and this will be 1 by 8 into minus 1 into d by ds of cos 4t, right? So we know that L of t power n is n factorial by s power n plus 1, and we know what is the effect of multiplication of f of t by t power n, right? So L of t power n into f of t is same as minus 1 whole power n dn by dsn of L of f of t. We have already proved this all, right? Yes. Now we will simplify this and then we put s to be equal to 1 to find the values, right? Yes. So this will be equal to, so we will be having 3 divided by 8 s square. I can take this minus this to be plus 1 by 2. Now what is derivative of, okay, you will write like d by ds of, and cos 2t is s by s square plus 4, right? Because s by s square plus a square, a is equal to 2 here, plus 1 by 8. So I can also write this as minus 1 by 8, right? I can write this minus outside. So d by ds of cos 4t will be s by s square plus a square. So my a is equal to 4 here, right? Yes. So this will be 3 by 8 s square plus 1 by 2. Now apply this derivative formula, quotient rule. So s square plus 4 into 1 minus s into 2s divided by s square plus 4 whole square, and here will be having 1 by 8. So again apply the quotient rule, s square plus 16, derivative of s is 1 minus s into 2s. If you differentiate this, will be having 2s plus 0. This will be s square plus 16 whole square, right? This is the Laplace transform of t into sine power 4t. Now we need to substitute, we don't need to simplify, right? What we can do is we can straight away substitute s is equal to 1, right? Because we need to find this integral value. This integral value is nothing but Laplace transform of t into sine power 4t. In that you put s is equal to 1, right? So what you can do is, so from start substitute s is equal to 1, right? So if you substitute s is equal to 1, you can get the value of integral 0 to infinity e power minus st t into sine power 4t dt, sine power 4t dt. So straight away put s is equal to 1. So this will be 3 by 8 plus 1 by 2 into, so when you put s is equal to 1, this will be 1 plus 4 is 5 minus 1 1. So this will be 5 minus 2 divided by, if you put s is equal to 1, 1 plus 4 is 5, so 5 square is 25 plus 1 by 8, and when you put s is equal to 1, 1 plus 16 is 17 minus, when you put s is equal to 1 here, we will be having 2 divided by, yes, 1 plus 16, so this will be 17 square, right? This will be 17 square. So now you just take LCM, you will be getting the required answer, right? 17 minus 2, so this will be equal to 3 by 8 plus 1 by 2, 3 by 25 plus 1 by 8, 15 divided by 17 square, right? So 17 into 17 will be, so 7 are 49, 1 are 7, 7 plus 4 is 11, this will be 7, so it will be 289, right? 17 is 289, so this will be 289. Now what we can do is, we can just, sorry, this is minus, right? Sorry, I just missed minus here. So minus 1 by 8, right? So minus 1 by 8, sorry, this is minus 1 by 8, right? So minus, so this will be minus, will be minus 1 by 8. Now I think you can do this, right? So this will be 3 by 8 plus 3 by 50 minus 15 divided by 8 into 289. So I think you can take LCM now. So if you take LCM, you will be having 3 by 8 plus 15. So if we take LCM, you will be getting the answer. You will be getting the answer as 3096 divided by 7225, right? So I think I take LCM now. Therefore, this is the value of this integral from 0 to infinity when you make use of Laplace transform, right? So very easy. So you just have to understand the importance of Laplace transform. You can see how complicated this integral is, but without even integrating this, we have found the value of this integral using Laplace transform, right? Third problem of evaluating the integral using Laplace transform, right? So third problem is evaluate integral 0 to infinity e power minus at minus e power minus bt divided by t into dt, right? So we need to evaluate this integral 0 to infinity e power minus at minus e power minus bt divided by t, right? Yes, we're going to find this integral value, right? Yes. Now I'm going to make use of Laplace transform method. We know by definition L of f of t, right? L of f of t is equal to integral 0 to infinity e power minus st f of t dt, right? Now I can write this as integral 0 to infinity e power minus 0 t. I'm going to take this full function as f of t now, right? E power minus at minus e power minus bt divided by t into dt. Now you can see when you compare this and this, so I have written this in this form, right? Integral 0 to infinity e power minus st f of t dt, right? Actually this is same as f of s, right? Because f of s is the Laplace transform f of t. So you just find the Laplace transform of, so what it means is integral 0 to infinity e power minus st f of t dt is same as L of f of t. So my f of t here is e power minus at minus e power minus bt divided by t. So this is same as you find Laplace transform of f of t. So what is f of t? F of t is e power minus at minus e power minus bt divided by t. In that you put s to be equal to 0, right? Because when you compare this and this, in place of s we have s to be equal to 0 here, right? So in the first problem we have put s to be equal to 2. The second problem we have put s to be equal to 1. So in this problem we need to put s is equal to 0, right? So when you compare this and this, so instead of f of t we have e power minus at minus e power minus bt by t, and instead of s we have 0. So you find Laplace transform of f of t. In that answer you put s is equal to 0 here, because L of f of t is same as f of s. So here s is equal to 0. So therefore capital F of 0 is the required answer for this integral, right? So this is same as f of 0, yes or no? Because L of f of t is capital F of s. In that s you put 0. So both are same, right? Or you can also write this as this to be equal to capital F of 0, but no problem. So you just find Laplace transform of this function and you put s is equal to 0 in this answer. Call this to be equal to star, right? Now we will find the Laplace transform of this function. Now to find Laplace transform of, now we will find the Laplace transform of the function. So we need to find Laplace transform of e power minus at minus e power minus bt divided by t, right? So we know that what is the effect of division of f of t, right? If you already know the result that, so what is the result we have seen? So L of 1 by t f of t, right? L of 1 by t f of t is equal to integral s to infinity L of f of t into ds, right? This is the formula that we have given you. What is the division of f of t by t in finding the Laplace transform, right? You also proved this also. Now I'm going to make use of the result here. So L of 1 by t f of t is equal to, so this is equal to integral s to infinity L of, so what is f of t here? F of t is e power minus at minus e power minus bt, right? Okay, so if you have more clarity, what we can do is I will write like this, right? So L of 1 by t into f of t. So f of t is e power minus at minus e power minus bt. Now we just apply this result here. L of 1 by t f of t is equal to integral s to infinity L of f of t into ds. So just find the Laplace transform of e power minus at minus e power minus bt, and then you put ds, right? Yes. Now we will find the we know Laplace transform is it satisfies linearity property. So this will be integral s to infinity. So what is L of e power minus at? It is 1 by s plus a. What is L of e power minus bt? It is 1 by s plus b into ds, right? Into ds. Yes or no? So what is L of e power minus at? L of what is second shift? This is second shifting property, right? So L of Laplace transform of e power at is L of Laplace transform of e power at is 1 by s minus a, and the Laplace transform of e power minus at is 1 by s plus a. These are very it is a shifting property. It is direct formula, right? L of e power at is 1 by s minus a. L of e power minus at is 1 by s plus a. These are direct formulas. So now we'll integrate this. So this will be integral s to infinity 1 by s plus a ds minus integral s to infinity 1 by s plus b ds, right? Now this is equal to what? Now this is log s plus a, this is log s plus b. So I can write this as log of so this is log s plus a. Okay, let me write step by step. So this is log s plus a minus this is log s plus b. Now for both the limit is from s to infinity, right? So we know log a minus log b is log a by b. So this is log of s plus a divided by s minus b. Limit is from s to infinity, right? Yes. Now when you put upper limit to be equal to infinity, actually we cannot put infinity directly because log infinity is not defined. So we will do like limit s tending to infinity log of s plus a divided by s plus b, right? S plus a, s plus b minus lower limit. Lower limit is you need to put s as it is, right? So this will be log of s plus a divided by s plus b. Now this will tend to 0, right? Because when s tending to infinity, this will tend to infinity, this will tend to infinity. So infinity by infinity will be 1. So it will get this will tend to log 1, right? This will tend to log 1 minus we will be having log of s plus a divided by s plus b, and log 1 is 0. So we will be having this value to be equal to minus log of s plus a divided by s plus b. So this is the Laplace transform. I think I have already discussed, right? I have already discussed how to find this limiting value. If not, what you can do is so limit s tending to infinity. So log of, you just take s outside here. So we'll be having 1 by a by infinity, and you just take s outside here. We'll be having 1 by b by infinity. This s will get cancelled. So when you put I'm taking s common, right? So if we take s common, what will be have? So if we take s common, we'll be having 1 plus a by s divided by, if we take s common here, we'll be having 1 plus b by s. So these two will get cancelled. When s tending to infinity, this will tend to 0, right? Because a by infinity is 0, b by infinity is 0. So we'll be having log 1 plus 0 divided by 1 plus 0. So this is same as log 1, right? So therefore this will tend to log 1 when s tend to infinity. So log 1 is 0. So we'll be having 0 minus log of s plus a divided by s plus b. So what is this? This is the Laplace transform for L of e power minus at minus e power minus bt divided by t, right? Now what we need to do? So to evaluate this integral, we need to find Laplace transform for this. In that answer, you need to put s to be equal to 0. So therefore integral 0 to infinity e power minus at minus e power minus bt divided by t will be equal to, we need to find Laplace transform for this, and then need to put s is equal to 0, right? So L of e power minus at minus e power minus bt divided by t. In that answer, you need to put s to be equal to 0. So this answer is minus log of s plus a divided by s plus b. This is the Laplace transform for this function. If you put s to be equal to 0, so you will be having minus log of a by b, right? Minus log of a by b. If not, you can also write this as log of a by b whole power minus 1, right? Because log you can take this power to numerator power, you can take this term to power, or you can also write this as log of b by a when you take inverse, right? Therefore this is the integral value for the given integral, right? So you can see how easy it without even, we haven't even integrated, right? We haven't even integrated, but we have found the answer this to be equal to log of b by a very easily, right? So that is the powerful of Laplace transform in evaluating the integral. Without even integrating the integral, we can easily find the integral value which is equal to, for this problem, log of b by a, right? Yes. So now we'll move on to fourth problem in evaluating the integrals using Laplace transform, right? Yes. So fourth problem, so evaluate. If you haven't watched all the previous videos, watch continuously, then only you will have a continuation, right? Yes. So evaluate integral 0 to infinity t into e power minus 3t sin t dt, right? Evaluate this. Now we're going to evaluate this. We're going to evaluate this integral, right? Yes. Now I'm going to make use of Laplace transform. So we know that. What is Laplace transform formula? So L of f of t is equal to integral 0 to infinity e power minus st f of t dt, or this is same as capital F of s, right? I'm going to write this as integral 0 to infinity e power minus 3t into f of t. I'm going to write f of t as t into sin t dt. Now we compare this and this, integral 0 to infinity, and remember we can make use of this Laplace transform only when the limit is from 0 to infinity, right? The limit is not from 0 to infinity, we can't use Laplace transform to evaluate the integral. Okay, so when you compare this and this, so you can see instead of f of t we have t into sin t, and instead of s we have this to be equal to 3. So this is same as L of f of t. So what is L of f of t? L of f of t is equal to, so let me wait. Now here my f of t is t into sin t, right? So this is L of f of t. So f of t is t into sin t. You find this Laplace transform of t sin t. After that you need to put s to be equal to 3, because when you compare this and this, here we have e power minus st, but here we have e power minus 3t. So that means s is equal to 3, right? So call this as equation number star, or you can also write this as f of 3 is the required integral value for this integral. So you will find the Laplace transform of t sin t. In that you put s to be equal to 3, right? Yes. Now to find Laplace transform of L of t into sin t, right? We're going to make use of property that the multiplication of f of t by t. So we're going to make use of property now. So we know that L of t into sin t. So what this will be? This will be minus 1 into d by ds of L of f of t, which is sin t, right? So if you want to make use of, if you want to write the formula again, so we know that L of t power n into f of t, right? T power n f of t is equal to minus 1 whole power n dn divided by dsn of L of f of t. So I have already proved this formula also, right? We have already proved this formula. This is a property, right? Okay. So here we put n is equal to 1 here, right? If you put n is equal to 1, we will be having minus 1 whole power 1 ds by ds of L of f of t. So f of t is sin t, t power n f of t, right? Yes, n is 1. So this will be equal to minus 1 into d by ds of, so what is L of sin at? So it is 1 by s square plus 1, right? Yes or no? Because L of sin at is a by s square plus a square. So a is 1, so 1 by s square plus 1. So now apply, now differentiate this with respect to s. So we know the derivative of 1 by x is minus 1 by x square. So minus 1 by x square, differentiate inside, we'll be having this as 2s. If not, make use of quotient rule, right? Okay, let me do this quotient rule. If not, you can also do this directly using derivative of 1 by x is minus 1 by x square, right? Yes. We will be having this as s square plus 1 into 0 minus 1 into derivative of s square is 2s divided by s square plus 1 whole square. So this will be equal to, so this minus minus will be plus. So we will be having 2s divided by s square plus 1 whole square, right? S square plus 1 whole square. So this is the Laplace transform of t sin t. But what we need to do, we need to evaluate this integral. So therefore from start, from start we have integral 0 to infinity e power minus 3t t into sin t is same as L of t into sin t. In that answer you need to put s to be equal to 3, right? So therefore this will be 2s divided by s square plus 1 whole square. In that you need to put s to be equal to 3. So what happens when you put s to be equal to 3? So this will be 2 into 3 divided by, so 3 square is 9, so 9 plus 1 whole square. So this will be 6 divided by 10 square is 100. So this will be, when you cancel this out, we will be having this as 2 3s are 2 50s are. So 3 by 50 is the required integral value for this integral, right? You can see how easily we have evaluated this integral by using Laplace transform. If we have the limit is from 0 to infinity, right? Without even integrating, that is the beauty, right? Yes. So now we'll move on to fifth problem. So evaluate integral 0 to infinity e power minus t e power minus 3t divided by t into dt, right? Now this is similar to the third problem that you have already seen, right? So we already solved what is the value of integral. So you can see this is third problem that we have solved in the last video. So integral 0 to infinity e power minus at minus e power minus bt divided by t will be equal to, we already solved this for general AB, right? So it turns out to be this is equal to log b by a, right? So I'm not going to do this. You can, if this question is asked, you can do that problem. In that problem you put a to be equal to 1, b to be equal to 3, right? So we already proved what we have proved, integral 0 to infinity e power minus at minus e power minus bt divided by t dt is equal to log of b by a, right? So refer problem number 3. In problem number 3 we have already proved this. So here you put a to be equal to 1. Here put, this is very important problem, right? So you will get these kinds of problem. So remember this result, a and b can vary in exam, right? So put a to be equal to 1, b to be equal to 3. So therefore when you put a to be equal to 1, b to be equal to 3, this will be integral 0 to infinity e power minus t e power minus 3t divided by t dt will be equal to log of b by a. So this is log 3 by 1, which is log 3, right? Therefore log 3 is the required answer for this integral, right? So you can do like, you can do without, you can make use of problem number 3. If not, you do similarly like problem number 3, right? Wherever you have a, put that to be equal to 1. Wherever you have b, put that to be equal to 3. If not, we will prove in general, like you prove the third problem. After proving third problem, you put a to be equal to 1, b to be equal to 3. So therefore this will be log 3. So evaluate integral 0 to infinity, and remember when the limit is from 0 to infinity, you can use the definition of Laplace transform to find the integral values, right? Cos 6t minus cos 4t divided by t into dt. We need to evaluate this, right? We need to evaluate this value. Now I'm going to make use of Laplace transform definition, to evaluate this integral, right? Yes. So we know that L of f of t, so Laplace transform of f of t is equal to integral 0 to infinity e power minus st f of t dt. This is same as capital F of s, right? Now I'm going to write this as integral 0 to infinity e power minus 0t into f of t. I'm going to write this f of t as cos 6t minus cos 4t divided by t, right, into dt. Now you just compare this and this. So integral 0 to infinity e power minus st f of t dt. This is same as Laplace transform of f of t. So what is f of t here? So f of t is cos 6t minus cos 4t divided by t, right? L of cos 6t minus cos 4t divided by t. In that answer you need to put s to be equal to 0. Why? Because when you comparing this and this, you can see here we have e power minus 0t, but here we have e power minus st. That means you just find L of f of t. In that you put s is equal to 0, or you need to find capital F of 0, right? Both are same. So what we will do is call this as star. So now we will find the Laplace transform for this function. After finding Laplace transform for this, you put s is equal to 0. That will be the integral value for this given integral, right? Yes. Now to find Laplace transform, of, so we need to find the Laplace transform of L of cos 60 minus L of cos 4t divided by 2, right? So L of cos 60 minus cos 4t divided by t. So we already know that the formulas, right? So that is L of 1 by t f of t, right? We already proved this. This is equal to integral s to infinity L of f of t into ds, right? We already proved this. So we'll try to make use of this formula now. So this will be equal to integral s to infinity, so L of 1 by t f of t. So 1 by t f of t is cos 60. Okay, if you want I can also write this in some other step. So L of 1 by t into, so I'm going to take f of t as cos 60 minus cos 4t, right? Yes. So this will be, so if I apply the formula L of 1 by t f of t, this will be integral s to infinity L of f of t ds. So this will be cos 60 minus cos 4t into ds, right? Into ds. Now we know that Laplace transform satisfies linearity property. So this is integral s to infinity. So L of cos 60 is s by s square plus a square. So a is 6 here, right? And here this will be s by s square plus a square, which is 16 here, into ds, right? Into ds. Now what we will do is, so we have L of cos 60 is s by s square plus 36, and we have L of cos 40 is s by s square plus 16. So what we need to do is we need to integrate, and then we need to put ds, right? Okay, so this will be integral s to infinity s by s square plus 36 minus, into ds, and here we will have integral s to infinity s by s square plus 16 into ds, right? Now we know the formula that integral f dash of s divided by f of s is equal to log of f of s, right? We already used this formula many times. So but here we have, you take this as f of s. What is the derivative? It is 2s, but we have only one s here. So what I'm going to do is I'm going to multiply this with 1 by 2, and I'm going to multiply this with 2, so that we will be having this to be integral 0 to infinity 2s divided by s square plus 36 minus, and similarly here also I'm going to multiply this with 2, integral s to infinity. Here I'm going to multiply this by 2. So I'm multiplying and dividing by 2 just to apply the formula. That's it, right? Okay, so this will be, so okay, I write this clearly. Okay, so this will be 1 by 2 integral s to infinity 2s divided by s square plus 36 ds, and similarly here also I'm multiplying dividing by 2 just to make use of this formula, right? I'm making use of this formula. So I can apply integral divide f dash of s divided by f of s, right? Derivative of s square plus 36 2s, and similarly here also derivative of s square plus 16 is 2s. So I can write this as, I can take this 1 by 2 outside. So if I take this 1 by 2 outside, this is log of f of s, which is s square plus 36, minus this is log of f of s, which is s square by 16. Limit is from s to infinity, right? Very easy, right? So if I apply the formula here, this integral is integral f dash of s by f of s ds, right? Okay, sorry, here we have ds. This will be log of f of s. So this is log of f of s is s square plus 36, and here I've taken 1 by 2 outside, right? I've taken 1 by 2 outside for both the term. This integral is log of s square plus 36. This integral is log of s square plus 16. So integral f dash of s divided by f of s ds is equal to log of f of s. So f of s is s square plus 36, right? Yes. So this will be equal to 1 by 2, and we know that log a minus log b will be log a by b. This will be s square plus 16 divided by, sorry, s square 36 divided by x square plus 16. Limit is from s to infinity, and when you apply upper limit and lower limit, so when you apply upper limit, we will be having 1 by 2 into limit s tending to infinity log of s square plus 36 divided by s square plus 16, minus when you apply lower limit is s as it is, right? So this will be I've taken 1 by 2 outside, so this will be log of s square plus 36 divided by s square plus 16, right? S square plus 16. So when you put s tending to infinity, this will tend to log 1, right? So we have already seen this will tend to log 1, because when s tending to infinity, this will tend to 1. This entire term will tend to 1, right? So we can take this s square outside, so we'll be having 1 plus 36 by s square. So okay, if you want, I can also write this as log of, so if we take s square outside, we'll be having 1 plus 36 by s square, and if we take s square here outside, we'll be having 1 plus 16 by s square. So these two will get cancelled. So when s tending to infinity, this will tend to 0, this will tend to 0, right? Because 1 by infinity is 0, 36 by infinity is also 0. So we'll be having log of 1 plus 0 divided by 1 plus 0. So this will tend to log 1, right? So this will be log 1 minus log of s square plus 36 divided by s square plus 16. And we know log 1 is 0. So we'll be having this as minus 1 by 2 log of s square plus 36 divided by s square plus 16 is the Laplace transform for this given function, right? Yes. Now what we need to do after finding Laplace transform for this, we need to put s is equal to 0, right? We need to put s is equal to 0 to obtain the integral of our value. So if you want, you can also simplify, like when you put s is equal to 0, we'll be having 36 by 16. So minus 1 by 2 log 36 by 16 is the required answer. If not, you can also do like, if you take 4 outside, okay. So therefore when you put s is equal to 0, so from star we have, so we need to evaluate this integral, right? So what we need to evaluate, so integral 0 to infinity cos 6t minus cos 4t divided by t dt. This is what we need to evaluate. This is equal to Laplace transform of cos 6t minus cos 4t divided by t. In that answer, you need to put s is equal to 0, right? That is what we have in star, right? That is what we have in star, that this integral is equal to Laplace transform of this, and put s is equal to 0. So we already obtained this integral, so that this Laplace transform, this minus 1 by 2 log of s square plus 36 divided by s square plus 16, you put s is equal to 0 now. So this will be equal to what? Minus 1 by 2 log of 36 by 16, right? 36 by 16. So this is same as so I can also write this as log of 36 by 16 whole power minus 1 by 2, right? 36 by 16 minus 1 by 2, because log a power x is x log a, right? Log of a power n is n times log a. So this is, I can write this as log of 16 by 36 whole power 1 by 2, right? Minus, if I am taking reciprocate, so cancel minus. So this is equal to, so if I take square root, this will be log 4 by 6, right? Log 4 by 6, because root 16 is 4, root 36 is 6. This is same as log of 2 by 3, right? If I cancel this by 2, 2 2s are, 2 3s are. Therefore, log 2 by 3 is the required integral value for this integral, right? So you can see how complex the integral is, but we have integrated this term and we have found the integral value without even integrating this using the Laplace transform. So this turns out to be log of 2 by 3, right? So the value turns out to be log of 2 by 3. So this is problem number 6. So in the next video, we'll move on to problem number 7 of evaluating this integral without integrating with the help of Laplace transform. And remember, you can apply Laplace transform formula when you have limit from 0 to infinity. So it turns out to be log 2 by 3 is the required answer, right? Problem. So 7th problem and 8th problem are alike. So if you understand 7th problem, you can do 8th problem in your own, right? So 7th problem is, so show that integral 0 to infinity sin x square dx is equal to 1 by 2 root pi by 2, right? 1 by 2 root pi by 2 with the help of Laplace transform. So you're going to find the value of this integral and you're going to show that it is equal to 1 by 2 root of pi divided by 2, right? Yes. We'll move on to solution. It's a very interesting problem. So we need to find this integral, right? We need to find the value of integral 0 to infinity sin of x square dx, right? Yes. Now what I'm going to do is I'm going to make some substitution. So put t is equal to x square. So therefore, so differentiate with respect to x. So this will be x. So we'll be having, so this will be dt by dx. This will be equal to 2x, right? With respect to x, so this will be equal to 2x, right? Will be equal to 2x. So therefore, this will be, so that means dt is equal to 2x into dx. So that means dx will be equal to 1 by 2x into dt. So I can write x to be equal to root t, right? Because t is x square, x is root t. This is 1 by root t dt, right? So therefore dx will be equal to, so dx is 1 by 2 root t dt, right? Yes. So therefore this integral now will be integral 0 to infinity sin x square dx will now be equal to integral 0 to infinity. The limit will remain same, right? So even when you put t is equal to x square, the limit will remain same, 0 square infinity square, right? Yes. So sin of, so x square is t, dx is 1 by 2 root t dt, right? Yes. So evaluating this integral is same as evaluating the integral 0 to infinity sin t 1 by 2 root t dt, right? Yes. Now to evaluate this integral, what I'm going to do is I'm going to make use of some adjustment. This will be integral 0 to infinity. I'm going to write sin t as e power it minus e power minus it divided by 2i, right? So already we have 1 by 2 root t into dt, right? So what I'm doing is, so I'm just writing sin t to be equal to e power it minus e power minus it divided by 2i, right? Because e power it is cos t plus I sin t, e power minus it is cos t minus I sin t. So when you minus, you will be having 2i sin t. So this 2i will get cancelled. So you'll be having sin t, right? Both are same. Sin e power it is cos t plus I sin t, and e power minus it will be cos t minus I sin t. So when you subtract this, these two will get cancelled. You will be having 2i sin t. So when you divide this by 2i, so you'll be getting sin t, right? So when you subtract and divide by 2i, sin t is same as this. Now I'm going to take this 1 by 2i outside. 1 by 2i outside. This will be integral 0 to infinity e power it divided by what we can do is I can also take this 2 also outside, right? Okay, let me keep this as it is. So 2 root t dt minus, and similarly I can write this as 1 by 2i integral 0 to infinity e power minus it divided by 2 root t dt, right? 2 root t dt. Sorry, this will be 2 times root t, right? This is root t. I'll just make it clear. Yes, this is 2 times root t dt. So 2 times root t dt, right? Now we will evaluate this 2 integral to find the value of this integral. So what we can do is I can take this 1 by 4i outside, right? So I can take 1 by 4i outside, because here we can take this 2 outside, here I can take this 2 outside, so therefore I can take 1 by 4i outside. So we'll be left with integral 0 to infinity e power it divided by root t dt minus integral 0 to infinity e power minus it divided by root t dt. So what we will do is we will call this integral to be equal to I1, we will call this integral to be equal to I2, call this as equation number star, right? Now we will find I1 and I2, and then we will subtract this to find the value of this integral, right? So far so good. So we have substituted and we have converted this in terms of t, and I have written sin t to be equal to e power it minus e power minus it divided by 2i. So and then I have expanded this, right? Yes. Now we will find the value of this integral I1. So we have I1 to be equal to integral 0 to infinity e power it into 1 by root t dt. Now we're going to make use of the previous method. So what is the previous method? We know that L of f of t is equal to e power minus st f of t dt, right? Sorry, L of f of t is equal to integral 0 to infinity e power minus st f of t dt. This is what we applied in the previous problems, right? Now I'm going to write this as integral 0 to infinity e power minus it into f of t dt, right? So I'm writing this I as minus of minus I, just to bring in this pattern, right? Just to bring this pattern. So now we can use this method here. So integral 0 to infinity e power minus st f of t dt. So this is same as L of f of t. In that you need to put s to be equal to minus I, right? Very easy, right? This is what we did in the last 6 problems. So I'm converting this to be e power minus st f of t dt. This is same as L of f of t. This is equal to capital F of s. So in L of f of t, you need to replace s by minus I, right? When you compare this and this, we have s to be equal to minus I, right? Yes. So this will be, now you find the Laplace transform of 1 by root t, and then you need to put s to be equal to minus I, right? Yes. So let us call this as, okay, now you will find the Laplace transform of, now what is the Laplace transform of 1 by root t? You already found this, right? What is Laplace transform of 1 by root t? This is same as Laplace transform of t power minus 1 by 2, and we know that I have already given this formula, right? So in the very first video, L of t power n is gamma of n plus 1 by s power n plus 1 if n belongs to real number and n greater than minus 1, and it will be equal to n factorial by s power n plus 1 if n is equal to whole number. So here n is equal to minus 1 by 2, which is a real number greater than minus 1. So the formula will be gamma of n plus 1 by s power n plus 1, right? So this will be gamma of n plus 1 divided by s power n plus 1, where n is equal to minus 1 by 2, right? So you replace this, so this will be gamma of minus 1 by 2 plus 1 divided by s power minus 1 by 2 plus 1. This will be gamma of 1 by 2 divided by s power 1 by 2, and we already proven, right? Gamma of 1 by 2 is root pi divided by root s, right? Root pi divided by root s. So therefore this is the Laplace transform of L of 1 by root t. In that you need to put s to be equal to minus I, right? So put s is equal to minus I, because then only we will have I1. So therefore my I1 will be root of pi divided by root of I, right? Now you always you make use of root I. Say root I will be equal to, so root I will be equal to that is square root of complex number. This will be write on the formula for root I. So root I will be equal to s is equal to minus I, right? So this will be root of minus I. This will be root of minus I. So therefore this will be equal to root of minus I is this is 1 by root 2 minus 1 by root 2 into I, right? So square root of a complex number that you come across in 11th and 12th itself. I'm not going to write on the formula for that. You just remember the root of minus I is 1 by root 2 minus 1 by root 2 into I, right? Now this will be equal to, so if I take this 1 by root 2 outside, if I take 1 by root 2 outside, so we'll be having root pi divided by, so if I take 1 by root 2 outside, we'll be having this as 1 minus I. So this is the integral value of, if not, you can also write this as root 2 into root pi divided by 1 minus I, right? If you take that to if you take that to that side, so we'll be having this to be equal to 1 minus I. This is the value of I1. Now similarly, you need to find value of I2. Very easy, right? Same as this. The only thing is here we need to put s is equal to plus I, right? Because I1 is integral 0 to infinity e power it root t dt. Here everything is same. Here you have put an s to be equal to minus I. Here we need to put s to be equal to plus I. That's it, right? So we will find I2 now. Now similarly I2 will be equal to integral 0 to infinity e power minus it into 1 by root t dt. So again I'm going to compare this with integral e power minus st f of t dt 0 to infinity. This is same as L of f of t. So compare this, you put here you compare, we have s to be equal to I. So just find Laplace transform of 1 by root t and then you put s to be equal to plus I, right? There you put s to be equal to minus I, because when you compare this with the obtained, you can see here my s is equal to minus I, right? E power minus st, s is minus I, but here we have s to be equal to plus I. So we know we already found this L of 1 by root t, right? So L of 1 by root t we already know, so which is equal to root pi divided by root s, right? Because same L of 1 by root t is root pi divided by root s. So this will be root pi divided by root s. So in that you need to put s to be equal to I. So therefore we will be having this to be equal to root pi divided by root of I, and I am going to write on the formula for root I. So root of minus I is 1 by root 2 1 minus I. This will be 1 by root 2 1 plus I, right? So remember these two formulas. So this will be root 2 into root pi divided by 1 plus I is the I1 and I2 values, right? So call this as equation number 1, call this as equation number 2. So we have found I1 and I2. So remember root of I is root of I value is 1 by root 2 1 minus I, and the root of plus I is 1 by root 2 1 plus I, right? Remember these two formulas that you can easily find using square root of a complex number that you come up at school level, right? So therefore from star we have, right? Therefore from star we have, so we need to evaluate integral 0 to infinity sin t into, so what we need to do, we need to evaluate integral 0 to infinity sin t 1 by 2 root t dt, 1 by 2 root t dt, right? 1 by 2 root t dt. This is equal to 1 by 4i of I1 minus I2. So this will be 1 by 4i of, so I1 is root 2 into root pi divided by 1 minus I, minus I2 is root 2 into root pi divided by 1 plus I, right? You can see I have just substituted I2 is root 2, sorry, this is root pi, root 2 root pi divided by 1 plus I, and I1 is root 2 root pi divided by 1 minus I. So just take 1 by 4i, just take root 2 root pi outside. So we'll be having 1 minus I minus 1 by 1 plus I, and just take LCM here. So this will be equal to 1 by 4i into root 2 into root pi. Now if you take LCM, this will be 1 plus I minus 1 plus I divided by 1 minus I into 1 plus I. So these two will get cancelled. So we have this to be equal to 1 by 4i root 2 into root pi into, so 2i divided by a plus b, a minus b, right? So a square minus b square, so we'll be having a square minus b square, right? A square minus b square. So a is 1, b is I. So you can see this 2i, this we will be having 1 2 here. So we'll be having root 2 divided by 2. Here we'll be having root pi. Here we'll be having again 1 by 2 here, right? Because I square is minus 1. So we will be left with root 2 divided by 4 into root pi. So I can write this root 4 as I can write this as root 2 divided by 2 into 2 into root pi. So root 2 divided by, I can write 1 root 2 as root 2 into root 2 into 2. I cancel these two. So we'll be left with pi by 2 root 2, right? We'll be left with pi by 2 root 2. This is the required answer, right? We'll be left with root of pi divided by 2 into root 2, or I can also write this as 1 by 2 root of pi by 2, right? So I can combine this. So this is one we need to prove, right? 1 by 2 root of pi by 2. So don't think that it is big, it is very easy. So we just need to prove this integral 0 to infinity sin x squared dx. This is same as integral 0 to infinity sin x squared dx, right? So what we have did is we have substituted this, and then we have written sin t to be equal to e power it minus e power minus it by 2i, and then we have splitted this into i1 i2, and i1 i2 I'm just going by the previous approach. So L of f of t, put s is equal to minus I, and I am finding L of 1 by root t, which is gamma of 1 by 2 by s power 1 by 2. Yeah, I have already found this right in the previous itself. We have already found the Laplace transform of 1 by root t, but now again I am doing with the help of the formula and putting s to be equal to minus I, and here s to be equal to plus I. So, and also remember that the root of I is 1 by root 2 1 plus I, and the root of minus I is 1 by root 2 1 minus I, right? Square root of a complex number. So substitute that, you will be getting the answer 1 by 2 root of pi by 2, right? Yes. And this is the, so therefore this is same as, so therefore integral 0 to infinity sin of x square dx is equal to 1 by 2 into root of pi by 2, right? So actually we have found this integral. So this integral is same as integral 0 to infinity sin x square dx, right? Sin x square dx, sin x square dx. So both are same, right? Both are same. So therefore the evaluate this integral is 1 by 2 root pi by 2, right? Yes, we need to integrate 0 to infinity cos x square dx. That is, we need to integrate cos x square dx from 0 to infinity. We need to prove this value is equal to 1 by 2 root of pi by 2, right? 1 by 2 root of pi by 2. So we will start solution. So what I'm going to do is, so we have the integral 0 to infinity cos of x square dx, right? So we will make some substitution now. So put t is equal to x square, differentiate with respect to x. So therefore we will be having dt divided by dx will be equal to 2x. So that means dt will be equal to 2x into dx. That means dx will be equal to 1 by 2x into dt, and we know x is t is x square. That means x will be equal to root t. This will be 1 by root t dt. So therefore we have dx to be equal to 1 by 2 root t dt, right? Yes. Now this integral now will become integral 0 to infinity cos of x square dx will now become, and the limit will not change, right? So even when you put t is equal to x square, when x is 0, t is also 0. When x is infinity, t is also infinity, right? So the limit will remain same. Cos of x square is t, dx is 1 by 2 root t into dt, right? So evaluating the integral cos x squared dx from 0 to infinity is same as cos t 1 by 2 root t dt. Limit is from 0 to infinity. Now I can write, I'm going to write cos t as e power it plus e power it divided by 2 into 1 by 2 root t dt. The previous problem I have written sin t to be equal to e power it minus e power, this e power it plus e power minus it divided by 2. The previous problem I have written sin t to be equal to e power it minus e power minus it divided by 2i. Now I am writing cos t to be like this, right? Obvious, right? Because e power it will be cos t plus I sin t, and e power minus it will be cos t minus I sin t. So if I add this, these two will get cancelled. So if I add e power it plus e power I minus it, will be having 2 times cos t. So bring this 2 to this side. So we'll be having cos t is equal to e power it plus e power minus it divided by 2. Let us keep all the term as it is, right? Yes. Now what we can do is we just take this 2 outside. So we will be having this to be equal to 1 by 4 integral 0 to infinity e power it plus e power minus it divided by root t dt, right? Again split up this integral. So we will be having this as 1 by 4 integral 0 to infinity e power it divided by root t dt plus integral 0 to infinity e power minus it divided by root t dt. So let us call this integral to be equal to I1. Let us call this integral to be equal to I2. Call this as equation number 1. So what we will do is we will find the value of these two integral and then we will substitute back in equation number 1 to find the value of integral cos 0 to infinity cos x square dx, right? Yes. So what is I1 now? So we have, so what is I1 now? So I1 is equal to integral 0 to infinity e power it into 1 by root t dt, right? 1 by root t dt. So again I'm going to make use of Laplace transform method, that we know that L of f of t is equal to integral 0 to infinity e power minus st f of t dt. This is same as capital F of s. Now when you compare this, so I'm going to write this as integral 0 to infinity e power minus I into t. So f of t is 1 by root t dt. So just compare this and this, integral 0 to infinity e power minus st f of t dt. So this is equal to L of f of t. So L of f of t is 1 by root t. In that you need to put s to be equal to minus I, because when you compare this and this, instead of e power minus st we have e power minus it. That means you find L of f of t, in that you put s to be equal to minus I. That will give you the integral value of I1, right? Yes. Now we know that what is L of 1 by root t, we already found, right? This will be equal to root pi divided by root s, right? Root pi divided by root s. So in that you put s to be equal to minus I, right? So why L of 1 by root t is root pi divided by root s? We already know, right? So you can see, okay, if you want I can also tell why L of 1 by root t is root pi divided by root pi s. Actually we have put this many times, right? Okay, no problem. So I can write this as L of t power minus 1 by 2, right? If I take this, I can write this as t power minus 1 by 2, and this is equal to gamma of n plus 1 divided by s power n plus 1 L of t power n, if that n is a real number greater than minus 1, right? So you can see in the very first video, L of t power n is gamma of n plus 1 divided by s power n plus 1 if n belongs to a real number and n greater than minus 1. We have n is equal to 1 by 2, which is a real number, and that number is greater than minus 1 also. We need to make use of this formula. If that n is a whole number means we will be using the formula n factorial by s power n plus 1, right? So instead of n you put minus 1 by 2. So this will be equal to what? Gamma of minus 1 by 2 plus 1 is 1 by 2, minus 1 by 2 plus 1 is 1 by 2. So we know that gamma of 1 by 2 is root pi. S power 1 by 2 is same as root s, right? Very easy. Now you put s to be equal to minus I. So this will be equal to root of, this will be equal to root pi divided by root of minus I, right? And you just remember the formula for root of minus I. This is 1 by root 2 of 1 minus I, right? In the previous class, I have given you the formula for root I and 1 minus root I, right? So you just go through the previous problem, that is in the previous video. I have given you the formula for root I and root of minus I, right? So you can see root of minus I is 1 by root 2 1 minus I, and the root of plus I is 1 by root 2 1 plus I. So these are the elementary formula that you come across in 11th standard itself, finding the square root of a complex number. Now, I'm not going to do that elaborately. So as of now, you remember this is equal to 1 by root 2 into 1 minus I is the square root of minus I. So if I take this root 2 to this side, to the root 2 to the numerator, we'll be having root 2 into root pi divided by 1 minus I. This is the value of I1, right? Now similarly, what we need to do, we need to find the I2 integral now. So what is I2? I2 is, here I1 is e power it root t dt. I2 is integral 0 to infinity e power minus it divided by root t. So we will do that now. Yes. So I2 is integral 0 to infinity e power minus it by root t. Okay. Now we will find I2 now. Now I2 is equal to integral 0 to infinity e power minus it into 1 by root t into dt. This is already it is of the form integral 0 to infinity e power minus st f of t dt. This is equal to L of f of t. This is same as capital F of s. So you can see already we have e power minus st. So this is equal to L of f of t. So L of 1 by root t. In that you need to replace s by I, because I is I, sorry, you replace s by I because s is I here, right? E power minus st. So here s is equal to I. And we know that L of 1 by root t is, already we know this value, which is root pi divided by root s. In that you need to put s to be equal to I. So this will be equal to root pi divided by root of I. And I have already given you the formula for root of I, which will be 1 by root 2 of 1 plus I, right? 1 by root 2 of 1 plus I. So call this as, okay, let me do like, let us take this root 2 to the numerator. So we'll be having root 2 root pi divided by 1 plus I, call this as 2. This is the value of I2. Now we need to find the Laplace. What we need to do? We need to evaluate. Okay, we need to substitute in equation number star, right? We need to substitute in equation number star. So we will be having, so from star we have, so from star we have, so integral 0 to infinity sine of x square dx will be equal to before I1 plus I2, right? I1 plus I2. So this will be equal to 1 by 4, and the value of I1 is root 2 into root pi divided by 1 minus I, and this value of I2 is root 2 into root pi divided by 1 plus I, right? So I can take root 2 root pi outside. So we will be having this as 1 by 1 minus I. This will be 1 plus I, right? Now this will be 1 by 4 root 2 root pi. Now if we take LCM here, so we will be having 1 plus I plus 1 minus I divided by, so a plus b, a minus b, so a square minus b square, right? And this will be equal to, so 1 by 4. So here these two will get cancelled. So we will be having root 2 root pi into, so 1 plus 1 is 2 divided by, and again I square is minus 1, so 1 minus half minus 1 will be plus 2. So these two will get cancelled again, right? These two will get cancelled again. So 1 plus I plus 1 minus I, so these two will get cancelled. 2 by a square minus b square, so these two will get cancelled. So we'll be having root 2 into root pi divided by, I can write 4 as 2 into 2, and this will be root 2 into root pi divided by, I can write 2 as root 2 into root 2 into 2, right? We already have 1 2, I'm writing 1 2 as root 2 into root 2, so these two will get cancelled. So I can write this as 1 by 2 into root of pi by 2. I'm just combining these two roots. So root of pi by 2 into 1 by 2. This is what we need to prove, right? So we need to prove integral, this is cos x square, right? Sorry, it is not sine, it is cos. Cos of x square dx will be equal to 1 by 4 I1 plus I2. That is what we need to prove, right? So integral cos of x square dx is 1 by 4 I1 plus I2. This is the required result we need to prove, right? Very easy problem. This is similar to the previous problem. In the previous problem we have proved integral sine x square dx limit from 0 to infinity is 1 by 2 root pi by 2. So here we need to prove integral 0 to infinity cos x square dx is 1 by 2 root of pi by 2. Same answer. Even if you have cos square or sine, even if you have sine or cos, we will be getting the same answer. So we have substituted this, and then we have written cos t as e power it plus e power minus it by 2, and then we have found I1 and I2, and then we have substituted those I1 I2 in the equation number star, right? Equation number star is integral, this is equation number star, right? Integral 0 to infinity cos of x square dx. So cos of integral 0 to infinity cos x square dx is 1 by 4 I1 plus I2, sorry, it is cos, right? Therefore we have proved that, therefore integral cos of x square dx limit is from 0 to infinity is equal to 1 by 2 root of pi by 2, right? This is what we need to prove. So we move on to the next subtopic, which is the last subtopic on Laplace transform, which is the Laplace transform of integral, right? We're going to find the Laplace transform of the integral, right? So far for the last 5 to 6 videos we have been evaluating the integrals using Laplace transform. Now we're going to find the Laplace transform of the integral itself, right? We're going to find the Laplace transform for this integral. So if L of f of t is equal to f of s, then Laplace transform of this integral 0 to t f of u du is equal to 1 by s into f of s, or 1 by s is into L of f of t, right? This is the formula to find the Laplace transform of the integral, right? Yes. Now we'll straight away get into the problem. So when we do problem, it will be easy for you, right? Yes. Problem 1. So find the Laplace transform of, find L of integral 0 to t, right? Integral 0 to t e power t sin t divided by t dt, right? So you can see we need to find the Laplace transform for this integral, right? Laplace transform for this integral. Now we're going to make use of this formula now, right? L of integral 0 to t some f of u du is equal to 1 by s L of f of t, right? So I'm going to make use of the formula. So solution. So we know that L of integral 0 to t f of u du. So here f of u du is e power t sin t divided by t into dt. This is equal to 1 by s into f of s, or 1 by s into L of f of t. So my f of t is here to be e power t sin t divided by t, right? So call this as equation number star. This is the required answer, but we don't know Laplace transform of e power t sin t by t, right? So far you can see the difference between the last and this subtopic. The last topic is we have been evaluating the integral, right? Here we are finding the Laplace transform of the integral. So for all the previous videos, the limit will be from 0 to infinity. We have evaluated that integral. Now we are going to the Laplace transform for this integral. The limit is from 0 to t, right? Now we will find the Laplace transform for we will find the Laplace transform of e power t sin t dt, right? So now we will find Laplace transform. So now we will find Laplace transform of e power t sin t divided by t, and then we'll substitute back in equation number star, right? Yes. So we need to find Laplace transform of e power t sin t divided by t, and we know that L of 1 by t f of t, right? So if you haven't watched the previous video, go through that. So L of f of t by t is equal to integral s to infinity L of f of t into ds, right? Because we know that L of 1 by t f of t is equal to integral s to infinity L of f of t dt, right? This is the Laplace transform, that is the effect of division of f of t by t when finding Laplace transform, right? Yes. This will be equal to integral s to infinity L of f of t. So here my f of t is e power t sin t, right? L of 1 by t f of t. So this will be e power t sin t into ds. Now what is L of e power t sin t? I need to make use of shifting property here. So this will be integral s to infinity. So you just find L of sin t, and then you need to replace s by s minus 1 ds, right? Already we have ds, you know, shifting property, right? L of e power at f of t is L of e power at f of t is, you find Laplace transform of f of t, and then you replace s by s minus a. So here a is equal to 1, right? S will be equal to, now I find Laplace transform of sin t. So this will be integral s to infinity. So L of sin t, right? So L of sin t is a square divided by s square plus a square. So this will be integral s to infinity 1 divided by s square plus 1. In that you replace s by s minus 1 into ds. So this will be integral s to infinity 1 by s minus 1 whole square plus 1 ds, right? So L of sin at is a by s square plus a square. So we'll be having this to be equal to, so L of sin at, right? L of sin at is a by s square plus a square. So here a is equal to 1. So therefore this will be equal to tan inverse of s minus 1. Limit is from s to infinity, right? Upper limit is, what is the integral? Integral 1 by 1 plus x square is equal to tan inverse of x. So instead of x we have s minus 1. So when you apply upper limit, we'll be having tan inverse of infinity minus lower limit will be tan inverse of s minus 1. So therefore this will be equal to tan, this is pi by 2 minus this is cot, okay, let us keep this as it is, pi by 2 minus tan inverse of s minus 1. So we know that pi by 2 minus tan inverse of x is cot inverse of x. So I can write this as cot inverse of s minus 1, right? This is the required value of this is the required value of L of f of t. But remember, we need to find what is equation number star. Now star becomes, this is star, right? So L of integral 0 to t e power t sin t divided by t dt is equal to 1 by s into L of e power t sin t divided by s. So we will substitute that value here. So therefore from star we have L of integral 0 to t e power t sin t divided by t dt, right? This is what we need to evaluate. So integral 0 to t e power t sin t by dt is equal to 1 by s into L of f of t. This is our star. So as of now we have found L of f of t, which is cot inverse of s minus 1, right? So therefore the Laplace transform for this integral is cot inverse of s minus 1 divided by s is the required Laplace transform for the given function, right? We need to evaluate, we need to find the Laplace transform of 0 to t e power t sin t e power t sin t by t dt. So we know Laplace transform this integral is 1 by s L of f of t. So we have found this L of f of t, that is we have found Laplace transform of e power t sin t divided by t. After that we need to substitute in star, so that answer will be cot inverse of s minus 1 divided by s minus 1, right? So we'll continue. second problem from the next class, right? Thank you. So problem number 2. So find the Laplace transform of, so find L of, so we need to find the Laplace transform of integral 0 to t e power minus t into cos t dt, right? We need to find the Laplace transform of the integral, right? Yes. So we know that solution, so we know that, so L of integral 0 to t f of u du, right? So this will be equal to, so this will be equal to 1 by s into L of f of t, right? This is the integral formula that I have given in the previous class, right? Now therefore we need to find L of integral 0 to t e power minus t cos t dt, right? So this will be equal to 1 by s into L of f of t. So my f of t is e power minus t cos t, right? Instead of f of t we have in terms of t, no problem. This will be equal to e power minus cos t dt, right? This is our equation number star. So now we'll find the Laplace transform for this e power minus t cos t, and then we will substitute in equation number star, right? Yes. Now we will find the Laplace transform of e power minus t cos t, and then we substitute in star. Now what is L of e power minus t cos t? I'm going to make use of shifting property. So this is same as L of cos t, and then you need to replace s by s plus 1, right? Because L of e power minus at f of t is equal to L of f of t. In that you replace s by s plus a. So what is L of cos t? It is s by s square plus 1. In that you need to replace s by s plus 1, right? So therefore this will be equal to, so you need to replace s by s plus 1. So you'll be having s plus 1 divided by s plus 1 whole square plus 1 is the Laplace transform for e power minus t cos t. Call this as 1. Now put 1, substitute 1 in star, right? So substitute 1 in star. So we will be having this to be equal to, so substitute 1 in star. So therefore L of integral 0 to t e power minus t cos t dt, will be equal to 1 by s into L of f of t. So that is L of e power minus t cos t. So this will be equal to s plus 1 divided by s plus 1 whole square plus 1. So therefore this will be equal to, so if you multiply s inside, we will be having this to be equal to s plus 1 divided by s into s plus 1 whole square plus 1 is the required Laplace transform for the given integral, right? For the given integral, this is the required Laplace transform, that is L of 0 to t e power minus t cos t dt will be equal to this, right? So we'll move on to last problem, and then we'll wind off Laplace transform. After that we'll be moving on to inverse Laplace transform. So last problem that we're going to do is find the Laplace transform of integral 0 to t sin t divided by t dt, right? Yes. So again I'm going to make use of integral formula. The solution, so L of integral 0 to t sin t divided by t dt is equal to 1 by s into L of f of t. So you take this as f of t. This is 1 by s into L of sin t by t, right? This is the required Laplace transform, but we don't know L of sin t by t, right? Yes. Now we will find that value. Now we will find the L of sin t by t, right? Yes. Now we will find Laplace transform of sin t divided by t, right? So we know that L of 1 by t f of t will be equal to integral s to infinity L of sin t dt, right? Because Laplace transform of 1 by t f of t is equal to integral s to infinity L of f of t into ds, sorry, this ds into ds, right? Yes. So what is L of sin t? This will be s to infinity, will be 1 by s square plus 1 into ds. So therefore this will be equal to 1 by 1 plus x square. So therefore this is tan inverse of yes, right? So therefore this integral value is tan inverse of x. So therefore this will be equal to, therefore this is equal to tan inverse of s. Limit is from s to infinity. So upper limit is tan inverse of infinity is pi by 2 minus tan inverse of s. So I can write this as cot inverse of s, right? This is the Laplace transform of sin t by t. Now substitute in star. So substitute in star. So we will be having this to be equal to now substitute in star. So therefore L of integral 0 to t sin t divided by t dt will be equal to 1 by s into L of f of t, which is cot inverse of s. So therefore the required Laplace transform will be cot inverse of s divided by s, right? Cot inverse of s divided by s is the required Laplace transform for the given integral. So far we have solved 3 problems as of now based on how to find the Laplace transform for the given integrals, right? So that's it. So actually we have completed Laplace transform, that's it. So from next video we'll be moving on to inverse Laplace transform. That we will continue from the next class, right? So in Laplace transform, first we have given you I have given the basic formulas. We have derived all the basic formulas. After that we have moved on. We have seen many properties like shifting property. What is the effect of multiplication of t power n f of t? What is the effect of division of t by f of t in finding Laplace transform? And then we have seen Laplace transform for periodic function. And then how to evaluate the integral using Laplace transform. And the last we have seen Laplace transforms for integral. So we completed Laplace transform. From next video we will be moving on to inverse Laplace transform, right? Yes, thank you. We'll see you next class. Thank you, all the best.